Kia ora. My name is Michael Reweri Fulson, and I am the tech guy behind the whole of this stream thing, this broadcast today. Anyways, here in New Zealand, in Aotearoa, the Māori here have a bit of a tradition where we do a karakia or a blessing before any large event like this, just to make sure everything goes right, just to get the right feel. Anyways, the words are right here on the screen with me, so I'm going to read them out, and you can read them along with me if you want. Haki roto, haki waho. Kia tau te mauri e kokiri nei. I ngā piki me ngā heke ko te rangi Māori e tāku e rapu nei. Tihei mauri ora. The best of health to you all. I hope you enjoy the show. Here's Zach to introduce and to kick it off.
Kia ora koutou, and welcome to AWS Community Day Oceania 2026. I'm Zach, an AWS hero based here in Aotearoa, New Zealand. It's an absolute privilege to open our second ever virtual edition. We are thrilled to have you stream with us live globally on multiple platforms. This event is 100% by the community for the community. Today isn't about sales pitches, it's about real-world engineering. We have incredible lineup covering platform engineering, Gen AI, security, and more. We are here to share the wins and the failures and the lesson learned while building in the cloud right in our own corner of the world. An event this size doesn't happen magic. I want to give a massive thanks to our sponsors for keeping this event free for everyone. Huge thanks to our platinum sponsor, AWS, our gold sponsors, Datacom and Deloitte, and our silver sponsors, Mantle Group, CyberCX, and MongoDB. Also, our community partner sponsor, Feedback Fedora. I also want to recognize the incredible organizing committee who volunteered months of their time. A huge shout out to Paul Dunlop, Casey Orr, Chamil D. Alvis, John Ahera, Michael Reverie Thosen, and Ramzami Arunachalam. You guys are the engine behind this stream. We want this to be interactive. Use the chat, ask our speakers tough questions, and connect with each other. My name is Zach, and it's time to get started. Let's head into our first session. Happy building, everyone. Thank you.
All right, good morning, everyone. It's great to have you here on this AWS Community Day Oceania and to kick off the first session for the day. So it's great to have you all here, no matter where you are around Oceania or around the rest of the world. So as a quick introduction, hi, I'm Stephen Sennett. I'm part of the team here at V2AI over in Australia, Australia's largest growing AI consultancy. And today, I'm here to talk to you a little bit about something we call the Builder's Moat. And I'm going to tell you about this as a bit of a start to the day. But first of all, something important. I'm an Australian and we like our caffeine first thing in the morning. Very much essential because I promise you it is 7 a.m. here. And for us, it's still very early. And hopefully for where you are, you're starting out your day well as well. But without any further ado, let's get into this by talking about the builder's moat. Now, as a quick thing before we start off, I do feel like, especially here in Oceania, I do want to pay acknowledgement to the traditional custodians of the many lands upon which we all come from this morning. And so for me, that's the Wurundjeri people of the Kulin Nation here in Australia. Of course, we have people here from across New Zealand as well, from all around Australia, and from all around Oceania. So wherever you are, whatever traditional custodians of land you come from as well, I pay my respects to them, and I'm very much looking forward to sharing this morning with you and kickstarting this day. Now, when we talk about the builder's moat, I kind of want to come back to something here, and that comes back to our caffeine. Very important. It's also a chance for us to deliver a few disclaimers about this today. So a couple of months ago, I was traveling for work, and I had the chance to catch up with an old friend who I hadn't seen in a very long time as well. This picture might not actually be from this. We see a lot of the images I have through today are going to be generated by generative AI. Shocking, I know. Now, when I caught up with this friend of mine, it was a very fortunate thing because we hadn't had a chance to see each other since before COVID even, so it's been quite a while. And my friend, she's a fairly senior lawyer at a very big name firm. Again, I'm not going to be mentioning particular names or technologies or customers here today. All names will be changed to protect the identities of both the guilty and the innocent. So with that in mind, my friend and I, we obviously have come quite a bit over the last few years since we last saw each other in person. So with her coming from her background in law and me coming from my background in tech, I think I was still probably a sysadmin last time we talked. And, things have changed a little bit since then. The interesting thing is that while we've both become more senior in our roles, we've also had a lot of crossover as well, where I've ended up having experiences close to her profession and she's had experiences close to mine. And we spent a little bit of time chatting about this. So from my side, a couple of years ago, I became a justice of the peace here in Australia. Fair note, that doesn't mean I'm a lawyer, but we were talking about some things around the execution of wills, around a whole bunch of stuff like that, that is probably interesting to a very tiny portion of the population. And look, if you're interested in talking about all kinds of things about that, I am very happy to discuss at some point in the future. But the interesting one was also talking about her and her experiences recently, because she's gotten more into tech and, of course, like everyone now, AI. So she's gotten deeper into this world as well. And with this, she's been building some of her own tools. And so something that she built was a bit of a tool to go through a whole bunch of different contracts and documents that she had, to break them down and to extract some dates from them. One of the big things for a lot of the sort of work that she does nowadays is around big contracts with lots and lots of dates. So going through these documents and trimming out all the dates from them. And to do it without AI either, because of course, these things are very sensitive. So it happened all with regex and Python. And now thinking about that as well, there's quite a lot of magic that comes into this. The fact that, somebody who doesn't really have a background in tech can still build stuff like this. And so with that in mind, the question kind of came up. What stops her from doing my job or me from her job? In this world of AI, where, both of us are using AI for a lot of different things, what's stopping anyone from doing anyone else's job? What makes a difference to any of us here? And this kind of comes back to the whole situation that we have at the moment around what gives us defensibility in our roles, what makes our roles a bit more unique, and especially for people coming into the industry, what are the things that we should be knowing about this? Now, if we think about where builders used to be, builders used to occupy a very unique spot. If you want to create software, you needed a developer to do that. That was the thing. Only developers knew how to program. That was the world that we were in. Of course, in the last few years with the world of magical AI agents, now the thesis, everyone can be a developer. That's the thesis of the last few years. Sure, lovely. The interesting thing is that on top of that, developers can use these tools as well. Now, I can tell you who's going to be the most useful at using these tools, but first, another detour as well. I was talking to a friend a little while ago, another friend who's actually a personal trainer, who trains a lot of their own clients and things like that. And again, is a bit of a nerd. So they want to build their own tool for kind of managing their personal training clients. And so they came up with this sort of thing. Again, all names and everything redacted. They very much just sat down and did probably about a dozen prompts worth of stuff to come up with a web app, a backend, a database, the means to track the training that their clients were doing, all the different exercises across time and everything like that. And that was kind of wild because it's like, if I look at this, I probably would have spent AI, I probably would have spent maybe a week or something making something look this pretty. Again, I'm not a front-end developer, so this is not my backyard by far. But you can see why these sorts of things have become a lot easier. But the thing is that this also helps us as well. If you're from a technical background, you can also build stuff like this a lot faster too. But if we think about people who are not technical, who are able to build stuff now, I go back to this tweet from about a year ago now. And this one was around someone who built their own SaaS company with really no technical experience. They just sat down with cursor, started vibing, and then bish, bash, boosh. Next minute, they've got their own SaaS platform and they decide to do the whole build in public thing. Cool. Interesting. If you look there, we can see about 100,000 views and 600 or so likes. That's cool. We scroll forward about 2 days into the future. Turns out that this approach of building without really having any technical skills has a few drawbacks. In this case, there were people who were borrowing the API key straight out of the app, people who were breaching things, people who were making, holes into the side of the product and using it in all kinds of malicious ways. And of course, he says there, I'll stop sharing what I'm doing because people are just being weird. And realistically, we know that, if there's a target opportunity, somebody somewhere somehow is going to take advantage of it. Just because we are small, just because we are from an industry that doesn't have a lot of money, anything like that, doesn't give us any protection. And if we look at this as well, we come back to this piece here. I'm not technical. I don't know what's going on here. And again, I think this is not necessarily a bad thing. I think it is wild that we live in an age where somebody who describes themselves as not technical is able to start building stuff like this. But that's where we are at. And now if we think about this, about what we actually need is the ingredients for a startup. If anyone here has ever done a startup before, you'll know that there's a lot of polyglot skills that come into this. It's not just one thing. If we look through this list, you kind of go from having your idea of the business through the value proposition, through everything around the architecture and building out the code, etc. There's a lot of stuff that you need to do here. So if we look at this though, over the last few years, things have started to change. Because nowadays, we look at especially those last couple, AI is now very mature at building those things. We've shifted a lot in that direction now. If we look at some of the higher level ones, those ones are still developing things like architecture and obviously security, design, a sense of what the product should look like and should do. AI is getting better at that, but not quite there yet. Those bits at the top of the funnel, though, are still intrinsically human. Things like having a good business idea, having a strong value proposition, etc. Those are still intrinsically requiring human intelligence. That's not gone anywhere. And that's not going to be going anywhere anytime soon. Now, you'd say, well, AI can help you with this. Of course, absolutely. But I can't just tell either OpenCode or OpenClaw or any of these other tools, go make me a SaaS product that's going to make money. I mean, I could. I don't imagine it's going to be very good at it, though. So that's where the world that we're kind of approaching now. And if we think about this, if you can explain those top parts of the funnel well enough, if you can explain what your business is, what's meant to do, what the experience is meant to be for the user, then the rest of that stuff at the bottom, we're now living in an age where you, whether you're a non-technical startup founder or whether you're an enterprise software engineer, a lot of that stuff can kind of move along a lot faster at speed. Now, of course, those bits in the middle, whatever. We let the AI figure out what the architecture should look like, security, whatever else. Realistically, if I am a non-technical founder, do I care probably so much as to whether this is using React or Vue or Angular? Do I care what type of database it's using? Probably not. But they're probably still pretty important decisions. And there's probably reasons we want to choose a couple of things instead of other things, isn't there? We know this because we come from a technical background. The complexity to everyone else is kind of lost, though. This has kind of brought forward a bit of an idea now. And that's the idea that the hottest programming language at the moment is English. Now, this isn't a new idea either. This tweet came from Andrej Karpathy, who's one of the godfathers of the modern AI era. And he posted this a bit over 3 years ago. Again, if we look at that date, January 2023, it's quite wild to think about this, but it was only about 2 months prior that we first saw the rise of ChatGPT, with GPT 3.5 powering it. Now, I don't know about you, but I can remember trying out ChatGPT in the earlier days, telling it write me a Python script, copy, paste, syntactical errors everywhere. It didn't work. It was not very reliable. This was pre the agentic loop. This was pre trying to build linters into the process. You copy and paste it just didn't work. So if you think about this, the idea that English was a programming language at the time was an especially hot take. And while it's still a bit of a spicy take today with a lot of opinions behind it, the view has probably changed a bit. And the thing is, we've been continually getting ever so closer to this kind of thing being a reality. Now, you can say English isn't deterministic. There's issues with building large systems with all this, and that's true. I can't say that we would be building something straight with English and never compiling it to another language. I can't personally see that. But that said, things are continuing to shift around. And when we think about this and we're thinking about, we can't build large complex systems of rules with deterministic values with just natural language. The thing is, we kind of can. We've been doing it for about 4,000 years now. There's a particular thing it's called. That's law. The interesting thing about law is that law is an attempt to codify everything that we have, all of our laws, all of our societal norms and values, into a single series of codified things built in natural language. We think about an example here. All that law really is our attempt to codify our rules into a deterministic way. But here's the thing. Literally, our entire structure of government in the West is built around this concept of natural language. If we think about it, there are branches of the government for executing law, interpreting it, and for writing it. If we think about this, the judiciary in most Western governments is really built around that concept of determining and interpreting law. Because if we think about the interpreting of law, effectively the computation behind this, that is an entire branch of our government. And it's quite wild to think about the amount of complexity in there. You would think that with this, we would have completely figured out law by now, because large language models are ultimately natural language machines. You would think that with enough context, we would have solved law by now. It would be a solved problem, both for creating things, for creating law cases, and that sort of stuff. We think lawyers would be the first ones out the door. But we know that law still can't work without lawyers. It's not possible. Not in any kind of near-term future. There is a lot more to this than you could ever have just with AI. Not possible at this stage. And just the same, building still can't work without builders. But I want to give a bit of an example here to kind of dive into this further, because law, as far as using natural language goes, is a lot further along than we are. But still, if you remember a few years ago, Do Not Pay, that company that said, they were the world's first robot lawyer, they also had I just remember a big promo for like, hey, if you argue a case before the United States Supreme Court, put some AirPods in your ears and say everything that our AI tells you, we'll give you $1 million. Bad idea. Needless to say, they were eventually slammed into the dirt by the FTC and forced to pay, I think it was like a $200,000 fine or thereabouts. On top of that, AI is still being used really recklessly in that sector of the world. And this was one fairly recently with about $96,000 worth of sanctions because, again, reckless, unbounded use of AI. So law as a profession is still very much safe. But at the same time, things are still changing. We look at Legora, which is a rather, large and growing AI, pardon me, words, still early in the morning. We love that. It's an AI law platform that has currently just passed 100 million worth of annual recurring revenue, which is really big, and about $5.5 billion worth of valuation. So clearly AI is going somewhere in law. The interesting thing is, though, that these kinds of tools are made to help lawyers do their jobs. They are made to kind of be their co-pilot, to help them find the right information, to source the right things, to help them review things. It's made to augment their capability, not to replace them. And if we think about that, that's an interesting kind of parallel to where we are in tech as well. How do we get these kinds of things where even in this domain of natural language where LLMs should thrive, we still haven't gotten the ability to completely do away with lawyers yet? Now, of course, law is actually heavily regulated. The practice of law is something incredibly regulated, which it should be. Very important. But even in cases where practitioners are using AI recklessly, they are still setting themselves in huge trouble from that. You see this just even here. Software development is not. Anyone can be a software developer. All you need to do is start with an idea, deploy some code, and you're well on your way. If we think about this, over the last few years, we've been very deep down the hole of wrapper apps. The idea of having a website that basically just wraps around an AI model, and that was the basis for a startup. If we look at this here, this is a bit of an example of pretty much every system architecture for the last few years. Your nice little web app at the front, a bit of a backend app to tie stuff together, particularly a database and an AI call. And that's fair, but let's reshape this based on its actual importance to the system's outcomes. The LLM usually plays a very outsized impact, has a very outsized role in all of this. And if we look forward a little bit, if we're considering what this looks like, realistically, the intelligence of the app kind of comes down often to just a prompt wrapped by an SDK. In this case, something like the Amazon Bedrock SDK, where you're able to call your foundation models like Claude Sonnet 4.6 through the Amazon Bedrock SDK and feeding the input text to it. So it's very interesting that this is pretty much all that was sitting around these apps for quite some time. There was not a lot of intelligence beyond these. I want to put that pin in our heads for this next little bit. Because one of the tensions we often find in tech when we're looking to acquire a new solution is, should we build it or should we buy it? Now, as a bit of an idea here, we generally should build something if it's, cheaper and easier than having to go out and buy it. Now, do I need to go out there and buy an application to create a bunch of CSVs and upload them to an S3 bucket? No need for that. I can write a script. All good. On the other hand, should I build my own payroll system? No. No. You never, ever, ever want to do that. And I'll explain a little bit as to why. Well, across this whole spectrum, there's a very wide set of options between whether we should build or buy something. This is the foundation of a lot of architecture that we see within large organizations. But something has fundamentally changed this. Could we build our own version with AI? This has changed the calculus for a lot of these decisions, right? Because now the opportunity to build something rather than buy it has started to collapse a lot more. Now, if we think about this sort of stuff where we have a lot of depth to these applications, things that are not easy to replicate. We use that payroll system, for example. Look, a payroll system seems really simple. Track your employees, how much they're earning, track their overtime, and trigger the thing to send them money. Cool. Thing is, there's a lot of complexity in those applications that you don't really see. Things like employment laws, things like overtime and penalties and FBT and union agreements and many things you do not want to be caught on the wrong side of. There's a lot of defensibility for those applications because they aren't easily replicated, even with AI. On the flip side, if we take my script for a bit of an example, if I tried to make an application to say, generate some S3, like some CSV files and put them up into S3, anyone can do that. I could probably do that. I could still do that without AI in Bash, PowerShell, Python, Go, maybe one or two others. I could still do that without AI, no problems. there is no real unique value there. It is easy to replicate. And of course, with AI, you could probably zero shot that. You don't even need to spend time actively building. And interestingly, I did want to insert this. I inserted this just this morning. Something another AWS community member built called Death by Claude. Could you replace your entire SaaS platform with a Claude skills file? And so interestingly, when you point Death by Claude back at itself, it realizes it's already dead. So we live in a very interesting time. But if we think about this concept of the depth, this is what we often refer to in more the business world than tech, but the idea of a competitive moat. What kind of defensibility do we have against our competitors? And if we're thinking about this from the kind of SaaS perspective, if we think about this, if we don't have much of a moat, it's because it's easy to replicate our solution, like our S3 files example, where something like a payroll system is a lot harder to replicate. If we build systems that are harder to replicate, high quality systems that can't be replicated easily, that gives us a lot more defensibility in the market. Likewise, if we're not bringing any unique knowledge, that's not great. Where if something brings in that domain knowledge, like employment law and all that sort of stuff, that's a huge upside. In these undefensible applications, the prompt is also the entire process, where for these other ones, it's part of the process. It supports the process. The process itself is not just the prompt. And likewise, in this case, the product really is the model, because all you're doing is wrapping some very basic application, I suppose the opposite, where the product uses the model. There is more to the product than just the model. That's this concept of a moat, of having defensibility, right? Now, as we think about this and as we start coming up towards the end of this, what does this mean for us? What does this mean for us as builders? Because of course, if you're going out there and building a SaaS platform, I want you to succeed. Please do think about this sort of model around not just building something where you can slap a prompt in front of it and chuck a web front end on it. It won't be able to be sustained, especially nowadays where you can just spin up Claude code and build your own version of it, so your customers can. You want to be building with depth. So we come back to this earlier model. If we think about the amount of time that we can spend nowadays writing documentation, doing our infrastructure all by hand, writing our code by hand, there's a bit more of a limited advantage there. I will say, people should still learn how to code. You should still care about how your infrastructure works. You most absolutely certainly should. But you should be guiding it. You should be guiding the architecture. On top of that, you still need to know the underlying pieces, but understanding how those work from an architectural perspective will give you a lot more depth. Likewise, thinking about things like product design. I'll say this, I am not someone who thinks much in this space. I could barely center a div. I'm not a front-end dev. This is not my world. But I should still understand what makes decent product design, decent UX, things that I would never have had to think about a few years ago, because that's someone else's role. I'll never be in that seat. Now I might be. Things have started to change a bit more. And as we come back to this, those ideas, the business idea, value proposition, the GTM, the go-to-market strategy, all still are intrinsically requiring human knowledge and skill, because only our brains are capable of that. AI can help us with that, but we can't offload that at all. That still requires human brain power. Coming back to finally wrap this up. Nowadays, everyone can create stuff. That is not going away. Even as the pricing for large language models and all this sort of stuff continues to adjust, people are still going to be building. That's still going to be there. Now, I might not ever be a front-end dev, but at the same time, I can still go and, press a button on Claude Code and it can go and make some nice little React site to make the ARR go brr. But it's not going to be as good as anyone who actually knows how these things work. I wouldn't know what a good front end looks like realistically or otherwise. Likewise, for my lawyer friend, when we were talking about that script about building out timeframes, she mentioned she kept on poking the AI agent, but there was one thing that never popped up. There was a whole bunch of dates that were missing. And she explained it to me. I was like, yeah, if there's something that's like, you know, the following Tuesday from this event, something will happen. And it's like, you're using regex. It's like, yes. It's like, it won't pick up on that. It can't understand relative dates with just regex. I can know that and intuit that. You probably could too, because you come from tech. You have domain knowledge. You have that much deeper context. That's something there that we still have a tremendous capability for. Our intuition, because we can go forth, think deeply, get creative, and continue digging deep to learn more. Now, with that, I also wouldn't ask AI to write me a contract either, but I'd still get it to write me an email. With that, I do want to say thank you very much for having me here this morning. It's been great sharing the morning with you. Go forth and have a fantastic community day. Enjoy.
Hey everybody, Peter Smith here. Nice to meet you. I am here sitting in sunny Nelson in New Zealand. This is the sunshine capital of New Zealand. I'm very happy to be here today. Just to tell you a little bit about myself, I'm currently a principal engineer at LocalStack, which is a company that does local development tools for AWS. Today I'm going to talk about local development for AWS. And formerly, I was a principal engineer at AWS in Vancouver, Canada. So I have quite a wide background using development tools, working with AWS, and I've been an AWS user for over 10 years now. So let's get started. What I want to talk about today is, firstly, what does local actually mean, right? I think all of us come in with this experience of building our software locally and then deploying it to AWS. But what does local actually mean? I'm going to talk a little bit about that. And then the question of why develop locally. I think many of us have an idea of why we do it, but you'll be surprised, different people have different reasons for developing locally. Then I want to spend the rest of the talk talking about the sort of transitions we've seen in AWS over the last 20 years or so of how we develop locally. So starting with virtual machines with EC2, that was about 2006. How do we develop locally then? And how did it change when we introduced containers? That was around 2015 when Docker became a really important thing. So we changed the way we did local development. And the third phase is really what I call serviceful. It's like serverless, but it's not serverless. It's serviceful is really where you're developing an application that contains AWS services mixed in with your own custom code. And then finally, I'll finish up talking about the future. What I think we need to do to make local development better than it is today, where we can go with that. Okay, so let's start with defining what local development actually means. And you may think that you know what it is, and I certainly thought I knew what it was. But when I started talking to many different people, I'm like, oh, you think it's something quite different. So let's go through the three main definitions that I've heard of. So the first one with local development, you are naturally thinking about checking out your source code onto the computer that's sitting in front of you, the one that you're actually touching. And then you're going to edit that source code, you're going to test it, you're going to compile it, you're going to change it, test it. And that's the edit, compile, run cycle that we're all very familiar with, right? That is something that has to be very, very high performance. You need that instant turnaround time, get your results, come back, fix it, and be comfortable with the code you've made. That's called the inner loop. We're all quite familiar with that. Then when you're ready to share it with other people, you would push it to the outer loop, which is when you do a code review, you may merge it into your mainline, and then you may deploy it to your production environment. And naturally, you're going to get bug fixes, you're going to get requests from customers, and you're going to go through what's called the outer loop. So when we talk about local development, most people kind of think about the inner loop, that focus, where you are focused on typing code into your local machine that is physically in front of you. Well, that's not the only definition, because these days you can actually involve the cloud in your local loop, right? So if you run your IDE and all your development tools in the cloud on like a virtual desktop in AWS, that is also considered local development. You may say, but wait a minute, I'm in the cloud, how is that local? Well, it's the same thing. It's the same tools, the same techniques, the same issues, the same needs for rapid turnaround when you're developing code. So yeah, I think that's fair enough to call that local development. Now, another one, this is a definition that I heard actually quite recently. It surprised me. Some people look at local development as being purely that inner loop, regardless of where you're actually running it. I can do my editing, compiling, and running and testing using AWS services like Lambda and step functions and EventBridge and all of those services. I'm really actually using those every time I make a code change and every time I run my tests. It's not just about deploying to the cloud anymore when you're done. It's not just about saying, hey, we ship to production now. It's everything you do involves it. Now, is that local? Yeah, maybe. Depends who you talk to, right? So some people say, absolutely not. That's in the cloud. That's not local. Other people say, yeah, that is your inner loop. Therefore, it is local. Okay, so fair enough. Three good definitions of what local means. But let's focus on the first couple of definitions. So I want to ask the question next. Why do you want to develop locally? Why do you want to use this first option as opposed to the third option? Why is that important to you? So here are the three reasons that I hear about mostly from the people that I've been working with. So the first one is cost risk. Now, AWS is amazing. You pay for what you get, right? If you want more, you pay more. That's how the cloud works. It's a very, very important concept. But there's always a risk. Now, if you're a developer and you're writing code and you're testing code, that code is not going to be perfect. There might be bugs in it. So you're always going to be a little bit worried that if you're testing in the cloud, let's say you do something wrong. What say you leave an EC2 instance running all weekend or for months, potentially? I've seen that. I've seen EC2 instances running for 6 months and people didn't realize it, right? That's expensive. Or even if you're using serverless, what say you have a Lambda function in an infinite loop and you're just running billions of implications of Lambda? That's going to be expensive, right? So when you're developing locally, there's always this nervousness about, am I going to do something wrong? And am I going to get a really big AWS bill at the end of the month? Okay, that's one definition, or one reason for using local development is that it takes away that concern. If you're running everything on your local machine, you know it's a fixed cost. You're not going to get an out of control bill. The next one is security risk. Now, this is more for, say, enterprises. If you're in the finance or if you're in healthcare industry, you probably know this one really well. There's always a concern that if somebody is developing in the cloud, that they're going to expose themselves somehow to hackers. They'll get the security groups wrong, they'll have a bug in their software or something like that. So a lot of organizations simply say to their developers, I'm sorry, you're not going to develop in the cloud because we need you to run your tests first, the full regression tests. We need you to do security scanning. We need all of those things to be done first before you can deploy your software to the cloud. And if you're in healthcare or finance, you probably know this really well. There are lots of compliance regulations that prohibit you from running in the cloud. So therefore, developing locally is a very attractive thing. In fact, it's necessary. Now, the final reason is deployment speed. If you are doing things locally, it is really fast, right? Now, the cloud is amazing. It's scalable, it's flexible, high performance. But one thing the cloud doesn't do very well is allow you to make code changes quickly. So deploying a change to a Lambda function can take a little bit of time. Whereas if you make the same change on your local machine, it's really fast. So with these three reasons in mind, I want you to think about what it is that's important to you. Now, if you're a manager, maybe the cost risk, because you're the one who has to pay the bill. Developers don't usually see their AWS bill, so they don't really know. If you're a compliance person in a large enterprise company, then the security risk is probably your biggest concern. And for the rest of us developers, deployment speed is probably your biggest reason. So hopefully you can relate to at least one of these reasons, but these are the three reasons why local development for cloud applications is considered really, really important. Okay. So now I want to go through some patterns. I want to talk about some of the things that you would do when you're developing in the cloud. Let's start around 2006. That's when EC2 was released to the world. And suddenly you could now lift and shift your existing software that ran in data centers to the cloud. And you could, within minutes, get a new EC2 instances up and running just by putting in your credit card number. That was amazingly quick. But nothing really changed about software architecture. Software architecture was the same. We didn't overnight just suddenly rewrite our software. So this was called lift and shift. Take your application from data centers, run it in the cloud, everything's exactly the same. Great, easy problem. But what does this mean for local development? Because now you have the situation, I should mention this is still very common. This is not just a 2006 thing, this is something that still happens today. So now you have a situation where you're a developer, you want your development environment that you're working on to be very, very similar to what's running in production. Why? Well, you've probably heard this before. It works on my machine, right? So you don't want a situation where the code runs perfectly on your machine, but as soon as you deploy it to production, it breaks. Or conversely, you don't want a situation where a customer reports a bug and you can't reproduce it on your local machine. So one of the things that's really important about local development is have it as close as possible between your development environment and your production environment. So the way that we did this back in the day was we would have the development machine and the production machine have exactly the same operating system. You'd have Linux and Linux or Windows and Windows or whatever you were doing. You would make sure that you had the same libraries on your development machine that were running in production, the same packages, the same databases, the same web servers, system configuration, and the same directory structure. Everything had to look as similar as possible to production. Now, many of you have probably seen this before. I've seen it over and over again at different customers, different places I've worked as well, is the run book, the 10-page run book. So when a new developer joins the company, they get a brand new development machine to work with. They then have to spend the next couple of days typing in all of these install commands into their machine to install the libraries, the servers, to change the configuration files, and so on. One company I worked at, it took me about 3 days to go through the entire runbook to set up my development machine to get it the same as the production machine so I could get my work done. And this happens every time a new hire joins the company. Every new person has to do this. And guess what? Every time a new person joins the company, they find mistakes in this runbook because development changes, the requirements change, but people keep on forgetting to update the runbook. So this is very common. I would say like 80% of the companies I've been involved with have a runbook of this nature. So what's a good pattern? How do you solve this problem? Well, one is to use configuration management tools. Now, you may not have heard much about these recently, but they were really, really popular easily 10 years ago. Instead of a runbook, you use a tool like Chef or Puppet. And I use Chef a lot, so I'm going to talk about Chef recipes, it's the name. But you basically have a configuration file called a recipe that lists all the services, all the libraries and the packages and everything you need listed in a single file. And then you just run that file and it deploys all of those changes. This is a really great idea. This is similar to infrastructure as code for the cloud, which I'm sure many of you have heard of, but this is just making changes on your own machine. This is a really great idea, but it's not actually very common. It's not common, right? People have just chosen not to do this for some reason. I was really surprised. So I did some research into it, and there's two main reasons why. Firstly, writing a cookbook, as in describing all the things you need to install on your development machine, it requires specialized skills. People kind of shy away from doing that, so that's one reason why it doesn't happen. But the second reason is it takes away a very valuable learning opportunity. For new developers who are coming into an organization, there's a lot of value in them actually typing those commands by themselves. They know how everything works. They see everything that has to be installed. They understand the architecture of their software. So I would say easily 80% of the companies I've worked at do not actually automate the step. They just leave it manual because that's an interesting thing for people to learn. Okay, so let's move on a little bit. Times progressed. 2015, Docker was released to the world, and containerization became a really important thing. Now, containerization was a fascinating invention. The idea that you could run exactly the same image on your development environment as you do in production, right? Everything, all the libraries and the files and everything is in the right place automatically. But what containerization did differently, well, they basically used the Docker file, which is the same as a recipe in Chef or Puppet. But because it had to be automated, you had to go through that learning curve of how to write a Docker file, because you were now pumping out containers every day and deploying to potentially hundreds of machines in the cloud. You could no longer get away with that whole typing things manually. So now we have to use Docker files, and it's a really, really good thing. It's also relatively fast, right? Depending on your image that you're building with Docker, it can take 5 seconds, maybe 30 seconds, maybe a few minutes if you don't have things cached, but it is relatively quick to deploy. And this is a good thing. The challenge though, think about local development. When you're running a container on your development machine, it's not your development machine, it's a container inside your development machine. There's some friction. It's a different file system. It's a different process space. So as a developer, you need to get into your container in order to do stuff. You need to get into it to debug. You need to get into that container to look at the files and the logs and things like that. So containers were an amazing concept, and it makes development environment and production environment the same. But now we've got a level of friction that we didn't used to have. And that's a problem. Yeah, there are solutions to it. So let's keep going. So here's one thing that I found a very, very common way that people have been working. So when you're using containers, you probably find yourself still developing locally, right? You write your code, you save them to your local file system on your desktop machine, you run your unit tests on your desktop machine, and you debug problems on your desktop machine. But when you want to get closer to pushing it to production, that's when you run your tests inside the Docker container on your local machine. And the difference really is when you're running a unit test, you have a very low dependency on that environment. You don't really care about what files are on the file system, what services are running. Your unit tests are very isolated and they mock out a lot of that. But when you get to your integration tests where you start to need to depend on other parts of your system being there, that's when you have to jump inside that container and run your tests. So this is a very, very common pattern I've seen, and I do this all the time, and I think a lot of people that I've worked with, companies I've talked with, do this as well. That's a great pattern to follow. But here's the problem. If you've done this before, how much RAM do you have on your machine? How much CPU do you have on your machine? And yes, you could have a very big cloud desktop with 128 gig of memory. Maybe this is not an issue. But for many of us who have like 16 or 32 gig of RAM, you're going to run out of memory pretty quickly if you start running containers on your development environment alongside your IDE and everything else you're doing. So it's not a perfect solution either. So how do we get around this? Well, here's another pattern. Break into microservices. What if I was to take my massive code base that is too big to run on my development machine and break it into smaller microservices that I can develop independently? So when I'm working with microservices, I get to focus on which part of the system I want to develop on. I only check out the source code for that part of the system, and I only build that part, and I only test that part, right? So reduce source code size and the build test complexity is a big win for local development because you are now able to put everything that you care about on your local machine. And for the bits that you don't care about, you use pre-built containers, somebody else's containers, some other team built those for you. You just Docker pull them and use them for yourself. It's a really great solution. Now, if anybody has actually done this before, there are probably alarm bells going off in your head right now because it's not as easy as I make it sound. It is quite challenging, right? Taking monolithic software and dividing it into microservices can be a multi-year effort. It's a big change. It can also be a major culture change for companies. If companies are used to building monolithic software that's really big, and now you're building these smaller microservices, the culture of the organization naturally changes where the teams communicate with each other differently. So if you're going to do this, it's a great idea, but be prepared. It's a lot of work and a lot of change to make it happen. Okay, well, here's another way of thinking about the RAM and the CPU problem. How do you get your development environment to be efficient? Well, maybe you just don't run everything. Maybe you find ways of breaking your application down and only running the bits you actually care about. So here's a typical AWS example. So I have a load balancer that is feeding requests into my custom software running a container. My container talks to a database, and I have a queue and another container listening to asynchronous data coming out of that first container. Now the question is, well, what do I actually need? Now let's say I'm a developer of that first container. What I need to check out is I need to check out the source code for that container. I almost certainly need my database because my application is going to fail if my database is not there. I can't do anything. It has to be there. But I don't need the load balancer. Load balancer is something for scale, right? It scales multiple containers. I don't need that in my development environment. Now the queue, do I need the queue in my development environment? Well, yeah, it turns out I do because my application is going to fail if the queue is not there. So I do need the queue to exist, but I don't need the queue to actually keep any data. I can discard the data immediately. And this container on the right-hand side, I don't need it either. So by intelligently looking at your application and deciding what do I actually need to have and what can I stub or mock out, you get to run less on your local machine and you can focus on testing and building just the bits that you care about. So here's another pattern. What if we ran those things in the cloud? Okay, well, that's an interesting. If you can tolerate the security and the cost risks, which I talked about earlier, then this is a great method. This is often called remote local development. In this model, we look at our application and say, well, which parts could I potentially run in the cloud? I need my container, my main application to be running on my desktop machine because I'm developing it constantly and testing and changing it constantly. But the database can be in the cloud. I'm fine with that. Why would I care? It's as long as I can point it to the right place, everything's fine. And as long as the security is good, everything's fine. The same thing with my queue. The queue can be in the cloud as well. Everything except what I am actually directly working on and changing can be in the cloud. And that's a really, really good time saver. But here's the question you may be asking yourself. Well, if I have 100 developers in my organization, do I have 100 databases? Or do I just have one database with 100 tables? So that's the trick you have to think about. Perhaps there's some optimization of just having one database server for the entire company, and everybody has a different database table or a different database schema within that has a username embedded in it somehow. So when I'm using the database, I use my set of the tables. When you're using the database, you use a different set of the tables. So there's some work to do here, but this can be a really great way of minimizing what runs on your desktop and yet still having a very, very efficient development environment. It takes time to get here though. This is not easy to do. You have to change your software and have some special development set up to make this arrangement work for you. Okay, so let's move on now to what I call serviceful. Now, I accidentally said serverless when I introduced this, but it's very, very similar. Serviceful is basically when you build applications that consist of multiple AWS services and you are joining them together with your own custom code. So serverless is a special case of this where everything scales to zero, meaning if you don't run it, it doesn't cost you anything. Serviceful is just any service. Now, container does cost money. You're charged by the hour for running containers. That's fine. That is still serviceful. So this is where your software architecture changes significantly as well, right? We are now, these things can't be run locally. They are services running in the cloud. It's not just some big hunk of Java code that you run. It's code plus services put together. So you've seen this as well. I'm sure everybody's heard of infrastructure as code. Application development teams are now changing their way of thinking. Application developers now need to learn Terraform or CDK or CloudFormation because they need to construct their own code combined with services. So the world has changed quite significantly in the last few years to rethink how we build applications. Okay, well, then the question becomes, how do I test these things on my local environment if in fact it's services and my own custom code glued together? Well, one way of doing it is abstraction layers, right? So an abstraction layer is basically where in my own code, I have an interface somewhere that says, look, are you running on production? If so, use the AWS service. Or if you're running development, well, you use your local files or whatever it may be. So in the case of S3, I push objects to S3. If I'm using on my development environment, I just save those same objects in the local environment. It works perfectly well. I see this all the time. There are tons and tons of libraries that you can use to stub out the access to the AWS service and instead use a local version. For databases, you may have just an in-memory data structure that stores the data rather than actually writing it to a database, as an example. Here's the problem though. This again takes work. You have to go through your entire application and think about all the places where your application talks to the cloud and then find an alternative way of implementing that functionality of yourself, right? So that takes work. It's a lot of effort. People do shy away from doing that unless they can find pre-built libraries to do that for them. So here's another pattern. How about emulating the cloud? How about using libraries that somebody else has built to make it look as if you're talking to the cloud, but you're not actually talking to the cloud? So in this case, you won't have to change your application at all. What you do then is you change your AWS endpoint to point to an emulator that's running on your local machine, as opposed to the default endpoint, which is running in the cloud. And if the emulator provides the same behavior as the cloud, you don't have to change your application in any way whatsoever, okay? And that's a really important point. And why you would do this? Well, again, it reduces that cost risk and the security risk of actually talking to the cloud. You are running the emulator on your local machine. You're not worried about the cost. It's a fixed price that you pay, usually free. And the security risk, it's running on your local machine, no problem, right? So where's the issue? So here's some examples. So one library I've used a lot is Moto. Moto is a Python library. You link it with your code, and basically it stubs out calls to AWS. Now I say it stubs out because it doesn't have full emulation functionality. It doesn't allow you to do everything the cloud can do. What it allows you to do is basically very basic: create resources, delete resources, list resources, just the really basic things. And this is very, very useful in a testing environment. A second thing to talk about is AWS emulators. Now, AWS teams, there are a small number of emulators available. Probably the best one I've seen is the DynamoDB local, which emulates DynamoDB, but it keeps all the data and everything running on your local machine, so you don't actually have to talk to the cloud. Step Functions Local, that's actually a tool I worked on when I was at AWS. That emulates step functions, and it does everything locally. Now, unfortunately, step functions local is no longer supported by AWS, but this allows me to recommend local stack. Disclaimer, I do work for local stack, so I'm a little bit biased here. Local stack does support a wide range of services, right? You can run Lambda and step functions and a whole bunch of services, and they integrate together as well. So for example, IAM policies are supported, and if you want to connect your SQSQ to a Lambda function and do event source mapping, all of that is fully supported and it all runs locally. Okay, so emulators are great because you don't have to change your code at all, right? You just repoint the endpoint. Okay, now let's talk about the future. Where should we be, right? Where are we? And I don't know if the future's here or not. It keeps on changing on me every day. I don't know where we are. But what I would really love to see, and we're not there yet, I want to see a very fast local loop. That is, when I make a code change, I want to be able to test it instantly. Run my unit tests, run my integration tests. I want to see whether my code change is the right thing instantly. Not have to wait 30 seconds to a minute, 2 minutes, whatever it takes to deploy. I don't want to have to do that. I also want 100% parity with AWS. I don't want to have something that I have to hack around in my local environment to make it work, and then it not be exactly the same as what I'm actually going to run in production. That's a bad thing. So how do we get here? What is still remaining for us to actually do? Okay. So one question that may come up is, well, why don't we actually just develop in the cloud? Well, is that where we're headed? You know, it's a nice idea, and some people believe that's the future, but I'm not quite there yet myself. I don't think that's quite the answer yet, right? People who do this, they don't do everything in the cloud. They still run their unit tests and they do their debugging. They still do that locally. They just do most of their integration testing and everything in the cloud. Friction is very high. You still have that cost risk and you still have a security risk in the deployment time. So we have to find ways of solving those problems. And a lot of it is just social, right? People are concerned about things that aren't necessarily real problems, but those are real concerns. So we can't just ignore them, right? We do have to find ways to get through it and better mechanisms for dealing with these problems. Tools are clunky. If you've done a lot of development in AWS, you'll know that there are many, many different tools. You have a set of tools for Lambda, a set of tools for step functions, a set of tools for DynamoDB. They're all really good tools, but they are siloed individual tools. They don't necessarily talk well with each other. And the tools don't do everything you want, right? I love breakpoint debugging as an example. I love the fact that Lambda functions, I can now do breakpoint debugging in the cloud. That's a really great project. I wish I had the same thing for step functions. Can I just set a breakpoint and stop my state machine running? I would love to see that, but we're not there yet. So there's a lot of work to do. So I want to continue the discussion, right? After today's talk, thanks you so much for listening. I want to know, more about this, and I'm researching this myself. How can we speed up cloud deployments? How can we make things faster so that inner loop is really, really quick, and we're not bothered by slowdowns every time you want to save a file and test it again? How can we avoid unpredictable cloud spending? That's another one. We all want to know that one. How can tools be seamless when we're working across different AWS services? How can we make them feel as if they are one tool that knows about everything rather than many, many different tools that are disjointed? And of course, AI agents. Welcome to the new world, right? So who knows, do AI agents actually help or not? Well, they help in many ways. In fact, AI agents could solve that problem we just talked about all the tools being disjointed. If AI agents are your primary tool and they orchestrate all the debugging activities for you across all the services, that's a really good thing. But do you really want to trust an AI agent right now to deploy to production and to debug for you? Because we've seen a lot of stories recently about, oops, accidentally dropping a production database. There's a lot to do there, and we need to move forward and sort of progress on this. But I think we're going in the right direction. Now, I would love to chat with you. This is a virtual conference, so obviously it's a bit hard to do, but please reach out. These are my LinkedIn coordinates if you would like to reach. And as I said, I am based in Nelson, New Zealand. So if you are interested in coming by, having a cup of coffee, I would love to chat with you about development environments and how to make them better. And we also have lots of FIJOs in Nelson. So please remember to give your feedback on the link that's about to be shown. And I'm really looking forward to the FIJO talk later on. Thanks very much, everybody.
Hello, and welcome to this presentation for the AWS Community Day Oceania, as run by the AWS User Group of New Zealand. For those people who haven't read the abstract or who haven't looked at the description, this presentation is about migrating existing AWS workloads into the newly opened New Zealand region. Wouldn't it be great if a command like this actually existed, where you can delegate most of the effort across to AWS? Alas, it does not, but this presentation will do its best to try and help you get through that uncertainty around the migration and to do some of the work for you so that you don't have to worry too much about doing the research. Just a quick discussion about who I am. My name is Terence White. I'm an AWS community builder and a member of the AWS User Group of New Zealand. I am based down in Wellington. The New Zealand region is up in Auckland, and as such, I have a vested interest in helping people migrate their workloads across to the New Zealand region. Just a word up in the corner, we have QR codes on a lot of the slides. These QR codes will take you to what the most relevant point on the slide is. And if there's a second QR code on the slide, there is one of them that would take you to something, and I'll tell you exactly what that particular QR code will point through to. These presentations are being recorded, so if you do not capture the QR codes on the first run through, please feel free to look at the recordings and grab them from there. Now, first, a history lesson. In 2013, AWS made their presence known in New Zealand, but they did not get any actual technology onshore here for quite some time. There was a lot of talk about opening up a New Zealand region, and that got hampered down by the COVID epidemic in 2020. Eventually, we did get a CloudFront Edge opened up, and that was followed a few years later by a direct connection point up in Auckland. Shortly after that, we got an Auckland local zone that used the Sydney region as its parent. This was a good second place prize compared to getting an actual region then. A couple of years later, early in 2020, late in 2025, we finally got our New Zealand region open, and shortly after that, the second direct connect location has opened up in Auckland. Now, why would we consider moving workloads to New Zealand? Three reasons come to my mind. There's probably a few other ones as well. The Treaty of Waitangi, signed in 1840, is New Zealand's founding document, and Article 2 in the Treaty of Waitangi guarantees full authority of treasures called taonga, including intangible treasures like data, to Maori. So this is a reason for government departments who hold data about the people of New Zealand to move the data to New Zealand. It helps with guaranteeing that that data is available to the people who want it in New Zealand. The second reason I can think of is regulatory compliance. There's laws, there's rules that say that you should. This is an example of the Reserve Bank of New Zealand's BS11 rule that allows for workloads to be run offshore, but it would make it a lot easier to comply with this and to pass audits on this if those workloads were in New Zealand. The bottom phrase there of the legal and practical control over all aspects of the backup system of a system that is handled by a third party, if it was in New Zealand, would fall under the laws of New Zealand, and it would be a lot easier to be able to claim having those full controls, rather than if your workloads were offshore in another country and subject to the legal whims of that country. And the third region, which would apply to most organizations not driven by the first two, would be things are faster network-wise to the people of New Zealand if your workloads are in New Zealand. I've run this latency test from my home in Wellington, and there is no surprises that accessing the nearest AWS regions, apart from the one in Auckland, are a lot slower than accessing the one in Auckland. So if you are considering running workloads that would be used in New Zealand by the people of New Zealand, one of these three reasons would be a good reason to go ahead and do the move across. So how are we going to go and do this move? The first thing we want to do is take a look at our workloads and pick a workload that can be moved. Once you've got a workload that can be moved, if you have an AWS account that is already activated for the New Zealand region, you don't need to do this next step, but initially your account will need to select that it wishes to opt in to the New Zealand region. AWS has a few original regions that it enables for every account that gets opened, but there are a lot of new regions that are opt-in only. Once the region is active for your AWS account, we are going to recreate stateless components that we can set up in the New Zealand region. And then we're going to look at getting our data moving across from our source region into New Zealand, get the stateful components that use those data up and running, and we effectively have our workloads running in New Zealand. Then pick a date, do a switch over, and should we be a bit hesitant about this, re-establish the data moving back to our original source regions as a backup or a failover point, and eventually we'll get around to cleaning up the source. So the question is, can you move workloads to New Zealand? When AWS open up a new region, there is a minimum amount of foundational services that need to be available, or they will not open up that region. Some of these foundational services, in fact, most of them, are used by AWS themselves to build even some of the foundational services, but also some second tier and third tier services later on. These are services that are most likely used by the majority of workloads. Things like EC2 service with block store, S3, the container services, Lambda, identity access management for security, and so on. You can have a look at this list and see if your workload fits in with this list of services that are guaranteed to be in the New Zealand region. And if you are unsure or your workload uses additional services, you can go to the QR code on this page, which will tell you which services are available. After a region is open, there are a few services that AWS will bring up, and these services are, most of them are already available in the New Zealand region. So these are services that are not essential for a region to open, but are still in great demand by customers, such as your transit gateway for your networking, your Kinesis fire hose for dropping logs down, and AWS organizations for managing accounts. I did a check, and there's only a few of these that aren't already open in New Zealand. So now we've decided we're going to go ahead and do this. How do we enable our New Zealand region? If you are on the AWS console, you go to the drop-down list of regions that we are all familiar with. You won't see New Zealand listed there unless you have enabled it. But at the bottom, there is a link that says there are 17 regions that are not enabled for the account. If you click that, or if you click the Managed Regions button at the bottom, AWS will open up a regions page, and it will show you that the New Zealand region is currently disabled. Select it, click the Enable button, and wait a few minutes while AWS copies things across to the newly enabled New Zealand region. AWS will prepare the region for you by bringing across things that are of a global nature, like IAM, users, roles, and policies, and a variety of other things to make the region work. If you are not a fan of the console and you wish to use the CLI, this is also available in the CLI, and you can simply make a CLI call saying that you wish to enable the New Zealand region. The call will come back immediately. You wait a few minutes, you can see the status of the region, and the region will become enabled. Right, so we now have a New Zealand region in an AWS account. What is the next step? We're going to look at migrating components that are not dependent on data that can exist in the region without needing any knowledge of customers or products or anything like that. So these are the infrastructure components that we'd like to bring in. I've got a list over here of some of them, but your particular application may differ. None of the items on this particular page here require data in order to be stood up. So you can stand them up before you're going to look at bringing the data across. You can test them to make sure they're up and working with some dummy data, and then you can tick them off as things that are available. If you're using infrastructure as code, and you should be, it should be a fairly simple process to be able to stand up a copy of what is already running in your source region. For example, if you're using Terraform, then you can simply add a region to most of your Terraform resources, and you can create modules that take region as a parameter, and then you can stand up an equivalent structure in the New Zealand region by simply specifying that you'd like it to go to Asia Pacific Southeast 6. Right, we've now got a platform, we've got our serverless stuff up and running. What is the next thing? What we'd like to do then is make sure that we can bring our data across, and this is the important stuff. In the previous slide, we were bringing us across components that if there was a problem, well, we could simply spend a little bit of time debugging. We could recreate them without any issues. Data is key. So we're now going to bring up those applications that have some sort of state, have some sort of data in them. The first one to take a look at over here is block storage. When you are creating servers on EC2, you may add block storage to those servers, or you may use existing block storage on those servers. AWS has a service called EBS, which handles block servers, a block storage that is permanent. There is also the ability to use instance stores on EC2 for block storage, but instance stores should only be used for ephemeral data, and we would not want to bring the contents of those ephemeral data across to New Zealand. We want to just have them recreated. Lucky for us, AWS has a service as part of the EBS service that allows you to make snapshots of your existing EBS disks, and you can copy those snapshots across to the New Zealand region. The first copy you make is going to be a full copy of that disk. It has to bring all the blocks of that disk across to the new region, but any subsequent copies that you make will use an incremental copy, so it will be a lot faster than that original copy. What you can do to get your EBS volumes across and up and running on an EC2 server is get your EC2 server up and running in New Zealand, create your snapshots, have them automatically copied across to New Zealand, and then when you're ready to go live, we're going to stop writes to that original snapshot. We're going to wait for the copy to complete. We can make sure that the incremental doesn't have a lot to copy by doing an incremental just before we want to go live. We'll then create a new volume from that last snapshot in the New Zealand region, attach that to our EC2 instance, and we have the data across in New Zealand. Second kind of storage that is very similar is file storage, and AWS has a few services for file storage, EFS and the FSX products. The FSX products are not yet available in New Zealand, so I won't talk about them yet. But on the EFS side, EFS has a replication service available that will allow you to replicate your EFS drives across to New Zealand. Those drives, once they're replicated by the EFS replication, will arrive in New Zealand in a read-only EFS drive, and you can mount those read-only EFS targets to EC2 servers that you've created in New Zealand, so that you can use your EFS and get it set up in a read-only way. When you're ready to go live with this one, we're going to stop writes in our source region. We're going to let that last replication happen across, and you can follow that in CloudWatch to make sure that the replication is completed. Once it's done, we're going to delete the replication config on the source EFS file system. And when you delete that replication, it will make the New Zealand EFS file system read-write, and then you can start your applications in New Zealand, and they will have EFS available for them to use. The third kind of disk-based storage is object storage, and it should be no surprise to you that S3 has built-in replication, which allows you to replicate your data across to New Zealand. There are two kinds of replication for S3. There's live replication, which will take any new and updated objects in your bucket, but we still need to handle the objects that have been put there over many years, and for that you have batch replication. S3 batch replication is a low priority process, and it is typically dealing with huge volumes of data, so it can take from 24 to 48 hours to copy across to New Zealand. You will have to create a new S3 bucket in New Zealand, as S3 bucket names are globally unique. You can set up live replication with a 15-minute SLA as well, and you can also consider using multi-region access points. A multi-region access point allows you to have a few S3 buckets, in our case, a source and our New Zealand region one, and then have one access point that is active and all of your reads and writes to that access point goes to a particular S3 bucket. At the time of going live with our move across to New Zealand, you can flip the buckets in the MRAP across to the New Zealand bucket. However, since we have our replication going across, we can also stand up our applications that use the S3 data in New Zealand, point them at the New Zealand bucket, and just don't use them until such times as we're going to go live with the move. There is an alternate option as well. So we can use a product from AWS called DataSync. DataSync is like rsync or SCP. It will use the public APIs of the EFS and the S3 product. It doesn't need to spin up a particular server or agent and run. You can just create tasks inside there that will effectively do a list and a copy of the S3 buckets or the EFS file systems. You can't use this for EC2 though, because you'll need to have NFS targets on one side in the form of EFS or S3. One of the reasons why you might not consider data sync is that the minimum frequency of running a task is 1 hour. So the timings around that could be a bit of a concern for you. If you have streaming platforms, the AWS Managed Streaming for Kafka service has replication built in that you can enable. This is an active replication, so it effectively consumes data out of your source and then replicates it across to your target. You will need to make sure that you update the capacity of your source in order to prevent any throttling that might happen from this new consumer that's going in there. On the Kinesis side, there is no service that will allow you to copy data across, but you can set up your consumers on both of these platforms in the New Zealand region. You have your producers that are pushing data across to your source, but you can spin up those producers in the New Zealand region. They will push the data into the New Zealand-based streaming platform, and the data in the source region's streaming platform will be consumed by those consumers in that region. Once the data is no longer being added to, those streams will eventually dry up and age out. We build a lot of applications ourselves and run them ourselves. So we need to make sure that we have our Docker repositories available in New Zealand, and there is replication available in the ECR service. You can set up a two-way replication so that if you push an image to the New Zealand region, it gets replicated across to your original source region as well. There is a slightly long SLA on this one, and if you're concerned about that, you could, of course, simply push your images across to both repositories. When you wish to go live, well, your images will be available in the New Zealand region, so you can just start up your applications that use those repositories. Now let's take a look at data in databases. If you are running your own databases on EC2, there isn't much help available from AWS. You'll need to spin up your database in New Zealand. You'll need to set up a copy of that data that will be in the New Zealand region. You'll have to handle that copy yourself, and then you'll have to use native database replication like DataGuard or Active DataGuard for Oracle, transactional replication for SQL Server, and then MySQL and Postgres also have inbuilt replication. When you want to go live with this, you'll need to stop your writes on your source side, wait for your replication to finish moving the last of the data across to New Zealand, switch over your database, and then start your New Zealand applications. Now, fortunately for us, if we're using RDS, RDS provides cross-region read replicas that will take away a lot of the manual steps in that last process. You can set up a replica in the New Zealand region. This will be read-only, and AWS will manage the replication using the database replication options. You don't need to worry too much about the setup of that. Once you wish to go live, you can stop writes on your source side. You can wait until the replication lag across to New Zealand is 0, and then inside RDS, promote that target database to be a standalone database. This promotion step does require a reboot of the database, so it will take a couple of minutes to go through, but it's only a couple of minutes, and then you can start your applications once that database is available again, and you can go forth and use the region. There's another step up. If you're using Aurora, Aurora has a global database built into the Aurora service. What this allows you to do is set up a replica in New Zealand that is also a read-only replica, but it is at a slightly higher live state than the RDS replica is. You can have live applications in both regions. They can point to their local cluster, which is read-only in New Zealand until you go live. And then at the appointed time, you can run a switchover command. What the switchover will do is stop writes on the source Aurora database, wait for the last writes to be replicated across to New Zealand. It will then enliven the New Zealand database. Your applications can reconnect to that New Zealand database, and then you can go ahead and run your applications. It will also make sure that the data that is written to the New Zealand region is replicated back to the origin in your source databases so that you have a failover point should you decide to use that. AWS provides driver wrappers for the popular languages such as Java, Go, .NET, and so on. That's why the second QR code is on the screen. If you use those driver wrappers, the switchover time can be reduced from around 30 seconds down to about 6 seconds, as these driver wrappers have knowledge about your Aurora cluster. And when you do that switchover, it doesn't take as long as 30 seconds for the DNS propagations to tell it where to connect up to. And then another popular database is DynamoDB. DynamoDB also has a global database service built in, but this one is active-active. Once you set up the global database and set it up to be in New Zealand, the database will allow, Dynamo will allow you to do writes to both regions, so you could spin up your live apps in New Zealand. Now, for go live over here, there is literally nothing to do. Your database is already accepting writes in both regions and replicating writes between both regions. Your original database will be available in case you decide that you wish to switch back to your original source region. Now, you may have a look at the documentation on this. I would recommend it is not keeping the apps live on both sides at once unless your applications are designed for it, as there is eventual consistency on the replication across, not strong consistency. Please have a look at the caveats on the documentation page and make sure that your applications can handle writes going to both of those regions. And of course, being AWS, there is an alternative option as well. There is the database migration service. This allows you to do replications from a source database across to a target database, and you can effectively have your source database in RDS, MySQL, or RDS Postgres replicate across to your target database in MySQL, RDS, and MySQL Postgres. Database migration service will handle the full load of those target databases in New Zealand and the ongoing replication using whatever native database tools are available. So the replication for both MySQL and Postgres. And it can handle a full load of the database. So you will end up getting all your stored functions and stored procedures and grants and other things going across as well. Consider using database migration service if you'd like to have a more visual representation of how things are going, or if it's a service that you're more familiar with. So, can we do the move? Yes, we can. AWS has provided a number of services to help with migrating your data across, and you have options. Please feel free to talk to your AWS accounts team. Please feel free to talk to your AWS APN partner of choice, and let us see if we can bring our workloads back across to New Zealand. Ko te pai, tawhiti, whaia kia tata. I've been Terence White.
Hello everyone, my name is Stacey and I'm excited to talk with you today at the AWS Community Day Oceania Virtual Edition 2026 Today, I'll be sharing an adventure of increasing Prometheus reliability while decreasing AMP cost, and with a splash of Kero CLI. Let's start with a story. Let's imagine you're heading out for a weekend hike. Your bag is full, and you know already that you might have overpacked. But what's the harm? You're prepared for anything. You've got a heavy-duty tent for a potential storm, a spare pair of boots, and a cast iron skillet, because you deserve a bacon and eggs meal after a hike. But now, only a few hours into the hike, the heavy bag is draining your energy, and every time you resume after a break, it's a struggle to lift it back on your shoulders. Now let's just say it, your bag is full of junk and you're paying for it. Okay, now, in a hypothetical world, I want you to imagine that the hiker is a singleton Prometheus pod and you're a cluster. I'll explain what Prometheus is later, but for now, this is a pod that collects observability metrics about the cluster, those metrics you might use in, say, dashboards and alerts. And now, imagine the backpack is a 300 gig PVC attached to the Prometheus pod. And in that super heavy backpack are metrics. Some metrics you've never actually used, some metrics that aren't in your dashboards or alerts, and anytime you trip over carrying that bag, it's a pod failure. And yes, putting that bag on your back takes time, and while you're down, that's potential metric loss. So, before I get to the grit of this talk, let me quickly say hello. I'm Stacey, and I'm based in Wellington, New Zealand. I currently work at Xero, which is a cloud-based accounting software designed for small businesses, sole traders, and accountants to manage finances, bank reconciliation, invoicing, and payroll in real time. Now, I've been a software engineer in a product team, a site reliability engineer, and now a Kubernetes engineer. I like to be solving problems and really understanding how things work, and this talk is a bit about that. And because I'm more than just my work life, outside of work, I'm a ceramicist, a foodie, and a solar-powered human. Okay, let's get back to it. Let's run through at a high level what Prometheus is and how we use Prometheus. I'll explain why that hiker metaphor was our reality for our Prometheus setup at Xero. So, Prometheus is open source observability. It's a specialized toolkit for systems monitoring and real-time alerting. It's also time series data collection. It uses a pull-based model to scrape metrics from containers, nodes, and applications via HTTP endpoints. One of the biggest benefits we love about Prometheus is the high-resolution insights, which we get via customizable scrape interval that provide deeper granularity for incident response than some of our other standard tooling. And it's also an operational hub. It centralizes metrics in Grafana dashboards and alerting, which are used internally by our developers and platform teams. Okay, now what does that look like? Well, at Xero we run Kubernetes and Amazon EKS. We run many clusters which will follow this same pattern. So, in each EKS cluster, we have a single Prometheus pod, which I'll show shortly, and that pod will sit on a single node in the cluster and collect metrics for the entire cluster. And yes, there are more modern ways to configure Prometheus that run multiple replicas, but that's not our reality currently. So, inside that cluster, there are a lot of applications that contain critical information about how the cluster and applications are performing. In infrastructure and Kubernetes core type components, you'll get node level metrics, node provisioning metrics, you'll get the state of all your pods and deployments and whatnot. You've got core DNS. In ingress, you've got maybe Nginx ingress, so your traffic coming into the cluster. Platform tooling, you've got cert manager, external DNS. Now these are just some of the things we consider scrape targets, but you can really configure anything that you like. So now into the Prometheus pod. Prometheus uses a pull-based model to scrape metrics from the scrape targets via HTTP endpoints. And those metrics look a little like this. They're made up of a metric name, a set of labels, and a value. Now, once those metrics are pulled into the pod, the head block stores the most recent data, and this stays in RAM for fast querying and processing. However, to prevent data loss if the pod crashes, Prometheus simultaneously streams this data to the write-ahead log, or the WAL. And you can think of the WAL as Prometheus's journal or a safety net. Every single metric sample Prometheus scrapes is immediately recorded here on disk before it is even fully processed or indexed into the permanent TSDB blocks. So, if Prometheus crashes, the WAL allows the system to replay recent events and recover any data that hadn't been saved to long-term storage yet. The size of the WAL is directly proportional to the number of unique metric label combinations you're monitoring. Now, moving down to the 2-hour blocks, once the data leaves the WAL, it's indexed and compressed into 2-hour blocks. These are immutable data sets available for local querying. And then moving down again to the PVC, nearly all the data you see in the Prometheus server pod is maintained by the TSDB, the time series database. The TSDB is backed up by the PVC, and this ensures that if the Prometheus pod restarts or moves to a different node, your historical data and current journal of metrics remains intact. Prometheus will continuously stream metrics to AMP via its remote write configuration, and this enables long-term storage of your data. This ensures that the PVC doesn't grow to an infinite size, and in fact, Prometheus will only store data for as long as the retention period you have configured. So, if we zoom back out, in our context, we have a growing number of clusters and a growing number of teams deploying workloads into the clusters, which all equates to more data in the Prometheus pod and being ingested to AMP. So what's wrong with this? Let's just bring us back to the metaphor. We've got a singleton Prometheus pod processing all metrics for an entire cluster, and it's struggling. We've got high CPU and memory usage on that Prometheus pod and occasionally out-of-memory kills. We've got prolonged pod restart times, so getting that bag on our back after a fall is a big effort. And during this time, we lose metrics, which creates gaps in platform-level observability tooling. Our bag, the PVC, is hitting 300 gigs, and it's a struggle to lift. Every time the pod restarts, we have to pull the TSDB back into memory so the WAL can be replayed and the block data is available for querying. And beyond this, the Prometheus pod is large. It's difficult to schedule. We're hitting AMP query size limits and local Prometheus query limits, so the data is difficult to interact with. And all of this is creating engineering pain and toil. The alert fatigue is real, and Prometheus is often a contributor in incidents and out-of-hours pages. Now, rest assured, over the years, our team had already done a number of investigations to improve the stability of Prometheus. They looked at reducing metric loss. They also looked at other solutions for long-term storage like Cortex and Thanos. And more recently, we considered Prometheus Agent Mode and Amazon Managed Service Scraper for Prometheus. Although, unfortunately, priorities changed and the suggested improvements haven't been prioritized to the top yet. So, when Prometheus appeared on a cost reduction initiative in mid-2025, we knew we had to take a different approach. Instead of hunting for the next fancy tool, we asked ourselves a simpler question. How can we rejig the setup we already have? We needed quick, impactful changes that would satisfy two key goals. Firstly, reliability gains. We needed to increase uptime of Prometheus, reduce metric loss, and ease alert fatigue for our team. And secondly, cost optimization. We wanted to deliver quick wins for important stakeholders. Now, to set expectations, this story isn't the biggest Prometheus glow up of all time. This isn't about buying a new backpack. It's about opening the one you already have and taking out the unnecessary junk. So, what was our approach? Well, we used AI. We used Kiro CLI, which utilizes MCP servers with AWS knowledge over EKS, AMP, and Prometheus. Kiro provided direct insights over our exact configurations, and it gave us actionable comments and very quickly highlighted a number of pain points. Now, this was achievable to do manually, but Kiro really helped us gain insights at pace. And you can see here in the high priority section, Kiro has highlighted that the prod cluster makes up 61% of our AMP cost, and the test cluster 14% of costs. It's also pointing out issues with high cardinality metrics, and it's suggesting longer scrape intervals. This is really powerful, so let's keep digging. Kiro was able to call out metrics with high cardinality, and the top offender here being an Nginx metric. But what is high cardinality? High cardinality in Prometheus occurs when a metric has labels with a lot of unique values. Each unique combination of these labels creates a new time series which has to be stored in the database. When these unique values change frequently, this gives us both high cardinality and high churn metrics, which adds significant load on Prometheus. Low cardinality labels might look like HTTP status codes, where there's a very limited set. High cardinality labels might look like pod IP addresses, latency values, or ephemeral pod names. We'll get more into this a little later. Kiro then goes on to say that this single Nginx metric is likely the biggest cost driver due to high cardinality labels. It's calling out a bunch of labels here like ingress, service, namespace. We'll dig more into these shortly, but most importantly, it's calling out that Prometheus creates a series for every unique combination of labels. We were able to confirm Kiro's thinking with Prometheus internal tooling, which I'll also show later. So, Kiro highlighted a lot of low-hanging fruit, and by that I mean small configuration changes rather than big system changes. A lot of this configuration had been in place for a number of years. It made sense at the time, but now it was due for a review. So, the first suggestion was reviewing unused metrics. A bunch that were highlighted we weren't even consuming. Reducing retention period. We already knew this value was larger than needed, so good opportunity to review it. Increasing the sampling period. Like I mentioned earlier, Prometheus's big value for us was high granularity data, so we don't want to lose this. This one is a no from us. And lastly, reducing metric cardinality. So let's dive deeper into a few of these changes. All right, removing unused metrics. Since our Grafana dashboards and alert manager configurations all live in source code, this one became a simple analysis to review what metrics were consumed by these pieces. And from here, we could start to understand what metrics highlighted by Kiro were candidates for removal. So we discovered we had two categories of unused metrics. Now in this example, metric A, it's being scraped into Prometheus and then remote written to AMP, but not being consumed by Grafana dashboards and alerting. So these metrics are adding bloat to the TSDB and adding to our AMP ingestion cost, all for us to just not use them. In the second example, you have metric B. Metric B is scraped into the Prometheus pod and then dropped at the remote write configuration, meaning it is never written to AMP. So likely a long time ago, we decided we needed to ingest metric B to AMP. We never needed to ingest metric B to AMP. but unfortunately we didn't drop it early enough, so it still lives locally in the pod. So the key change here, or the golden rule, is always drop as early as possible. If you know you don't need a metric for local troubleshooting or long-term storage, drop it at the scrape level or the service monitor. You'll be using metric relabeling to drop your chosen metrics. And the benefits for this are reduced I/O for storing unused metrics in your TSDB and reducing AMP ingest cost. Next up is the retention period. The retention period defines how long Prometheus stores metrics on local disk before purging them. For us, initially the retention period was very high, which made sense at the time, but now wasn't serving us to store that much data on disk. The value of reducing it, well, since long-term data is already safely stored in AMP, reducing local retention period provides significant wins. You have lower RAM usage and faster restarts because Prometheus doesn't have to handle as much data in memory. You have reduced storage costs in your PVC, and you have lower I/O overhead. And then beyond that, you've got faster garbage collection from all of that magic stuff that Prometheus is doing internally. How to change this one? Well, this is a simple configuration update. It's probably one of the quickest wins we had by modifying the storage TSDB retention time flag in your Prometheus deployment. Now, there is no one-size-fits-all value here, and it should be right-sized based on your specific needs. I'd recommend giving the Prometheus docs a read. They have very good guidance on this. Okay, now the last change Kira suggested was reviewing high cardinality metrics and reducing labels on those metrics. So this metric on screen is one Kira called out to review. Nginx ingress controller request duration seconds bucket. It's a histogram metric that tells you the distribution of response times for our Nginx ingress controller. You can use it for percentile metrics and asking questions like, how is the 99th percentile request times behaving versus the 50th from Nginx? And you can see there's some interesting stuff on here. This is all dummy data, but let's look at these red flags. From the top, you've got the controller pod, the Nginx pod serving the request. You have the very legitimate host name. You have the instance, which is some IP address. You have the path, which sometimes has GUIDs or query parameters, and even duplicated data, again, the name of the Nginx pod. These pieces of data with really high cardinality or unique values. And they have high churn, meaning the values change frequently. So let's just visualize this cardinality explosion a bit more. If we have 10 API hosts and 10 distinct endpoints on each host, 10 unique pod names, 10 pod IP addresses, and because this is a histogram, we also multiply that by the number of buckets, which in this case is usually 10. That's 10 times 10 times 10 times 10. Suddenly this one metric is costing us 100,000 unique time series, which needs to be stored in the TSDB. And that's not even factoring in if those request paths contains GUIDs. When a pod restarts or we deploy a new version, the old series don't just disappear. They stay in the index for hours, and this churn fills up the Prometheus head block of memory. So you can verify this. Prometheus provides a built-in TSDB status page, which is found under the status tab. This helps you articulate your high cardinality metrics. The highest labels, it shows you the highest labels with the highest unique values. Like here we have 8,300 IP addresses and around 12,000 pods. It'll also show you the labels that contribute to high memory usage. So this tool lets you look inside your backpack and see how heavy those metrics are. In our case, it proved that just one Nginx metric was responsible for nearly a quarter of our total storage in the TSDB at any one time. And for deeper dives on this, we can supplement this view with prompt tool commands inside the pod, which allow better filtering to get insights on a specific metric. Now I'm going to skip ahead a bit here, but from here we really evaluated the high churn labels critically. A lot of this data we could piece together via our logging systems and other monitoring. Our dashboards didn't need to facet Nginx latency by pods or instance. They reported much more generally by ingress names or namespaces. So, can we just delete the labels? Well, sadly no. Prometheus essentially treats every unique combination of metric and label combinations as a separate row in the database. So high cardinality labels like user IDs or pod IPs create thousands of rows. And by dropping those labels, we are telling Prometheus to stop storing them separately and just put all that data into a single row. This Grafana query is a result of just deleting the labels, and it's clearly wrong. It's taking us in the opposite direction of where we're trying to get to. So, instead, to achieve what we needed, we used recording rules. Now, recording rules pre-compute frequently needed or computationally expensive expressions and save their result as a new set of time series in the TSDB. So let's walk through this example. First of all, this is the new rule named Nginx ingress recording rule. It will execute every 15 seconds. When it executes, it will record a new metric in the TSDB with this name, very catchy, but you can see it's prefixed with label reduction. Suffixed with label reduction. Then it performs an aggregation of the original high cardinality metric, in this case a sum operation. And here we are very selectively choosing the labels from the old metric that we are grouping by, and therefore keeping this reduced set of labels. All other labels are safely excluded on the new metric. And there you have it. But how is this different to dropping labels? Well, dropping a label just erases the label's text from the data before it is saved. And this creates a collision because Prometheus suddenly sees multiple identical metrics arriving at the exact same time, assumes it's an error, and rejects the data. On the other hand, a recording rule uses math. It looks at that data that has already been safely saved, it aggregates those different data points together and stores them as a totally new metric. Now, there are some drawbacks with this approach. It does create more data in the TSDB, but the big one here is that we can use the new metric to remote write to AMP, and the original high cardinality data only ever lives in the TSDB. So, let's zoom out and just summarize the changes that we made. We stopped scraping and ingesting 6 high cardinality metrics. We reduced the TSDB retention period by 75%, and we used recording rules on one metric to safely remove 2/3 of its original labels. And what was the impact of all that tidy up? Well, for the Prometheus pod, we saw a 60% reduction in CPU and memory utilization. So now, yes, that 300 gig PVC was pretty overkill. Our pods are a lot less busy. Our changes reduced startup time of the Prometheus pod by 70%. And because there is just so much less data to read into the memory from the PVC, it was a really big win. The flow-on effect of this is we see significantly less metric loss while Prometheus is starting up, which means the gaps in our Grafana observability dashboards are significantly smaller now. And the impact on AMP? Well, we saw a 40% reduction in AMP costs. And for us, this equated to an annual saving of more than 100,000 US dollars a year. And this is directly related to less metric data points being ingested. So it's not perfect, but it's a lot better. We still have very minor data loss when the pods are starting up. We still have some hefty metrics, and that PVC could still be smaller, but the pod is much more stable. We are a long way better than where we started. And the good thing is, even if we consider moving to Prometheus agent mode and running multiple replicas, or using a different long-term storage mechanism, all this work to clean up is still relevant. Now, before I run, I'm just going to give you a couple takeaways. Firstly, every metric has a cost. If a metric has no clear owner or use case and doesn't show up in dashboards or alerts, it might just be clutter. But don't look at a metric in isolation. Look at observability as a whole. Look at metrics, logs, traces together, and only delete when you're sure there's no real gap. Secondly, your observability config should evolve with your system. Teams ship new services, deprecate features, and change SLIs frequently, but the scrape configs often stay frozen in time. Treat your Prometheus config like application code. Review it regularly, remove legacy, and keep it aligned with your current architecture and reliability goals. And lastly, cleaning up what you already have can sometimes be a better MVP than a shiny re-architecture. So instead of pitching a 6-month re-architecture, consider reviewing unused metrics, tightening scrape configs, and aligning labels with how people actually query your data. That alone can drop AMP costs, speed up queries, and reduce the computation needed by Prometheus. It's a change you can ship this week, you can measure next week, and use as proof that maintenance work moves real numbers. Thanks everyone for listening. Feel free to reach out to me on LinkedIn if you have any questions. I'm Stacey.
All right. Thanks everyone for tuning in. My name's Rowan. Today we are going to get to know AWS Security Agent and see how you can use it in your development process to help build secure applications on AWS. So, quick introduction. My name's Rowan. I am an AWS security hero. Before that, I was a community builder and AWS ambassador. I've been building on AWS for over 15 years now. It is a pretty long time in the grand scheme of things. I authored a book called The Practical AWS IAM Guide. That's kind of how I got started in the security side of things. And I help teams build securely on AWS and also pass their compliance audits. Moving on to Security Agent. Security Agent was announced at reInvent last year and is what Amazon is calling a frontier agent. Now, frontier agents are designed to operate for extended periods of time. And the other frontier agents that AWS offers are DevOps Agent, which is used for troubleshooting operational issues, and also Kiro as a development or coding agent. So these agents that Amazon has invested particular efforts to focus them and make them as useful as possible within particular scopes and boundaries. The reason why you should care about this is that this is going to be one of the easiest ways to shift security in your software development lifecycle left. And by left, if we imagine that we start by writing code with the idea that eventually we'll deploy it into production at the end of the development lifecycle, we want to bring the security feedback as soon as possible in that process. Because of things like, a stitching time saves 9. If we can solve problems before they become big problems, then it's much less costly from a effort and also from a financial perspective. For example, in the context of security, having a security incident in production is a very, very costly event. So if we can avoid that by maybe taking a little bit more time, spending a little bit more time in the development process, then we're going to have much better outcome for our software and our businesses. And this is what Security Agent is really good at doing, as I'll show you in the coming slides. The common challenge that we see in the industry when trying to apply security best practices is that a one-size-fits-all approach unfortunately doesn't work too well. Unfortunately, making very broad statements, while it might work for LinkedIn posts, doesn't always translate into the context or the situation that we find ourselves day to day. There might be a very good reason why we can't do something that would otherwise be considered best practice for historical or business reasons. And it's kind of on the tools that help us to meet us where we are. And Security Agent does quite a good job of that, as you'll see. The other thing that Security Agent does that I really like is this scaling of security fixes and teams. Unfortunately, what we often see in the development lifecycle is a development team will build their application, especially in the context of compliant applications or applications with regulation, and they'll go through the whole process and think that they're done and go through a final kind of pen test or external assessment, and that will come back with a whole lot of surprises with in the security context that will then potentially delay go live or result in a large amount of rework and just be a really kind of unpleasant process for everybody involved, the developers, but also the security people assessing it as well. So by bringing this feedback sooner in that cycle, like I said before, we really can scale out our security capability in a much more enjoyable way. When it comes to Security Agent itself, it's made up of 3 main pieces of functionality. We have the design review, which is where Security Agent will take your design documents and associated documentation and review that with a security perspective. And, this is a way that you can get security feedback before you've even started writing code, which is something that most teams don't always have available to them. The second part of Security Agent, and probably the part that gets the most focus, is the penetration testing aspect. So Security Agent allows you to run automated pen tests on your applications so that you can get feedback from actual live testing on your application. And this is what a lot of teams have traditionally had to rely on an external or third-party expert to do that. And the reality is you probably will still need these external pen tests to give you that really high level of confidence and validation. But Security Agent gives you a way to very quickly and easily and early in the process get some of that security feedback so that you can really improve the quality of your output, so that when you do have an external pen test, they're spending their time finding much more high value things in your application rather than some of the basics, the OWASP top 10, things like that, ideally you should have sorted before you engage someone outside of your organization. And related to that is the code remediation piece. So this is where Security Agent can proactively review your pull requests in GitHub and also create remediation recommendations code for the things that it's found. So it isn't just saying, hey, this is a problem, deal with it. It's saying, hey, this is a problem and this is how you can fix it. And then you are in control of, when and how you accept those changes into your application. So to get started with Security Agent, there's two key requirements that you kind of need to set up to get going. The first one is defining your security requirements. Now, thankfully, AWS makes this quite easy because they have a set of managed security requirements, and then that you can just use. And then on top of that, you can layer in your own custom rules. Now, this is done across your Security Agent setup. So it goes across multiple applications. And don't worry, I'll go into a bit more detail about that. Because each application gets what we call an agent space. And so this is where you have specific details, things around your penetration testing settings, any specific design documents go into an agent space, and that forms the context that the agent will use to then assess your application. But the security requirements are more of that organizational level so that you can have common requirements across all of your applications. So touching on these managed security requirements, these are the ones that you get out of the box. Now, you can selectively choose to enable them or disable them as you desire. You have these best practices from AWS. There's 10 categories, which I'll show you in the next slide. And then you have your own ones on top of that, as I touched on already. So the managed security requirements, there's nothing too surprising here. It's all the kind of things you'd expect to see. You have things around, are you doing appropriate logging? Do you have authentication and authorization implemented? Is your information protected? Are you following good data security practices? Are your logs appropriately tamper-proof? Do you have privileged access controls? Are your secrets being managed appropriately? Are your defaults safe? Do you have multi-tenant security for those tenant isolation? Now, this is probably a good example of something maybe you would disable if you only had a single tenant application. And are you using appropriate levels and ciphers for your cryptographic operations? And again, this is something that when you catch it early in the process is a relatively easy fix. There's a few applications in a business context that specifically require some very unique cipher, but if you just say observe the defaults or potentially the default that a LLM gives you based on its somewhat dated knowledge horizon, then you may end up implementing something that is no longer best practice or appropriate. Once you've got those security requirements in place, you have to set up an agent space. And like I said before, this is a workspace for that context in a particular application. So this is where you'd have application-specific design documents. You configure the penetration tests about where your application is, how it should log in. And again, I'll show you that shortly. And then you can track all of the results from those penetration tests and also things like the code remediation examples. And it's all per application, like I already said. So time to get real. Rather than just talking about what you could have read in the documentation, this is my application. It's called Your Public Cloud. It's something I was able to present last year at AWS Summit Sydney. And this is a SaaS application that I built because I just wanted something that I could experiment on like I'm about to do now. Now, it is a real application. You can sign up for it and see all of the public resources in your AWS account. There's probably a few I still need to implement, but it covers all the main ones, obvious ones like buckets, API endpoints, CloudFront distributions, and the like. Now, some of these things should be public in your application, just to be clear, or in your environment rather. But some of them are not, and it often catches people by surprise what they do have kicking around in their AWS environment. I use this to test out the security agent features, and I'll show you what it looks like over the next few slides. So to start with, you create a web application. Now, this is how you interact with the security agent directly, rather than kind of the service itself. And so this is something that gets deployed into your environment. There's multiple ways to log into it. The default way is to just click a magic link in the AWS console and give yourself admin access. But thankfully, it also has integration with Identity Center. So you can say, hey, I want these people in my Identity Center to be able to access my security agent web app. And you can even give them different levels of access. Maybe they only want to just read reports, or maybe they do want to be able to trigger pen test reports. And it shows up in your Identity Center portal as a web application there. Now, the first part of the security agent functionality, like I explained earlier, is the design review piece. So this is where you get an AI-powered analysis, you upload your diagrams, it reviews them against those security requirements that you have set. So if you've enabled or disabled, or if you've added your own custom ones, it will take those into account, and then it will identify those vulnerabilities. And again, this is a great option for teams that are just getting started with a new project, so that they can catch some things early on and really just have a better understanding of the security process involved. Unfortunately, in my example for your public cloud, I didn't do a lot of upfront design. I know I'm sure you're shocked to hear about that. I just, opened up an editor and started coding it back in the day. And so my design review was not particularly useful here. So this is actually a screenshot of the web app that you will get once you've completed that. I actually tried to cheat and ask Claude to generate a summary of my application. And security agent, quite rightly, in my opinion, said in almost all cases there was insufficient data, and in one case it was not applicable. Now, I think it's probably worth mentioning that the your public cloud application is relatively small in scope. So you set up a cross-account role assumption, you deploy that into your environment, you give access to the app, and then it goes out and checks for the configuration. So there's not a lot of user input there. There's not a lot of settings to control. You really just choose what accounts you're in. So there's not a huge attack surface there, but you'll see that more when we get to the pen testing. But yeah, unfortunately, I don't have a good example for the design review functionality. So this is something you should go and try yourself if you do have those design documents. But unfortunately, something that I did not have. Moving on to penetration testing. Now, this is probably where the bulk of security agent functionality and value is. So here you can see the high-level results from a penetration test I did. And this allows you to kind of trigger that pen test, walk away, come back a few hours later, and see kind of where you stand. In order to get the penetration test working, you do have to do some setup. So I'll just go through that at a really high level here just to show you what it looks like for real. So here you can see that I'm setting up the various domains I would like to test. Now, it's very important that you own the domain that you are testing, and there is a few verification steps that you have to go through because Amazon doesn't want you pointing this at someone else's website, understandably so. So once you've created your domains, you have to verify them, usually using a DNS record. You can then specify the out of scope URLs. So these are URLs that you do not want the agent to test. You may also want to add additional URLs so that you can, fine tune exactly how the agent interacts with your application. And finally, you can set particular headers. If this is something you want to be able to see, maybe what the agent's doing on your side in your server logs, you could ask it to set particular headers. Once you've got those high-level settings set up, you then have to give it a few permissions. This is mainly for doing things like sending logs to CloudWatch logs. So you give it a role so that it can do that. Down the bottom here, you have this automatic code remediation here. Now, I would recommend that you do not tick that. Don't worry, you can ask for the code remediation later on. I did this and it did generate a lot of PRs in my environment. Now, there is a reason for that I'll go into. Basically, my application is a mono repo, so I had many different stacks, types of functionality. So it did generate a lot of noise. So if you don't have a mono repo, then you might want to turn this on, but later on I'll show you how to get the same functionality from the pen test report. Once you've done that, you then get the option to set up your VPC resources. So this is if you are testing an application in a VPC, and my application was available on the public internet, so I didn't need to worry about this. And finally, you have to tell the agent, how is it going to log in? Now you can simply not do this, and then it will test it as kind of a black box kind of remote testing. But there's not as much value in doing that. So this is actually an example where I was going back to an existing pen test that I'd set up. So the first time I went through, I input my testing credentials, and then in the background, it's put those into Secrets Manager for me. And I then give it a little bit of description about how it should log in. In this particular case, I'm using Cognito's hosted login interface. So I just gave it a brief little introduction about that, and it had no troubles logging in. Finally, you can give it additional context. Now, this is another thing which you don't have to do, but I would suggest that you do because you will get much better results from it. So in this case, it can actually see my GitHub repository that is called Mars, and it will then use that to kind of inform the things that it's testing. So it's all additional context, which, as most of us know by now, you will get much better results out of your AI and agents if you give it more context. But, you know, there may be reasons why you don't want to do this. So it's something that you can configure on demand. You can also add things that are not necessarily code here. So you might have additional documentation, maybe API specs, things like that, that you want the agent to keep in context. So you can add those here as well. And then at this stage, you get taken back to the high-level status screen so you can see how that's going. Now, in this case, my test is already complete, and I can see a very high-level summary of my historical tests that are there. Now, something I should have called out a little bit earlier in greater detail, but I'm going to do it now. I'm going to give it its own slide, is only test this in non-production environments. Do not go pointing this at your production environment. At the end of the day, it is an automated process and may do things that you don't expect. And when we're talking about things like penetration testing, that could potentially result in the loss of data. So if you only take one thing away from this talk, I would like it to be this thing. Please do not point this at your production systems. Give it its own, or give it a development or a staging environment, you know, something where if something does go wrong, it's not going to be the end of the world. And yeah, you'll just have a much better time using Security Agent. Just leaving this slide up just for a little bit longer to make sure everyone knows that I am serious. So what does it look like at the end? So here you can see the result of my pen test. Now, nice thing about this is I didn't have any criticals, and I'll go into a bit more detail about what those findings were. This is kind of a little bit clipped off, but look, the report looks really nice. I really like the report. You can now export it as a PDF as well. So from that perspective, it's just a surprisingly good report to look at. And you get a nice breakdown of the various categories and the risks involved. You can also see how long it ran for. So here it ran for 2 hours 21. Now it's important to know that that is not the amount of work that was done, because a whole lot of testing gets done in parallel. Come back to that a bit more when it comes to pricing. If we jump into the actual findings, here you can see the findings report. And so you can see the various results here. Now, this is where there will be some, you can see at the top there that the hide false positives button is ticked. So the agent, you know, is a little bit eager. Sometimes it will find things that aren't that important. And, you know, I would probably argue that this high severity finding here about my hard-coded Sentry DSN, this is just my unique identifier that identifies me to Sentry, the bug tracking service. It was hard-coded because I had to put it somewhere. Is this a high severity finding? No, it is not. So, you know, I probably should give feedback on this finding here. But this is the kind of thing that you do get from AI-based assessments. You know, looking at some of these other findings here, missing DynamoDB transaction boundaries with multi-step operation, like, you know, if it was an extremely high volume website, then maybe that would be a concern. But right now, I'm not worried about DynamoDB transactions to ensure my data is completely accurate, because this application is not going to challenge DynamoDB's performance in any way, shape, or form. So some of these findings are maybe questionable as to how important they are, but they're not wrong. They are things that could be improved in my application. For example, down the bottom there, it says sensitive data logging. Yeah, I'm not filtering any, but there shouldn't be any PII in this application because it is just checking for AWS resources. So these are the kind of findings you'll get. There are some findings, though, which did surprise me. I'll show you those once we get to the code remediation. Here you can see also these buttons at the top here, the resolve finding and remediate code. So just like I said, if you don't tick that box in the initial pen test setup, because when you do tick it, it will generate PRs for all of these things. And as I've just said, some of these things I don't really care to fix. But here I can selectively go through each of the findings and click remediate code and get a PR just for the things I care about. So that's a much less noisy way to do that. And if you were to scroll down on this screen, this is just a screenshot, you would see a bit more of the log about how the agent reached this. And it's really cool because you do get to see the reasoning involved, which is good. Now, this is something that's actually just changed last week. The pricing for the penetration testing functionality has been announced. So slightly confusingly, the pen test functionality, if you remember, I talked about the three parts of functionality: design review, pen test, and code remediation. The pen test functionality has gone GA. The other parts have not, and so do not have a cost associated with them, but pen testing now does have a cost associated with it. It's metered per second, and it's charged at $50 per task hour. They reckon that the average app takes around 24 hours of task time. So that's not duration. For example, a pen test that might take 4 hours could have, nearly 20 hours of actual task duration in the background. And that's what you're going to be charged at. There is a free trial I believe it's for free tier customers. I'm unsure if it applies to non-free tier customers. You'll have to check the documentation for that. And you do get a bucket of task hours to use. And so this is something that you kind of have to keep in mind. If you're comparing this to a actual external pen test, this is quite cheap. This is actually pretty good value in terms of what you get. I'm probably not going to, for my own personal application, I'm not going to schedule a weekly pen test at that kind of cost, but it's definitely something that is, if you're building a new application from scratch, if you can run this test, get this feedback early, incorporate that feedback, and then go for your external pen test, you're going to have a much better result and get a lot more value out of that external pen test because you have done this first. So look, it's something to be aware of and keep in mind that value, like a lot of Gen AI things, it's hard to know exactly how long this thing will take when you start it off. My application is relatively uncomplicated. It took about 2 hours of duration. So, there's probably maybe, 3 times that in terms of task duration in the background. So if you're building a much more complicated application, with a lot more endpoints, a lot more interactivity, a lot more resources from like a REST perspective, then, I would expect it to cost more. Moving on to the third and kind of final pillar of functionality in Security Agent, it's the code remediation. So as I said, this is something you can turn on for your pen test. It's something I turned on. At the moment, it only works with private GitHub and GitHub enterprise repositories. So if you did have a public repo, you could just fork it and make it private, and that would make it work. It creates these pull requests, and the pull requests are quite nicely documented. So here you can see just a really high-level view of what happened to my repo after I did my first pen test. This is just a fraction of them. I think I ended up with over 20 PRs. So like I said, next time I will probably change that and just do it successfully. And it did pick up some things that I was actually surprised that it picked up. So for example, there's one there that is, where is it? I think I go into it in the next slide. Didn't make it into this screenshot, where it talks about the business logic. And so it did actually identify a failure in my business logic, which I'll show you shortly. Each of these PRs is quite well isolated. So you can go in there and selectively choose which ones you want to include. They did lack some context, as you might expect. Probably that was partially my fault. I could have given it more context in terms of design documentation or any other things that I wanted it to focus on. So, it shouldn't be too surprising to you now if you've worked with LLMs or Gen AI in any kind of capacity. The more context you give it, the better results you'll get out of it. But ultimately, I found this a really big time saver, especially for some of these simple fixes that I knew I should have done, but I hadn't done because, hey, it was just me working on this. And being able to just go in, especially for those really kind of discrete things, and just go, yep, that looks good, merge it and be done. It was just much, much faster than if I'd done it myself. This is the issue I was trying to find. So this is finding that I had implemented paid tiers in my application, but I hadn't actually gone and enforced it. And I knew that was there. And I think I even mentioned it in my talk when I gave it back at Summit. I was like, look, it says you got to pay for it, but you don't have to pay for it yet. Now, unfortunately, I have gone back and implemented this now. So I do actually check for a active subscription. You do get a free scan. You don't have to pay for the first scan, but if you want ongoing scans, you do have to pay for it. And so it was a really nicely written and composed pull request. And again, this is more of a business logic failure that was resulting in, unauthorized access to scanning resources. So I thought it was a really good pickup by a security agent. So just to summarize, the pen testing functionality is GA and you do have to pay for it, but the design review and the code remediation functionality of security agent are still in preview, which means there's no charge associated with them right now. That may change soon. At the moment, it's still console only. You do interact with it via that web app that I mentioned. So there's no CLI that I'm aware of yet, although again, as it reaches GA status and comes out of preview, I would expect that to change. The findings that it has do require review, but they are very helpful, and I think they can save you a lot of time, especially if you are operating in a security conscious environment. So in terms of best practices, use it as a feedback tool. And I think the sooner the better, so especially if you're in a team where you're focused just on the business side of things or the application side of things, it can give you that security input as soon as possible that will result in a better product overall. If you can, you should customize those security requirements as soon as possible. The default ones are good. They'll get you a lot of the way towards a secure outcome. But if you do have any particular industry or business requirements, get those into your security agent as soon as possible. Keep an eye on those task hour costs. Unfortunately, it's probably one of those things where you just have to try it to see and obviously be prepared for it. So take advantage of that free window that you get, but make sure that you are in an account that does qualify for those free hours. And that will help you really get a much better idea of how much task time is actually going to take to run your pen test. Give feedback to the service team, help make the product better. In my case, I ran this pen test a couple of months ago. I really should go back because I'm sure they've improved the assessment in the meantime. And finally, in case you missed that large orange slide earlier, do not point it at production, only point it at a non-production environment. That's it for my talk. Thanks very much for listening. If you want to connect on LinkedIn and talk more about AI and particularly AI security, I would love to connect and have a great day.
Kia ora koto everyone. I'm Arshad Zakaria, aka Zach, AWS hero based in New Zealand, Aotearoa, platform engineer in Kubernetes space. I'm a senior engineer at Xero and a lovely husband. I love collecting Legos. Yes, I love cooking and I love traveling. If you want to connect with me, you can scan this QR code, connect with me to LinkedIn or email, whatever the easiest way. I'm happy to help with anything, any question you have. Yeah, so today's session, I'm not going to have any slides or anything. I'm just basically going to do a whiteboard session with some live demo, which I hope you will enjoy. I built something really interesting. I'm going to share the story, why I built it, how I built it, what are the failures I faced, and what are the tools I used. So those things. Let's get started. Cool. You can see I have a one sticky note on this board, but don't worry, we are going to do a really good whiteboard session later in this session. You know that we have been hosting AWS communities in Aotearoa, New Zealand, and we always found this not a blocker, but there are some tools to collect feedbacks, because after event, we would love to get your feedback to improve our next sessions. Also for the speaker, let's say after this session, I'm going to share a feedback code and you're going to submit a feedback where Zach can improve, how I can share, what are the things I should have done better or should stop doing it in the future. So you can get the feedback. So feedback is very important us to improve ourselves and improve the community and give back to the community again. Right now, I think you have already watched a couple of amazing sessions of the virtual community Oceania. While we organizing this event, we had a budget, right? Because every organizing events need a budget. It spends a lot of cost and a lot of human power. We have to spend a lot of time after work because we're all doing a day job. So after that, we have a couple of goals to make sure everything is aligned. And since this is a global event, we have to make sure we are reaching out to the speakers in the right time zones, and there are a lot of things to do. One of the things when we planned the feedback platform, last year we used a different feedback platform. Then we realized we are doing a community event, right? If we can save some money rather than spending on these big numbers on these feedback platforms, we could be able to save that money and use that money for something else, like print some or share some amazing stuff when we host our in-person events, like we can pay for our food and beverages, many things. We thought of, okay, let's do this. So when we had these meetings, I took this challenge and I challenged the team, why not we build something very simple for the community? Because there are other feedback platforms out there, but those are like, comes with a lot of features which are not good. We are not going to use, to be honest, for a community, right? Because we just need a simple feedback platform where we can collect feedback and share a report with the audience or the speakers itself on like that. So we thought, okay, let me get into and build this platform. Since we are in the Gen AI era, I thought, okay, let me work with my very good friend Kiro and let do something amazing. So eventually I was able to get things done very well. And now we have a live feedback platform where we can use for these events. So not only for this event, there are some other events also going to use it in the future. And there are some events already being used in the past. So I'm very happy as a YB engineer, able to give back something to the community. Not only for this platform, let's say you're going to build something amazing. So you have a lot of thoughts and ideas, right? So you need some requirement to gather. So the specialty about Kiro is spec-driven idea, I would say, because rather vibe coding, you can do vibe engineering. You can have a nice spec, a plan, an implementation, tasks, and you can get going. So later we are going to see some live stuff on the IDE. I'm going to show you how I use these things and so on. Yeah. Cool. So let's say you have a requirement, something you want to do. Let's say you need to have the product. Oops. Product. So the product itself, like what is the product about, right? You have to give an idea like, okay, my product is like this, and I'm planning to have payments later, or I'm going to give it this for a free version. What are the tiers I'm going to have? So you have to describe your product very well. What are you going to do and what are you expecting out of this product? So it can be a web application, it can be a mobile application, something like that. So you have to make sure you have to write these things in a doc. So I usually use my notepad or iPad to write all those things in a human word. like my own brainstorming, I was able to collect all this information together and create a small doc, and it contains all these product ideas. Better to put as like product idea. Then in Kiro, you can create a spec out of this product. Like you gotta make sure all these informations are there. So in product idea, we can have a separate path. Okay, let's say how fast you want it. Let's say if it is a POC, you want to get something like the main structure, get it done and ship it. Because I always believe these AWS principles. One of my favorite principles is bias for action. Ship fast and get the feedback and improve. Don't wait until you're 100% perfect one. So ship fast. So in that case, you have to get your POC ready. And under that, we can have especially tech spec. So the tech spec, you can define how are you going to do it. Like it's a mobile application or web application. Let's say web application. In this case, a web application, I used AWS Amplify. Amplify is very easy and amazing, easy to deploy your Node.js application. And I was able to do it via JS and Tailwind CSS, those kind of things you can spec under that one. And your API spec, I use AppSync, then the database, DynamoDB tables, all those things you have to clearly give to that spec document itself when you're starting. So you have to document all these things properly in your draft, like before we even go to the ID itself. This is not only the main thing, because we can give all the specs and all those things and it can do amazing stuff, yes. But have you noticed this hallucination? Like you're trying to do something in a different AWS account. Let's say you have multiple AWS accounts in your AWS config, locally configured, and it's trying to do in a different one always, like maybe the default one, but you want to go to your dev environment. So these things can be solved by something called spec, something called steering documents. So this is my favorite part of Kiro. I can have some steering docs. So part of this, I am putting something like a guardrail. I can tell what to do and the one, what not to do. So I can make sure, I can tell what to do and what not to do. And same time, we will talk about some spec, I'm telling like, use Next.js or Vue.js, something like that. So even, for example, I can tell here, use Next.js version like this XX version. I can tell that, this specific version I want in this application. So it will make sure it will use only that specific version. It won't go out of that, which means you can save some tokens. That's a new currency we are talking about these days, right? And we can make sure that we are under that guardrail. And another thing I learned while doing it. So rapidly I was changing and pushing to my dev environment and testing it out and everything, right? I use all the production level best practices to vibe engineer this one. So I want to make sure in my GitHub repo, I'm not allowed to directly push to the main branch. I want to create a PR, and the PR has some checklist and it runs some security scanning. So once everything is done, tested only, I could be able to review it and merge the PR to the main branch, which will build a GitHub action pipeline to deploy everything to the production environment, which is amazing. So I noticed something initially, try to push directly to the main branch. I was like, oh no, don't do this, right? Then in what not to do section, you can write in your steering docs. I can show you in a bit later. I mentioned use GitHub CLI tools, or you can use MCP tools as well. Tools to query and check with your GitHub. And this not only for making sure you're avoiding not push to main branch. So rules like don't directly push to main. Always push to dev first. Something like that. So in this case, it didn't push directly to the main branch. Always it will push to the dev branch and test it out. And also, I found amazing thing, like rather going back, let's say my infrastructure changes, like GitHub Action, I am using CDK, and the CDK infrastructure, sometimes it check the diff, and when it's applying, sometimes it failed, right? I don't think anyone like deploy a success build in the first build. Always there's a failure. So that's how we learn from the failures, right? When the GitHub Action failed, I don't have to come and tell it always. So I put like strictly saying, use GitHub tool to check GitHub Action logs. So when it push a commit, and it will check with the commit, okay, this is failed or success. And if it failed, it will go and reiterate and check, okay, oh, this is the reason it failed. And it will update again its docs to make sure, okay, next time we have consistent data and the proof what to do next. Cool. So overall, it's something similar like this. So this is something like very high level how I use this mechanism to build it, but there are a lot of multiple specs and everything I will be show you in few minutes later. So this is a good start. If you have a requirement or idea, like a dream to build, always come up with, first start with the POC. Make sure your skeleton works well, and don't worry about the UI, those kind of things initially. You can improve always later, and keep improving, and make sure do a deep thinking, and make sure when you build something, make sure it should be able to do any changes in the future without zero downtime. So that's how I built it. Even in the spec docs, I have mentioned, okay, I might migrate this. Let's say if this platform is going to be like massive and I have to increase more compute powers, and let's say in a way I want to move this to a Kubernetes cluster or EKS. So in a way I have built it like supporting all these future scenarios kind of thing. So later I don't have to worry about, okay, I might need any big downtime to get things done. So always think critically. Critical thinking is very important when you're doing web engineering as well. Definitely the POC should be done, but once you improve the POC, you should be able to improve the future changes as well. Cool. Now quickly have a sneak peek of the spec docs and the Hero configuration, which I was talking about before. Cool. So you can see I have multiple specs. I didn't just vibe coded this. As I mentioned, I vibe engineered this. The reason, you can see AWS amplify event feedback. So first one is basically I wanted to have a basic event feedback platform where it can run in Amplify and all this information, and I managed to up and run and test it out, the initial one. It was all good and nice and went well. So the initial version, it was able to check the feedback on a web browser, then it should be able to download the exported PDF file, then the PDF file we can be able to share it. So I did a kind of like a demo to the team, our virtual community Oceania team, and they really liked it. Then this is how the requirement comes, right? Like the feedback, that's why I'm talking about, like feedback is really important. Then our dear friend Paul said, Zach, last year we had some problems, not problems like hurdles. We have to go through the feedback platform and download the PDF file and attach to email and send it as attachment. So he suggested, okay, what about like a shareable link? So we can generate a shareable link, a secure link. We should be able to share with the speaker so they can check their feedback. How did they do? And all those things. So I created a separate spec for that. So once everything is done, push to dev, then it's pushed to production and everything is good. Then I created a CloudFront shareable link with that. So before CloudFront, I used the S3 link to do it. Then my dear good friend John, Zach, he tested this app. He said, Zach, your S3 bucket is visible. I think it's good, not a good practice. I didn't even notice about that. Yes, because it's better to have something like CloudFront. I added all these things to my docs again, and I was able to create a CloudFront shareable link. So thanks, John, for that. And it's live now. Then I wanted to give this to the community for free. If you are hosting a community event, I would love to give this to free, because when I did the spec planning, I should mention something here. The most important one is the cost. In my docs, I mentioned I want something in minimum cost, but make sure it's secure as well. That amplifier last year released some amazing features, like from Amplify itself, you can enable the WAF, web application firewall, and enable some rules for the firewall and CloudFront, everything. So the production one is like totally enable the firewall as well. So make sure avoid from any vulnerabilities or threats. Running this environment on my AWS accounts, thanks to this Heroes program, I get a lot of AWS credits. So I should be able to run this within those credit limits. So I wanted to give back to the community. So I thought, okay, if anyone's hosting an AWS Community Day or any meetups, just reach out to me. I'm more than happy to set up your account and do those things. So I came up with something like community tier. So the community tier is not, it's on beta, which means I want to make sure test it properly. So community is like people can register. So in my admin backend, I can allow and deny and say, okay, this is a legit requirement or request. So I can give them the access, and so they should be able to use in their community days. I wanted to have some bug fixes, like I found some bugs while doing it. Okay, oh, what if different scenarios, right? What if the event is expired and still people should be able to do feedback? It should be, right? So those kind of teeny tiny bug fixes I did. And one of amazing community user group leaders via the AWS user group Slack channel reached out to me and asked, Zach, can we have a feature add custom questions? Initially, the first version, right, I deployed as, okay, there are basic questions and people can ask those questions. But I understand that some geographical locations, some communities have different questions to ask, right? I thought, okay, let's add that feature as well. So I was able to add those feature. Yeah, thanks to Kiro. And there are some feedback and UX fixes on the way I did, and there were some issues with the reporting, and some questions are not showing on the reporting. I fixed it, some event formatting, and there is something with the rating. So there are some custom question had some issues with rating. So I had to do all the testing. So the Kiro itself, it writes all the test cases as well. So there's a chance, right? Like it can miss some test cases. So we have to make sure when you're web engineering, you have to properly manage all those things. Cool. This is all about the specs. You can see it's going to be keep building because I'm going to keep add new features, new specs are coming. So I always love to go with the spec, and here you can define, okay, even it's a new feature once you build it, or it's kind of bug fix. So another thing I noticed that and learned, if you have bug fixes, Kiro is intelligent. It says, okay, you have multiple bug fixes. Let me focus one at a time rather than creating another spec for all the bug fixes. So it's really went well. It picked one bug first and it creates the specs, design and task again, and multiple times for each and every bugs, and it works on it and fix it very fast. It's really cool. So this is steering docs I mentioned. So the product document, I say, okay, AWS Amplify feedback event application, low cost, scalable platform for collection and anonymous feedback from event attendants. So all my product ideas are here, and the product structure, how the folders and everything is structured, and the technical specifications also here. So I'm not gonna go deep into that. There are some information I don't want to share because there are some information which are like account IDs and other stuff. Cool. Even since I have two environments for this, so it initially suggested me, okay, Zach, better to have two each separate environments for dev and production, so you can test everything in dev and the production is separate production. So I'm using for authentication like IDP as Cognito. So Cognito is basically my authentication platform. So very easy to integrate with Amplify, super easy and secure as well. Cool. Now let's go to the feedback Fedora. This is what I was talking about. This is what I built. It's very beautiful, right? I love Fedora, to be honest. So if you're watching this, I'm a big fan of Fedora. It's a fruit kind of flavor, like a mix of pineapple and guava, but it's nice. So it's a season here in New Zealand at the moment. So if you go to the feedback.fejoa.com, you can see all this, what it can do and everything, but I'm gonna show you a live demo now. So I created the Fejoa project test app. So this is how you get it, like when you log in. And currently I don't have anyone in my users. So in community, you can invite 2 more users as well. So in project, you can have multiple events. For now, as a testing, I'm providing only 1 event per project, but later on I'm planning to add multiple events for 1 project. Cool. Let's create something like Fejoa Fest, and Zach loves Fejoas. So let's go with virtual. So in-person virtual, I have like different subset of default questions, so it changed. Since I'm recording on Friday, so I'm gonna put from Friday until like 30th. And these all are small tweaks. I was able to get it done via the feedback I received, and yeah, create. And it will create a unique code for you. That's it. That's it. So it comes with some default questions, but you can add some custom questions as well. And this is for the event overall, like how is the event? Like this is a virtual event, right? How the video quality, streaming quality, and this is about the speaker. So I'm gonna create a session as Fejoa 1-to-1 Zach and add a session. Cool. So session is created. So if you want to share the QR code of this session, you can download the QR code, or you can copy the link separately for this session. So this is how it looks like. Very simple and beautiful. And if you want to share, let me add another session. Let's say Fejoa meetup. Oh no, so event, right? Fejoa talk or something. And this one is, let's say, John. Cool. So I will, if I copy this URL, so this one for the John's talk, and we can give the feedback. And if I copy this one, it's like overall your main event and all the speakers as well. And if I want to give the event only, so the event, about the event, we can give the feedback. So let's give the feedback. How do you rate the streaming quality? Let's say 5, and audio video, let's say 2. And how you rate the event overall? Let's say 4. And love it. Zach needs a haircut. Just for fun. Cool. So this for the event, right? Then let me go back to John's rating is 5, and let's say how do you rate the speaker, this overall, and the rating for the speaker, let's say, sorry John, but I'm gonna give you 4. How will you rate the content? I'm gonna give you 2 because you didn't have much Fejoa pictures on the slides. So just joking. Love it. Any additional comments you can, it's optional, you can leave it and you can submit. And let's go to the Zach one. Let's say Zach 1 is 2 overall, and the speaker, let's say 4, and content 0. Let's say 0 Fejoa pictures. Nah, submit it. Cool. So this is fully anonymous and nobody knows who's giving the feedback. And once it's done, so as the event organizer, you can go here and you can click view report. Cool. I forgot to mention something. Here you can see a go live button, right? So once you finalize all the questions, before you get any feedback, you have to click the go live button. Once you go live, you basically lock your feedback platform, because we have to make sure once you receive the feedback, even as a transparency, you shouldn't be able to update any questions, right? It doesn't look good. So I just put that option there. I'm still looking for feedback. Maybe I will remove it. I don't know. So let's see how it goes. So the report section, you can see the reports for each speaker, and you can see report for each main event as well. So we report, you can see 5-star, 2-star for the audio video quality, and all the comments are here. Yes, and report for your one-to-one. You can see how would you rate the speaker and total events and everything. So the other best part I was talking about, like the shareable link. You can click the share link and you can see this one and copy or share with your speaker. It will generate a nice speaker readable reporting here. And same time you can able to export a PDF as well. So this is what I built and my journey, and feel free to give a try, and I love to get some feedback as well from you all. And yeah, if you're first time hearing about Kiro, go to the kiro.dev and download it for free. So there are some free credits when you're starting, and if you have AWS credits, you can use AWS credits as well. You have to use AWS Identity Center for that. If you have any questions, please feel free to reach out to me. I'm happy to help. And you can check builder.aws.com. So here the Builder Center, all the amazing blog articles, a lot of conversations are going on, and you can find your community from here, who are the heroes and the community builders and the user groups. You can check what are the user groups available here and the cloud clubs for the students, so on. So thank you so much for watching this, and I hope you had a really good time listening to this, and hope you learned something, and feel free to share some feedback through the feedback platform I built. And there are amazing sessions ahead waiting for you, and go and watch, enjoy. Please do some interactions through the comments or chat. You can learn, share the feedback, and I hope you have a really good time. Thank you. Bye.
Okay. Okay, welcome to my session on implementing an effective EKS observability strategy. My name is Dale Orders, and I'm a software engineer at Five9. And today we're going to be discussing how it is that you can develop an observability strategy. And we're going to particularly be focusing on how we can integrate both Prometheus and Grafana into your observability stack. So without further ado, let's take a look at the agenda. So today we're going to start with an example of an observability stack. So I'm going to present an architectural diagram where we can see the necessary features that our observability stack should have. We're then going to delve into Prometheus. So we're going to look at what Prometheus is, how we install it, and how we can use it to glean insights from our data. We're then going to look into Grafana. So Grafana is a virtualization platform. So once we have the data, how is it that we can actually display the data through virtualization? And finally, we're going to look at some common issues that you may encounter. and how it is that you can potentially address those issues. So that is today's agenda. Okay, so to start, here is a very common situation. We have our AWS account, and you'll see here that we have a cluster. On the left-hand side, we have our control plane, and that is going to manage both of our nodes. Within our nodes, we have our applications running. So you can see there, we have an application running in both nodes, in both regions, in both availability zones. So how is it that we can take this situation? How is it that we can develop an observability strategy around this very simple setup? So first thing we need to do is to actually create the cluster. So for anyone who is not familiar with EKS, we use this command here to actually deploy our EKS cluster. And that once that's deployed, that will give us this setup here. Next, we have to think about how it is that we can actually use observability within this design. And one such way we can do that is through the use of Prometheus. So Prometheus is a service that is designed to extract metrics or to pull metrics from our applications. So if we look at the screen here, we have our Prometheus server that is deployed into our cluster. You'll see that it is pulling metrics from both the application and the Prometheus node exporter. So the Prometheus node exporter, we know that we have our application there. The question then is, what is the purpose of the Prometheus node exporter? So the Prometheus node exporter is a pod that is designed to collect the metrics that pertain to the actual node itself. So that includes things such as CPU, memory, disk input and output. All of that data is being collated and is being pushed to the Prometheus server. So in this scenario here, we are collecting both metrics from the application as well as from the node itself. And how is it doing that? So if you look at the screen here, you'll see on the left-hand side, we have our node, which has both our application and our Prometheus node exporter. And on the right-hand side, we have our Prometheus server. Now, the Prometheus server contains three components, the first of which is the retrieval worker. So the purpose of the retrieval worker is to pull metrics. So what it does is it pulls the metrics from both the Prometheus node exporter and the application. It then stores those metrics in the time-based database, which you can see to the right. And then finally, when a user makes a HTTP call to the server will then pull the metrics and then return that to the user. So let's see how that actually works. So there is both our application and our node metrics being sent to the server. So this is how it actually works in practice. So our retrieval worker sends the HTTP request to the targets. The targets then send the data back to the retrieval worker. This data includes things such as metric name, timestamp, and value, which we will see later on when I show you some examples of the metrics that it collects. Those metrics are then pulled into the time series database. When a user makes a call to the API, the server is going to query the data and it is going to return the metrics back to the user, which can be displayed in the form of a graph. And I will show you what that graph looks like a little bit later on. So we know the importance of the node exporter. We do need to have information about how our node is operating, but how exactly do we install it? Well, if you have, and you can see here on the left-hand side, I have a node with both my application and the node exporter. To actually install that node exporter, I need to create a Kubernetes manifest, which you can see here on the left-hand side. So I have to configure that specific node exporter, which is fine if you're just creating the one node. That doesn't seem like too much work. The problem, though, becomes as you increase the number of nodes, for each node that you want to add, you have to add an additional configuration. So every time you add a node, you have to add an additional configuration, which then has to be installed on that node. So as you can imagine, that can be quite time-consuming and can lead to errors. So the better way of doing it is to use something called a daemon set. So what a daemon set does is it ensures that every time you add a new node to your cluster, the node exporter is automatically installed onto that node. So if I start with one cluster and I add additional clusters, it doesn't matter. I don't need to do any additional configuration because every time I spin up every time I use a new node, that will automatically have the necessary node exporter installed in it. So then the next question is, how do we actually install Prometheus? So to use Prometheus, we do actually need to install quite a lot of resources. So here on the left-hand side, you can see a number of different resources that we need to create. That includes the node exporter daemon set, which I just mentioned. It also includes Grafana, which I will be talking about a little bit later. It includes Prometheus, obviously, and it also includes a particular function called Alert Manager, which we won't be covering today, but that is something else that is included. And how exactly do you install this? So you can go through the process of actually creating each of these resources individually. So you can create the pods, the services, the deployments, the stateful sets. In fact, if you wanted to create all of those resources, you could do so. However, you would have to create each and configure each individually, which, as I said earlier, is not ideal. A far better approach would be to use Helm to install Helm charts. So to run this command here, and then to install the Kube Prometheus stack. So within 2 lines of code, you can install all of those resources without having to do any additional configuration. So that is the recommended way of installing Prometheus. When we are looking at observability, we have to be able to, once we've got the Prometheus stack installed, we then have to look at how we can configure some of these resources. So within Prometheus, there's something called Service Monitor. So you'll see here on the left-hand side, I have a resource object, which is called Service Monitor. This is a custom resource definition that configures Prometheus to scrape from the target. So this is what we need to create to ensure that Prometheus can actually scrape from each target within the application. So the first thing you need to do once you've defined the kind is then to fill in the metadata. So you'll see here I have the metadata, the name, the namespace, and the labels for this particular service monitor. And you'll see here that I have a particular field called release. Now, when you are creating your service monitor, it's really important that you do have the correct name for the release. So the release should be the same name as the stack that you installed your Prometheus with. So we see here, I named mine Prometheus. The release should therefore also be named Prometheus. So it has to have that alignment, otherwise it won't be able to detect the relevant targets. Next step is to fill in the spec. So you'll see here we have the spec on the left-hand side, and we have our service definition on the right-hand side. We have to make sure that the selector and the namespace selector are the same. So if we look at the selector for the service monitor, you'll see that the key is app and the value is demos-app. That must match the label of the service. So you see that it does. So that helps it to detect the service that it needs to scrape from. But you also need to make sure that you have the same namespace. So in this case, my namespace is demo-app, which is the same namespace that is defined in my service. So those two things must also match. And finally, we have our endpoints. So when you are configuring your service monitor, your port has to be the same as the name of your port on your service. So you can see that both are labeled HTTP. Yours might be something different, but in this case, I've elected to use HTTP. And finally, you need to expose your application. So you'll see here, I've got a Flask application and I have a route that's called metrics, and that aligns with the path in my service monitor. So when you actually create your service monitor, you have to make sure that you have the correct alignment in order for Prometheus to be able to detect and to scrape from the relevant targets. So going back to the design, this here is what we currently have. We've installed our Prometheus server. We've created our service monitor so it knows how to detect the targets. And we obviously have our Prometheus node exporter. Now, for the purposes of this demo, I am using, I've decided to use port forwarding to host the application on my local host on port 9090. But obviously, if you're doing this in production, you would instead be using load balancers and DNS. But for today's purposes, I'm just going to be hosting it on my local host. So what does that look like? So if I go to localhost 9090, you'll see here we have Prometheus. So this is what Prometheus looks like. We have a section which says demo requests total. So that is the specific metric that I want to query. I put that in there and then I press execute and it shows me some metrics, which confirms that Prometheus is in fact scraping the data correctly. So that is what it should look like. I then have the option of being able to display that data. So Prometheus does have it has the capability to produce graphs. The graphs do tend to be quite basic, which is why we will be using Grafana in just a moment. But this here is what a graph in Prometheus looks like. As I said, we are going to also be covering Grafana. So we do have the ability to create graphs in Prometheus, but it is preferable to actually use Grafana. And I will be also hosting the Grafana server on port 3000. So again, local host. When I open that up, it takes me to this website. Once I log in, I have the option of being able to create my own graphs using the data that has been scraped from my application. So you can see here on the screen, I have at the very bottom, I have demo request total. So I've got the same metric. On the right-hand side, I've got a number of different visualizations that I can choose from. So you can see already that we have a greater degree of functionality compared to what we saw with Prometheus. So that there is what a Grafana graph looks like. And then finally, we have the ability to use Prometheus Alert Manager. So you would use this if you want to to create an alert, which would notify you should your metric exceed a certain threshold. This is another capability that is on offer. It's not one that we'll be covering today, but it is good to know that it exists. So common issues. So we know how to install Prometheus. We know how to configure it to scrape the data from our targets. But what happens if we encounter certain issues? So the first is, how do I ensure that my observability stack is set up correctly? So going back to Prometheus, the way that we can verify that is first going into our localhost 9090, so which will take us back to Prometheus. We have a section called targets. Now, because I created the service monitor and called it demo-app, you can see there at the top there, that should be, if it is working successfully, that should be reflected in my targets. So you'll see there we have that. And on the right-hand side, it will actually say, it'll be in green and it will say up. So if it is correctly connected to those targets, it should be shown there. We can also check the application. So I exposed my metrics on port 8080. If I go to that, I can actually see the metrics that have been produced from my application. I can take one of those metrics, so the process CPU seconds total, which I've got highlighted there, and I can paste that into Prometheus query, and if I execute it, it should give me back some data. Okay, so that confirms that it is in fact working as expected. And I should then be able to go to Grafana, and I should be able to paste that same metric there, which is in red at the bottom, paste that same metric there and press enter, and that should show me the data reflected in my graph. If it says no data, that means that it hasn't been successfully scraped. So that is one way that we can ensure that we have successfully set up our observability stack. Now, if you find that the data is not being reflected, there are certain steps you can take to ensure that you can troubleshoot why it isn't working. So the first, of course, is to make sure that your service monitor is correctly configured. And we went through that previously, the particular fields that have to align. You have to make sure that the service monitor selector matches the service labels, which we saw earlier. In my case, I'm using port forwarding, so I can actually make sure that that command has actually been run, and then again check. And then finally, making sure that the port name is correct. So again, as we saw earlier, both were HTTP, going through and making sure that those do in fact align. Why has my request rate dropped to 0? So you may be using Grafana, it's set up correctly, it's working as expected, but you may find that you encounter some issues. So the first of which is you're looking at a graph and you may see that the request rate has dropped to 0. So this particular PromQL that I'm using is rate demo request total. So looking at the total number of requests that have been made to my application. This graph does not show 0. It's rising, but say, for example, it has fallen to 0. I would then need to explore why that is. And the way that I could do that is by, of course, checking my pods to make sure that they are not in crash loop back off or that they're not in a pending state. Check Prometheus to make sure that both the nodes are in an up state. Look at any recent deployments to see if there was a recent deployment that may have broken the application. And then finally, check the logs on the application. So going through those steps, we can hope to find out why it is that this issue may have arisen. What happens if your app is running slow? So you may go into Grafana. You would paste this promql code, promql command at the bottom, which you can see I've pasted there at the bottom of the screen. When I execute that, you can see that the duration of all my requests are pretty stable. But say, for example, there's a spike. A spike might indicate that there's particular issue with the function of your application. So if there's any particular spike that you see, you can run some of these commands. The first of which is to see if your resource has been constrained in any way. Is it throttling because of high CPU? Is memory usage high? You can also look at the limits and potentially increase the limits if either of those two issues are occurring. You can look at dependencies too. So you can add a new Prometheus metric for external calls. So in this case here, we saw that I created the path for metric, but you could potentially create another path in which, and call it /API/data, for example. And then you can use that to see if the latency is any higher or lower, to see if there's any potential dependencies that may be leading to this specific issue. And then finally, you can scale out to relieve pressure. So if you're using 2 replicas, you may decide to increase to 4. So there are some ways that we could potentially address this issue. Another common issue is where your pods keep restarting. So if we go back to Grafana, you'll see there I have my promql command at the bottom. I'm going to paste that into my command. And once I execute it, now you see here on the graph, it's at 0. That's because I've had no restarts. But if, for example, you're finding that there are a lot of restarts, you may look to describe the pod to see if there is potentially an issue around memory usage. You may decide to compare the memory limit versus the current memory usage in your deployment. And finally, you may decide to increase the memory limit. So if, for example, you are out of memory, you may decide to actually configure a higher limit. That way you won't have the same issue. Okay, and with that being said, that concludes my talk. Thank you all for coming along. And if you are interested in connecting with me on LinkedIn, that is my QR code. So thank you again. Hope you have a wonderful day.
Welcome everyone. Great to have you here. Today, we are diving into how to build real-time translated subtitles for live streaming using AWS AI services. My name is Phạm Nguyễn Hải Anh, but please call me David. I'm a cloud associate at G Asia Pacific Vietnam, an AWS partner in the Asia Pacific region. So first, we are going to talk about the process to create the real-time translated subtitles, the problems we will face, and how to solve it. Okay, so let's get started. This is a workflow to show how subtitles are created and displayed. Starting with a video source, a streaming platform like OBS Studio, which is the most common tool for YouTube streamers and is free to use. The video stream has two components: frames, the image, the animation, and audio, the streamer's voice. The audio stream is extracted and converted from speech to text using tools like AWS Transcribe or Whisper. An OpenSUG ASR, Automatic Speech Recognition AI model. That text is then translated using third-party translation APIs, or you can use AWS Translate. And the subtitles are sent back to the UI for display. That sounds simple, right? It is because I explained it in a very simple way. Yes. But when building the actual pipeline, there's always challenge. The first problem is context-aware translation. One word in the source language can have different meaning in the destination language, depending on context. Phrasal verbs and idioms are good examples. Sometimes something implied in English might not carry in the same meaning in another language. This problem also occurs with traditional NLP models, which tend to map words one by one and miss implied meanings. You can see here in this slide example from English to Vietnam, the light word sometimes mean lamp, the light source, sometimes mean not heavy, sometimes mean pale in the Vietnamese version. Yes, it's also in the example in English to Japanese, the word run, sometimes to mean run physically, sometimes mean to manage, and sometimes mean to execute. Well, the meaning of the word is diverse, and the NLP cannot understand it correctly. The solution is to use generative AI. It's smart for most of the time, right? It may translate more accuracy if it has context, and the subtitles are translated to reflect what the speaker actually means. This works extremely well for sport and sport commentary. And depending on the model that we use, it can support many languages and domains. Look at the prompt here I use for Claude Sonnet model. I want it to know the context, which is the football match. And the target language, in this case, is Chinese. And I import one example with the expected output. And I also told it there are two inputs, the text current for translation, and the last translated chunk to make it not change the subtitle much. Also, I keep the top K 1 and temperature 0 to make it keep consistent in what it prompt, in what it output. And this example prompt is for the football live. You can try in other domain, but this will be the context for the session today. And also you can change the target language and the source language. Also here I set it to Chinese, but it also can support other language like Vietnamese, like Korean, Japanese. It's depending on the language, the LM model that you choose. Okay, the second problem is about the transcription accuracy for proper names. One important thing must keep in mind is that if the transcription is wrong, then the subtitle will be wrong, no matter how good the translation is. A common issue is that speech-to-text models often fail to recognize names, such as football players, unless they are very famous, like Messi or Ronaldo. AWS Transcribe address this with a feature called custom vocabulary, which lets you import proper names with two columns, the phrase and how you want it displayed. You can see some football players' name here. As an example, I'm currently using AWS Transcribe for this. But if you have other solution, I would love to discuss them with you. Last but not least, the final issue is about the speaking speed in live streams. In live streaming, people speak in real time, and so does the speech-to-text module AI model. Unlike uploading a pre-recorded video, where you will get a very clean, complete transcription, is a much difficult in a live stream. The speaker will speak roughly one word by second. Meanwhile, the ASR module outputs transcription every 100 milliseconds. So, what happens when the speaker hasn't finished a word yet? Exactly, the model still produces output. Its best guess, and that guess is sometimes wrong. AWS Transcribe handles this with a feature called partial result stabilization. When enabled, only the last few words remain subject to change. This makes it well suited for live captioning and video subtitling. The stability level can be set to low, medium, or high. Low prioritize accuracy, while high prioritize speed. You can see here in the example the group that we highlight when the sentence is the first sentence is the Amazon has no law. The Amazon is the law, which has no meaning. This is because the AI model is still predict when the speaker has not finished the word, which make it wrong. Okay, but when we enable the feature, it will guess correctly. Yeah, you can see here they are not look like change very much from the partial resource stability enable and disable, but if you think about the translated subtitles, it's a very huge change, a lot. Like in this row, the Amazon is the law. It will change to the completely different meaning compared to the second and compared to the other lines as well. So the accuracy, the quality of the transcription is very important for the subtitle. Since a transcription segment can be long, we split it into smaller partial segments and decide which ones to be sent to the translation modules based on punctuation, commas, periods, semicolons, exclamation points, and colons. Also, if the text is long but does not detect any punctuation, we need to strip it and send to the translation module too. So in the logic of this code, I set to where it's more than 60 character and has a comma, then just give it to the translate module. Or if it had more than 76 characters, then give it to the translate module. But this is for the example, and it should have complex algorithms to find the suitable segment to be translated. And I'm happy to discuss with you about this. So now I have the origin video which captured by YouTube. And the transcription here is also made by YouTube.
Three to aim at, just too deep.
They all ran into the same position. Three of them thrown a blanket over all three instead of trying to get one pulled out.
Yeah, you can see there's some implied meaning here. And the speaker sometimes speak fast and sometimes speak slowly. So now let's look at the solution architecture, the full pipeline. I use OBS to simulate the streaming source platform. It streams to an NGS server hosted on AWS Fargate by using RTMBS, real-time messaging protocols, SQ. From there, it's split into two streams. One sends the video frames to Amazon IVS for display, cached globally via CloudFront. The other extracts the audio using FFmpeg and send it to AWS Transcribe for the transcription. The transcription is then passed to AWS Bedrock for translation. And the subtitles are delivered back through CloudFront alongside the video. This architecture has been kept as simple as possible. In hands-on, it also needs to think about how to use Lambda to display the transcription and the subtitles in the real times, in the suitable times, I mean, and how to get the session from the user. Of course, we have the user to watch at the CloudFront. And also we calculate how to scale the Fargate and how to set up everything at the backend. Okay, so now let's look at a short demo here with the full pipeline solution. Translate from English to simplified Chinese. So I hope that you understand Chinese. If not, feel free to use Internet Translator to check it. But currently, you can see that the solution is showing the Korean subtitles. Yeah, my solution, the generative AI supports many languages. So let's see.
3 to aim at, just too deep.
They all ran into the same position. 3 of them have thrown a blanket over all 3 instead of trying to get one pulled out.
Okay, so you can see here, 3 of them roll a blanket. And if that's only the input, so the AI model will cannot get the context. It say like the obvious meaning. But if has the context before the chunk after the chunk, and it can respond correctly what the speaker mean in this scenario. Okay, cool, right? There is a delay for the subtitle with the video stream, but it is acceptable, only 1 or 2 seconds. Mostly due to the time that the bedrock model need to produce the output. I choose Amazon Bedrock Anthropic Cloud Sonnet. It's not all bots because although all bots may respond correctly more, but it's slower. It's not haiku because the haiku is low, but it's fast. The haiku is fast, but it's not correct like sonnet. Yeah, but subtitles text still uprise faster than the video stream. So it works very well in practice. But in the future, I would plan to reduce the response time by using distillation techniques. By fine-tuning a small language model like Haiku from a language large model like Obus for a specific domain to get faster, lighter inference without sacrificing too much quality. Thank you for listening.
Hello everyone. I'm happy to welcome you on our today's session from misconfiguration to breaches, a red team AWS playbook, and of course we will cover how to defend. My name is Victoria. I'm a security engineer and penetration tester at TechMagic. I'm also AWS community builder, and recently I became AWS user group leader of Lviv. I've seen S3 buckets go public at 2 a.m. I am roles that could take down prod and secret hard-coded in code like it is 2010s, but it was really last year issue. Hello everyone. I'm happy to welcome you on our today's session from misconfiguration to breaches, a red team AWS playbook, and of course we will cover how to defend. My name is Victoria. I'm a security engineer and penetration tester at TechMagic. I'm also AWS community builder, and recently I became AWS user group leader of Lviv. I've seen S3 buckets go public at 2 a.m. I am roles that could take down prod and secret hard-coded in code like it is 2010s, but it was really last year issue. So to understand the problem deeply, I always start with example, and here one which you will be able to read by link to make it deeply and fully. But let's go to the attack in some steps. Like we had a threat actor who found exposed environment variable, so .env file with also secrets or credentials. They enumerated the environment, so like IAM, STS, S3s, SS, and the credentials did not have any admin permission, so it was not admin account exposure, but have access to the function like attach role policy. So they was able to create a new role and then use attach policy and attach it to the administrator access. So it was not administrator from the first time, but with this role policy it was able to assume the role and of course exfiltrate data and place a ransom node, and you can understand what went next. So let's go an overview of misconfigurations. Of course we understand that misconfigurations occur when cloud resources are not set up correctly, securely, and it can lead to potential risks. So common types of misconfigurations are overly permissive IAM roles like wildcards or allowing something extra, misconfigured S3 buckets, so like publicly accessible or something exposing sensitive information. Also public facing resources like EC2, RDS databases or Lambda functions. And security group mistakes, wide open rules like zero IP for SSH or RDP access. And of course insecure serverless architectures, mismanaged API gateways or Lambda permissions. Common pitfalls are public S3 buckets, so it was just a test data, for example, so to try to experiment with until someone closes it, finds sensitive information and something like that. Of course it's unpatched AMIs or containers, like images are built once and never updated, so you never even remember what to do with them and how to control. And now you've got 20 EC2s running a vulnerable Log4j version. Who was working that time? I think you remember those period. hard-coded secrets in CI/CD. So again, secrets was stored in some config file, on some .env file, and then anyone running truffle-hawk on your repository and found out your secrets. Insecure CI/CD configuration like CI pipelines has full access, AWS access key hard-coded, and the pipeline gets compromised. Over permissioned IAM roles, it's like when you have this administrator access just to get things working. You know, when you want to add something on or fix something and you don't want to add this rights again and again. So you just decided I will have this admin access just for a few hours to make things done. And then you forgot this, or maybe some deploy is taking more time than you were thinking, and weeks later that role spins up a crypto miner in your AWS bill. Why do misconfigurations happen? So first of all, it's human error, like manual configuration mistakes and lack of understanding of security best practices is most common mistake. Complexity of cloud services. Of course, AWS offers a big amount of services, more than 200, and to configure them, it's very challenging. And to make it secure, you need to really deeply understand how to do it. Services evolve quickly, so it also leads us to potential misconfigurations. And lack of security awareness stands near human error because developers may focus on functionality or over security as well, like, you know, business logic or something like that, not about security. And the organization may just not have this clear security policies, like we'll have in future, we'll do it maybe. Let's go to the impact of misconfiguration. So again, I like to cover everything by example. So first of all, it's massive AWS credential theft in 2024, because attackers exploit misconfigurations in public websites to extract sensitive information, and it includes AWS credentials. And there was a compromised over 2 terabytes of data. The second one, exposed environment variables leading to breach. So attackers targeted web services with exposed environment variables like .env, which we saw in our first example. And it also contains sensitive information like access credential. So it leads to unauthorized access to system and further network infiltration, which affected 100,000 domains and million endpoints. The next one is misconfigured AWS S3 buckets with sensitive information. So there was just easy stuff. AWS S3, which was publicly accessible to this misconfiguration, and it also leads to exposure of sensitive customer data, which included in this situation personal information and credentials as well. And application load balancer misconfigurations are like improper implementation of authentication, which lead to potential exposure of thousands of web applications and, of course, unauthorized access. If we are talking about AWS pentest, so I want to add some tips and tricks what you need to know. So, of course, AWS have penetration testing policies, so you need to read them before proceeding. And let's go through what you can test in AWS. So you can test your assets like EC2, S3, Lambda functions, everything we was covered in previous slides like misconfigurations. Your network configurations like security groups, VPC, load balancers, and application and data, anything you deploy within the cloud environment. And be accurate here what you cannot test. AWS managed services, so like physical infrastructure, underlying hypervisions and network managed by AWS, you cannot test it, you will be blocked. And AWS services themselves directly testing like RDS, Dynamo, and something like that. When you will read these penetration testing policies, you will know that in most situations when you want to perform pen test even for your services, you need to tell about this AWS so they knew that you're providing this pen test and also not block you. Let's go to the Red Team AWS playbook. So like moving from steps: initial access foothold, privilege escalation. I don't know, maybe after privilege escalation we already can stop describing, because everyone knows what to do next. But let's cover the discovery, later movement, persistent, and evasion. So here we can see like some examples. If we're talking initial access foothold, it's like S3 exposure, leaked credential. Then we move to the privilege escalation when we have this assume role abuse or over permissive IM. Then we go to data discovery. Again, we have S3 enumeration to find something new, secrets in lambdas or something like that. Lateral movement include pivot of ECSs and lambdas, and persistent innovation we have functions like disable login and create backdoor roles as example. Another one, again, from initial access we go to the privilege escalation. From this we can go to this data discovery like over permissive IM, weak trust policies, then to lateral movement like public buckets and unprotected secrets, then to persistent and evasion like shared IM roles, overly broad access, and the latest one like missing cloud trail, so there will not be any config monitoring. And real world exploitation scenario, abusing AWS Lambda for privilege escalation. In this scenario, we will exploit overly permissive AWS Lambda. So attack path will be first step, enumerate Lambda functions to identify vulnerable function with excessive permission. Then we will check IAM role permissions attached to this function. Then we can abuse permission to create a new function with elevated privileges, execute the payload to gain persistent or create a new IAM user, and of course escalate privileges to admin level access. Then I think we already covered possible steps. So here you can see how it can work, so which functions we already described them, but you can see it graphically on this image, so where we was able to create a new function with this administrator access, and then invoke function to create IAM user and create the admin user, which will be our backdoor now. Where to try? I added a link with Cyber Labs. I really like them, so it's very interesting and will develop your skills. But here we also will cover what mitigation steps can be. Sanitize and validate all user input in Lambda function. Use AWS IAM Analyzer to detect overly permissive roles. So regularly, maybe once a quarter, if once a month it's pretty very okay. Use enable AWS Cloud Trail, so you also need to monitor this unusual Lambda activity and prevent Lambda from creating IAM user by using service control policies. And always, I will repeat this, but always use least privileges to move forward. AWS security best practices. You need to have an incident response strategy in place. So define roles and responsibilities for security incident. Use AWS Cloud Trail and Guard Duty to detect and respond to threats. And of course, implement automated remediation with AWS Lambda or Security Hub. So you can use it as well. Then follow the principle of least privileges, so never use the wildcard in IAM policies or anyone else. We really recommend you to use whitelist, not blacklist. So when you add only needed functions, only needed stuff to this whitelist, it will be really easier to track it. Regularly audit IAM roles and remove unused permission. Use IAM access analyzer to detect some additional access. Then secure sensitive data and secrets. So please store your API secrets, credentials, tokens, everything in AWS Secrets Manager. Restrict access to all your services using IAM policy, and it's a good thing to enable S3 versioning and object lock too, so not to allow that data tampering, and harden network and compute security. So again, avoid public EC2 instances. It's always like honey pot to hackers. Limit security group rules and enable AWS WAF. But please remember that you need to customize it, because AWS WAF by default it's really can be bypassed easily. Let's tell so. Automate security audits and monitoring, so use AWS config. Also, I recommend some third-party tools like Prowler, CloudFox, and Pacu, and set up AWS Security Hub for continuous monitoring. Also, AWS Security Hub can be integrated with Prowler and some other third-party tools. Enable login and threat detection. Again, native tools like CloudTrail, GuardDuty, and VPS flow logs will help you in this state, and perform regular security review and pen testing. So schedule internal audit on your cloud security assessment, conduct penetration testing, and train your team on secure cloud architecture and AWS security best practices. So again, we was talking about some native tools like IAM Access Analyzer, Security Hub. You can set up them to be frequently as it's okay for you, so once a quarter, once a month, so, and or maybe in this amount of time you can review what was done, is it working correctly, or maybe you need some changes to it. Also, I want to add some AWS penetration testing workflows. For CI/CD scanning, we use tools like Snyk, Trivi, Checkov, or WASP. Cloud monitoring, AWS config, native tool, Security Hub, GuardDuty, Prisma Cloud. Pre-commit for Trufflehawk to find your secrets, Git secrets, and pre-commit. IAM governance is Parliament, good one. IAM Access Analyzer, AWS Identity Center. And for Secret Manager, you can use this native AWS Secrets Manager, and also, for example, HashiCorp Vault. So, conclusion and key takeaways, the importance of identifying and mitigating misconfigurations. So, misconfiguration are a leading cause of cloud security incident. Even minor misconfiguration can lead to significant data breaches. Effective tools and techniques for AWS penetration testing. So CloudFox, Prowler, Pacu, is some popular tool, third-party ones, which you can use to automate some security assessments and review, and maybe sometimes to save money, not to use the some AWS pre-built, and some additional tools like Scout Suite, Cloudsploit, and AWS native tools like Config and GuardDuty. So you must be familiar with all of them. Also, automate regular security checks and audits, implement the principle of least privileges in IAM roles, and as I mentioned, always use this whitelisting and add only what you need, then add every time something to blacklist. It can be really late. Continuous monitoring environments using AWS native tools, and develop a strong incident response plan to handle misconfigurations quickly. And some additions from me. Security is shared responsibility, so protect your configurations and data. Proactive monitoring and auditing, so it will help to prevent breaches before they happen. Automate and enforce security control, so don't rely on manual checks. You can use already something which already was created for this purpose, and plan for incident. So have a response strategy and be always ready with your next steps if something happened. And some more AWS security resources are added on the slides, like AWS security best practices, AWS security hub, and AWS incident response guide. Also some additional resources like security workshops from AWS, some security workshops from TechMagic, which we already covered, also some AWS topics. Also, I recommend to review cyber cheat sheet and lab and maybe our webinar recording, so how to secure your cloud with Prowler. Also, I recommend you to follow AWS Security Digest newsletter and to try your skills with Pound Labs. And here must be a time for questions, but as it was previously recording, I will happy to answer on everything if you will write me on LinkedIn, so I will be happy to connect or answer anything you're interested with. So you can also scan this QR code to download presentation, to get my LinkedIn profile and some other additional resources. Thank you a lot for joining me today. Bye.
All right. Okay. All right. Good morning, good evening to everyone, depending upon where you're listening me and watching me from. Today's session, the session that I'm gonna be talking to you about is around the Lambda functions, and underneath that we use Firecracker. So we're gonna unpack what it is. So the title of the session is Under the Hood of Firecracker, a deep dive into AWS Lambda. My name is Mudassir Sayed. I'm a security software engineer. Let's look at the agenda for today. So what all are we going to be covering? The full Lambda stack, and then we'll look at what KVM is, what and why Firecracker exists, and then we'll go into the internals of Firecracker, and then we'll learn a little bit about cold and warm starts, and then we will go into the security aspect of the firecrackers. And then I'll leave you with some of the key insights or key takeaways for you at the end. Jumping in. So before we dive deeper, I would like to have a common understanding or the basic understanding of AWS Lambda, what it is, so we are all on the same page. A fully managed serverless compute service, right? That's what AWS Lambda is. That's what many people tend to learn. I just want to take it a step ahead here, where we are also allowing executable code to run into as part of Lambda, and those executable code or the executable code would run from different AWS accounts on a single bare metal server, right? And we are not compromising on performance and security. So the biggest challenge that AWS Lambda solves is running that executable code for n number of different customers on a single bare metal server, and making sure the security and performance of the service is maintained and is not compromised, right? When you look at it deeply, it's a really a architecture marvel, if I may call it so. I really enjoyed learning about it. I've been using Lambda functions for like since 2015, 16, but I dive deeper into it at later stages. And when I learned about it, it was fascinating to see how it has been built to scale and how securely it runs. It's really amazing. I'm gonna dive into those things. In the next slide, we have the Lambda stack, the whole Lambda stack. Uh, what what general developers know is they have a function that they write, and they are familiar with what is the Lambda runtime that they're gonna use. Is it Java? Is it Node.js? Something Python, right? And underneath that is what this session is going to be covering. And then guest OS, which is the operating system on which the VM runs on, and the Firecracker VM. We'll go into that in details further. And then KVM, which is the kernel level virtual machine software, and then the Nitro bare metal EC2 instance. If you're familiar with Nitro, it is it gives really high performance isolation and also virtualization. So that is about Nitro in brief, but that is again we can go into that later stages. It's really interesting. All right. Firecracker boot flow. Imagine you have your executable code deployed onto a Lambda function, and you're invoking this Lambda function through maybe an API gateway or anything else, right? Or directly Lambda itself. And the way that it works is first the Lambda API is called, and it first routes through slot manager. Uh, and slot manager is kind of a controller in the sense of programming language. If you're familiar with Spring or any other frameworks, that's the controller. It acts as a controller, and you can think of it like a control plane in terms of how it coordinates the things in Kubernetes sense, right? So slot manager gets a request. It tries to find if there is any warm instance, warm virtual machine available to be served, right? Ready to be served, something which is already baked in, right? If it does not find something which is already available, it then asks the KVM the firecracker software to. We'll go into this a little later, into details of this later, but just to understand the whole flow of it. KVM firecracker hypervisor to spin up a micro VM, and once it starts this micro VM, then it starts serving the request. So all of this happens within 125 milliseconds. Imagine the speed at which this occurs, and there are around 150 hosts that can be run on a single virtual machine, and it would use somewhere around less than 5 megabits of memory as well. And we'll go into the next slide. All right, again, before we go in to the details, I also want to make clear around virtual machines. We all get the basic understanding of it. So virtual machine acts like each virtual machine. When we have virtual machines, each of them acts as a separate computer, right? Though the physical hardware is same, there is a hypervisor in between, which is managing all the resources, allocating them, and managing them. So that is what a typical virtual machine looks like for VMware, for example, the way that it works. So that's the idea around the traditional virtual machines, whereas the firecracker micro VMs are quite different. Let's go to the next slide. Before we go into firecracker, let's also cover the aspect of KVM, which is kernel level virtual machine, the virtualization, which is the foundation on which we build the virtual machines, right? So what is a KVM? It's a feature introduced as part of Linux, Linux operating system. It was introduced in 2007, and this Linux feature, like, it turns any machine into like bare metal hypervisor, in the sense that it gives us the isolation that that a traditional virtual machine would give us, and it is secure by security by OS. What it means is the host VM and the guest VM, or rather guest VM, is considered as a outsider entity, in the sense that it is considered uh, like insecure, to make sure that there is no trust by default, right? You're not blindly trusting it. You're making sure that it is going through the uh, security firewalls or gaps that we'll talk about. So that is also being added here. And then hardware proximity. So there is no big layer in between the VMs and the hardware. The KVM acts very close, to the bare metal server. So you'll not see a lot of lag. So it's kind of gives us much less latency compared to having a traditional hypervisor style virtual machines. So on the right side, you'll see a KVM hypervisor, the diagram which depicts how it looks like. So on the there is this hypervisor which is built along with the kernel itself, and which is supporting the OS or virtual machines, having allocation of resources through it, and managing memory and all of that sort of thing. All right, why was Firecracker built, right? And what was the problem that was being addressed here? So traditional VMs, you've got a really rigid way of doing things, very slow, very cumbersome. You're making sure that you have your isolation taken care and all of that good, but it's not gonna be ready within few milliseconds. Like we talked about, 125 milliseconds for serving a server request, right? And at the scale at which Lambda works, it is going to be really hard with traditional VMs to serve such systems. Whereas if you look at the containers, containers are pretty flexible, lightweight, but they are sharing the same kernel. What that means is there is a high chance that if one of the containers is compromised, it could get to the level of kernel and compromise the kernel itself and the whole server and all the containers that are running on them could be vulnerable to any kind of attacks, right? So that's where there is a balance of lightweightness and also the isolation that a traditional VM gives us. That's where Firecracker comes in, and it gives us, you know, best of both the worlds, right? That is the idea of Firecracker. We will go into the internals of it as well. Okay, so looking at the internal aspects of it, we did refer to some of these in our previous slides, but it is something which is written in Rust programming language, and why Rust, right? I mean, if you think about it, Rust is memory safe, thread safe. You will not end up having memory related issues that we see with a lot of the other systems which are built, the older generation ones. So that is kind of taken out of the scope here with building something from using Rust, right? And it uses bare minimal devices, in the sense the networking devices, the file system, and the memory, CPU, everything is so tightly bound, in the sense that only what is needed is being allocated, right? And there is no BIOS, which is generally referring to the input and output emulator that comes with, and it takes its own time to get your OS running and get that interaction going with the kernel and all of that sort of thing. The other thing is you can control your VMs, you can manage your VMs through REST APIs, because there is a REST API that Firecracker exposes, so you can start and stop and do all of that sort of thing with virtual CPU that you want to allocate and storage and stuff. You can play around with that, and each micro VM is managed by their own Firecracker process. So every micro VM is running as a dedicated Firecracker process, right? It's not running as a separate computer that we talked about in our introduction to virtual machines, the other slide that we looked at. Okay, so we'll go to the next slide. Some of this information is covered earlier, so I'll dive in. Cold start versus warm start. This is a very important aspect of having Lambda functions served and made available for the users. For example, so Lambda functions are based on the runtime and the memory and then the CPU and all of the allocation. So if there is a request that coming in, if there is a micro VM already available which can be served, then that is served or considered as a warm start. You're not spinning up something from scratch and allocating the resources and then serving it. It's just that you have something in the pool. It might be in an idle state, and you you just allocate the resources back and serve it in the warm start, whereas in cold start you are starting from the scratch or spinning up the micro VM, and then Firecracker boots a new VM, and again with a minimal level of kernel level access and runtime, libraries and things like that being loaded, and Lambda package that is attached as file system, and all the runtime things that are handled. So within 100 to 500 millisecond total latency for a cold start, right? You're bringing something up uh, from from zero, or right from scratch. And if it is already available in the pool of VMs, then you just serve that. That gets your request served within 10 milliseconds. So it's somewhere between 10 milliseconds to 500 milliseconds that a Lambda function gets up and running, or it's available to serve your request. Okay, so multi-layer security, this is a, a key aspect of Firecracker. The reason for that is we wanted, or there is a need for defense in depth. Imagine you're running an executable code from a uh, different third party who's deploying in your infrastructure, and that could very well be compromised. So it could lead to a lot of issues underneath uh, underneath the surface. There is one single probably one single bare metal server that is used for multiple customers, and one bad executable code deployed by a bad actor could compromise the whole system, right from your server to all the other micro VMs altogether, right? So hardware isolation is the key aspect of it. You virtually isolate the guest kernel from the host kernel, right? You're not blindly trusting the guest kernel, and you consider that as a third party system, or like a supply chain issue. Thinking about considering that, keeping in mind of supply chain attacks, you don't trust the guest kernel as is. You add additional layers of security, and then you have minimal device model, which again is restricting to what you need from a networking perspective, from a file system access perspective, and the console access and timer and everything. So you are limiting to 4 to 5 devices or tools that are needed for your container to run. That's pretty much it. And any additional accesses would lead to unnecessary attack surface being made available, right? So that's the concept of that. And then third, layer 3 of this is each firecracker process is what we call like considered jailed, in a sense, permissioning wise. We talked about number of devices. Now what we are talking about is the level of access that we are giving. It is chroot. Based on chroot, you manage the file system access, right? What permissions are, you only give read permissions only to a specific set of files and things like that. And then the BPF filters for networking, and how things are routed, and C groups again, and namespaces for managing your file system, right? So that's the idea behind that. You limit what gets accessed by the virtual machine. And then the last one is the network and encryption. So imagine there are two servers, right? Each of them would be running in a different network by itself. You have that isolation in place. And also, think about it like one system is compromised and you have free, that is able to talk to a different server freely, right? And that means that it could compromise the other systems across the organization. So what you do is you do that isolation in between and make sure that those servers are not in the same co-located space, virtual space, right? Not having them in one single VPC. So you separate them out, you have that isolation in place, and then make sure the communication that happens is through encrypted communication with AES and things like those. All right, I'll jump into the next aspect of it. So the performance and the density at scale, this is the key highlight of what the Firecracker serves. It serves like trillions of function executions monthly, trillions, like imagine, it's like so many zeros in there, right? And then micro VM on single host. There are like thousands of micro VMs running on single host. Uh, think of it like a huge uh, LED light system that you have. There are like a lot of LEDs in it, right? And you have one of them independent from the other. It's not like one goes off and then the whole system goes up. So thousands of micro VMs kind of flashing on this one single bare metal server, and each micro VM the lifetime of it is like 14 hours. Beyond that, it's taken off of the system, and then a fresh one is introduced or spun up. And again, referring to some of the provisioning aspects of things, like we only the Lambda function or Firecracker only allocates the resources when necessary and how much those are needed. Once the Lambda function is going into an inactive state, then those resources are used by different VM which needs it. So you're not sticking to one configuration and just having it right, all along. You are separating them out and only taking what is needed and when it is needed. All right. And Lambda, Amazon Linux 2 images. This is Lambda execution environment run on Linux 2 with all the packages that are necessary. And then Nitro system is like we initially talked about it. It is a high performance virtualization and isolation server, which is on top of which the Lambda functions are running, or the micro VMs are running. All right. And then finally, the key takeaways from today's session are KVM is the foundation. KVM is the foundation for the whole of the Firecracker architecture that is built on top of it. It's a Linux. It's a Linux's KVM, which is it comes with Linux 2008 or 2007 version, and that helps us use micro VM, micro virtual machine monitor, Firecracker, which is a micro virtual machine, monitor, and that will help us build these virtual VMs or micro VMs on top of that, which running in isolation and serve the request in speed at speed and defense in depth. And like we talked about, there are like multiple layers of defense. If one goes through, there is a bad code that is being running that compromises the guest OS. If that is compromised, then we make sure that there is permissioning around using chroot and all of the other aspect of namespaces and things which limit what goes to the kernel and then to the bare metal. So there are those multiple levels of defense in depth in place. And warm pool and cold pool, or not cold pool, but it's warm pool rather, which gives us the low latency. And if it is a cold start, that is going to serve your micro VMs from get them from scratch and serve them. Whereas micro pool, warm pool will allow for us to use the same VM for a particular period of time. If it is not used, it is served within 10 milliseconds. And then the way that Firecracker is built is using the Rust programming language to make sure there is no memory related security bugs or issues that we tend to notice with anything that is built in C, C++. And open source impact is this is open source. Firecracker is open source. Anybody can go in, modify it, kind of customize it to the need of what you're building and using it in your organization. So that is pretty much from me. And this was the last slide, and I really enjoyed talking to you all. And you can feel free to find me on LinkedIn. My name is Mudassir Sayed. Signing off. This was an amazing experience talking to you all. Thank you so much.
Okay. So, hi everyone. Good afternoon. It's been great to hear to present about this topic, AWS IAM MCP Server 101 getting started. So, it has been a good day to starting from the morning, learning from the various speakers, and now we are moving towards the another session. And let's get started. So before starting, I'll briefly introduce myself. I'm Sankal Sandeep Paranjpe. I'm based out of Pune, India. I work as a cloud security engineer. I'm an AWS community builder. I also lead volunteer activities at AWS User Group Pune, and I'm also former Cloud Club captain. So that's a bit about me. Let's see what we are going to explore today. So, what MCP is and how it helps. MCP components, AWS MCP servers, then AWS IAM MCP server, and a few demo use cases about AWS IAM MCP servers. So yeah, let's get started. So before we start, how many of you have been debugging a pipeline for 20-30 minutes and then realized that it was a IAM issue where the role was not able to access certain service, right? So using these MCP servers, few debugging, few auditing can be made more easy, and it will help in overall deployment workflows as well. So before we dive in, the problem at scale, which is there are hundreds of users, roles, policies, and it become hard to manage them. Also, writing least privilege policies is error prone as we are configuring so many user roles and policies. And again, policy simulation that also requires write CLI commands. Without that, it is very difficult. So MCP server, IAM MCP server solves these problems, which we are going to see in this further presentation. Uh, what is MCP? MCP basically is an open source standard for connecting AI applications to external systems. These external systems can be anything like basically your local files or databases or tools like calendar. Yeah, yeah. Uh, I am showing. Is it not visible? Yeah, it is in the present mode. So none of these slides are visible. Yeah, what is MCP slide? So previous slides were not visible. Oh, okay. Yes. Yeah, yeah. So uh, yeah. So, continuing with the technical topic where I left. So, using MCP, AI applications can connect to various data sources like your local files or databases or your Google Calendar or a search engine and your own workflows. So, whatever basically I explained it in previous slide. This is the diagram where on the left side you can see AI applications. Those can be any of your web clients or desktop assistants or your code editors, CLI tools, or any of the agents which you have written. We use MCP protocol to connect these AI applications to the data sources. Basically, those are object storage. Hmm? Yeah, I am on the diagram about the MCP standardized protocol. Okay. 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 So basically, we have AI applications. Those are web clients or desktop assistants or your code editor, CLI tools, and any of the agents or workflows which you have created. And now we use MCP protocol to connect the data sources. It can be these databases or files or any maps or locations, anything. So that's the basic how and what MCP is. What MCP enables us, how it helps us. So first is the context aware help. So it has access to our all personal data, personal tools to provide relevant outputs to you. Next point is that software wide automation. So it executes various tasks across various tools seamlessly. Apart from that, it helps with it to connect and analyze the information from multiple databases or multiple places. So you have all your custom data at a single connect point, and again direct hardware interaction as well. So now the components of MCP. This diagram is officially from the MCP documentation, where we have this MCP host, the AI application, and we are initiating multiple MCP clients which are connecting to different MCP servers. So let's say I have MCP server A that is locally deployed, and MCP server B is also locally deployed, but MCP server C is remotely deployed. Now, there are two layers while we explain the MCP servers, the transport layer. So how does transport layer communicate is basically through two transport methods. First is the standard input output method. Basically, when you deploy MCP server locally, you can use STDIO basically for communication between the client and server. But when your MCP server is deployed on the remote host, you use server events, streamable HTTPS to make connection between the client and server. The other layer, which is basically the data layer, it has three components: tools, prompts, and resources. Tools basically include the executable functions that AI application can invoke. So that can be your file operations or any of the API calls or the database queries. Those can be the tools. Prompts can be something templates or a structure basically which you use to interact with the language models. Let's say you create a system prompt or any of the prompting techniques. Third is the resources. So data sources that can provide the contextual information. So as I talked about, databases or calendar or any API responses. So in AWS ecosystem, there are 66 plus MCP servers available various in various categories of infrastructure, data, machine learning, and more. So this is the official AWS Labs GitHub MCP website, where you can see there are multiple MCP servers: essential category, core category, documentation, infrastructure and deployment, AI, machine learning. Various MCP servers are available which you can install and use them. To get started, you have different documentation available, samples available which you can implement in your workflows, and these servers, all the installation guides, how to use them have been mentioned here on this specific website. Now, talking about IAM MCP server, it has multiple features, core IAM management features like user management, role management, group management, where you are creating these user, role, group, you are writing IAM policies, you are writing inline policies, you have full CRUD operations for user and role inline policies. Then access key management, you can simulate your IAM policies. Yeah, so how can we install them? You can install them using these UV, or you can install it using pip as well. Then you require some IAM permissions, and if you're using Kiro, you can add the configuration in this mcp.json file. Or you are using a client for Cloud, so you can add this configuration, and you can directly install it in Windows as well. So this is the basic installation. It also provides you with the read only mode, where if you basically, it prevents all the mutating operations. So if there will be no accidental modification in your production environment, it will be only in the read only mode. As well as you can test your policies. So it allows a safe exploration of IAM resources and auditing as well. So which specific resources should have the read access. So how can we enable the read access? We need to pass an argument of -f and read only while we are starting the server. So -f and read only we need to add while we are starting our server. Okay. And in read only mode, create user, delete, basically these are blocked, while list, get user, list role, list policies are available. And multiple tools are available for user management, role management, group management, which we are going to see a demo in a few seconds. Moving to next part. Here we will see how are we going to install this MCP server basically in our Kiro. So first I am going to create my configuration file. So I have added my configuration where I am using an IAM-MCP server, and I'm passing this as an argument and some environment variables as well. I have my AWS credentials. Those have been set via AWS CLI. So let's see how can we configure this MCP server. So it is currently in the read-only mode. Read-only is true for now, and I've just tried to see what is there in that specific file. Now, when I added that, basically, so you can see the Kiro MCP logs. It has added new MCP server. It has registered it, and server is started in the read-only mode. And now it is processing the request of type this, and list tool request is there. So it is installed successfully, and I will be able to use this MCP server. So coming to the some demo use cases. So first use case where we need to audit our IAM users in our account for access key hygiene. So I want to know that which user have their access keys older than 30 days, or the key ID, the information about the key, the creation date, its status, if it is active or inactive, when was it is last used. Then I need to flag those keys basically which have never been used, or basically we need to sort the keys by age. So oldest key would appear first. So for this specific demo purpose, I had set up few AWS IAM users, roles, and policies. Okay, so mm, when I'm be sharing, when I will be entering this prompt to my Kiro, where I am giving a prompt to audit all IAM users. It used a tool called list users to list all the users in my account, and there are 4 users, so it is trying to list all those users, and it says that as of 11th April, 30 days threshold, before it would be 12th March. So keys that are older are 30 days and none. And there are few of these two keys which have been created one day ago, but those keys have never been used. So it used the MCP tool to get this information directly from AWS. And it also says that two things about noting that this specific user has administrator access, and there are no access keys for these specific users. So it has used the MCP tool for list users and found this specific information. Now, moving to the next use case, where we have to find all IAM roles in the account that have administrator access attached. And for each one, we basically have to show the role name, then when the role was created, and when it was last used. So, and also we need to flag any role that have been used in the past last 90 days. So most majorly around the auditing part of the IAM roles. So let's see how this MCP server is utilized here in this case. Okay, so I have provided the prompt to this hero. Now it is going to use a tool for list roles where it will get all the roles. Then it says that it has 46 roles in my account. Then it is calling for multiple the simulate principal policy tools, and it gets the result. So there are 46 roles, and these roles have administrator access with them. They are never used when they have created, and there are other custom roles as well. So it basically gives us which of them has this administrator access and inline policy with wildcard policy for all actions. Functionally, that is identical to administrator access only. So it has used those tools, MCP tools. Next, let us move to the third use case where I have a CI/CD deployment role called demo IAM MCP deploy role. It is supposed to deploy to ECS and pull image from ECR. So I'll ask, can you simulate whether this role can perform these actions? So we want to simulate and check if these actions can be performed by that role. And basically, we are asking them to use the role ARN and tell exactly which one will fail and which one will succeed. So let's see how the MCP tool is utilized here. So I have provided the prompt basically, and the MCP tool has run simulate principal policy tool where it says 3 out of 4 pass, and the breakdown is given, and it says ECR get authorization token will fail. Basically, the fix is that we need to implement that as an inline policy that has not been implemented yet. So we will have to fix them, and it says want me to patch the inline policy. I have entered it, yes, but it will not be able to patch that. It will not be able to create that inline policy. Why? Because we have started the MCP server in read-only mode only. So it is going to basically fail, and it will not be able to create the MCP, create the IAM policy basically. Now let's move to our use case 4, where we will ask Hero to basically look at the inline policy on this specific role, demo IAM MCP Lambda role. And we'll ask what permissions does it actually have, and is there a problem? So let's see what happens here. So we have given a prompt. And it used get role policy. It had failed, but it got the policy document in the output. So it has action star and the resource star, and that is a serious problem. It highlights that because it is functionally identical to administrator access, and as a best practice, we shouldn't have this IAM inline policy like this. So it will ask like if we need to fix that, and then I had mentioned about it, yes. So it says, what does this Lambda actually do? So I'll provide the context. It reads from S3 bucket. So it is going to draft a IAM policy for this Lambda function. So let's wait and see. Okay, so we require these many actions, and it defines a policy for us, and it also provides us with the command because since it is in the read-only mode, it says I cannot directly apply. So we will just basically copy the CLI command and we can apply that. Or again, we can remove the read-only true argument and restart the MCP server. And this MCP tool would be able to apply on behalf of us. Next, we'll move to the use case 5, where we need to find all IAM roles that allow external AWS account to assume them via their trust policy. So for each one, we want that role name should come, which external account IDs are trusted, those should be there, and whether principal star is used anywhere. So basically that is a critical risk, and we need to flag the roles, the trust policy is broader than it should be. Okay. Um, so let's see what happens. Okay. So we have provided the prompt. It says I have 46 roles from the list role, and from that these roles have trusted principal, these two, but those are root. And basically it suggested that this IAM role, a cross account role, needs fixing the external account statement. Excuse me. So this needs external account statement, and if we provide them the right access, it is going to fix that as well. So yeah, coming towards the end of the session, if there are, so basically this is the QR code everyone can scan, and it will redirect to the official AWS Labs GitHub MCP documentation, where you are going to find all the MCP servers with IAM MCP server documentation, how you can install them, and then you can use those MCP servers in your workflows. So yeah, we are towards the end of the session. Thank you, team. Thank you, everyone. We can connect on LinkedIn, and if there are any questions in the chat, we can take them up. Okay, thank you.
Oh, yep. Okay, hello. Ready? Oh, I didn't listen. Okay. Good morning, everyone. Thank you for joining my session. Today, I'm very excited to share a topic that is becoming increasingly critical in our core journey, going the keyless, eliminating credential management in AWS compute resources. This session about how we eliminated AWS credential management during the IAM role and the instance metadata service. Before we dive into the technical detail, let me briefly introduce myself. My name is Cynthia, an infrastructure engineer in Zero One Group based here in Indonesia. I have been working in industry for about 2 years now, focusing the cloud infrastructure and DevOps and observability. I spend a lot of my time to build the scalable systems, and also you can see this talk, finding the way to make them more secure and efficient. If you would like to connect with me, see my technical blog, or check out my other project, you can find all my professional link in the link tree displayed on site. Displayed on this slide. I love to keep the conversation going after this session. Before we get into the technical detail, I want to tell the story because it's isn't about the shiny AWS feature. It's about the journey from not knowing to resisting change to finally shipping into production, and some of you might be find it familiar. So here's how it started. A client come for us with what sounds like the simple request. Can we eliminate hard credential from our infrastructure? My first reaction, pushback. I said, we cannot do that. If you want to access AWS, you need to access key and secret access key. That's how just it works. I was pretty confident at the time. The other, the other client come back with the same request. I still said no. Eventually, whatever out to curiosity and embarrassment from getting pushed back repeatedly. I sat down and actually read the AWS documentation properly, and that's when I realized the approach I'd been using wasn't just suboptimal. I was fundamentally wrong. It was fundamentally wrong. AWS had already built in the better solution. I just never looked for it. I want to clarify something before we go further. Before I get into the specific situation, let me acknowledge the general risks that come with hardcode credential, because they are real. Credential commit to Git history can persist forever even after deletion. They can leak through CI/CD logs, Docker image, or config file that get accidentally exposed. There's no automatic progression, so the compromise key stays valid indefinitely. And because one set of keys is often used for everything, the blast radius of leak is massive. Now, in our specific case, we weren't doing any to this. No credential in Git, no ENV file push anywhere. By basic standard, we were careful enough. But that doesn't mean we were safe. The real problem was more subtle. The credential we used came from the IAM role with the overlay board permission. Early on, to avoid constant error, we gave it wide access. Over time, no one there, no one that triggered it because they were afraid something would break. That same IAM user, that same EM user was shared across multiple places, EC2 instance, CI/CD pipelines, local development environment, no separated, no granularity, and most critically, no expiry. This credential could remain active for years without anyone noticing. If something got compromised, the misconfigured instance can overlay for both logs. An attacker will have long-lived, broadly scoped credential they could use from anywhere. So the problem wasn't a leak, it was the fault design from the start. because at the time we simply didn't know this was the better way. We only knew one method. Generate access key, put them in code, move on. Next. Oh, sorry. All right. Let's get into the solution. Is the color the IAM role? The concept is straightforward. An IAM role is the AWS identity that can be assumed by another entity. In our case, that entity is the EC2 instance. Where the EC2 instance launch, we attach an IAM instance profile that contains an IAM role. AWS then automatically inject temporary credential into the instance. Oh, sorry. Oh, wrong slide. Sorry. This is the sorry. Okay, this is the right side. I will continue. When the EC2 instance launch, we attach the IAM instance profile that contains the IAM role. AWS then automatically inject temporary credential into instance through something called Instance Metadata Service, or EMDS. The address is 169.254.169.254. This is the link local address, which means it's only accessible from inside the instance itself, not from internet, not from other machine. These credentials are temporary. They expire after a few hours, but before they expire, AWS automatically rotate them. We don't have to do anything. And here's the key part. AWS SDK, Bota3, Good SDK, and Node.js SDK, all of them already know how to retrieve this credential automatically. We don't write a single line to code to handle this. No credentials stored anywhere, nothing to rotate manually, and nothing to update when things change. AWS made all of it. Let's look at the Terraform implementation. I hope you can see this slide. You can zoom it. There are 4 resources to create. First is the AWS IAM role. This defines the role itself along with the trust policy. The trust policy determines who is allowed to assume this role. We set it ec2.amazonaws.com, meaning only the EC2 service can assume it. Second is AWS IAM role policy. This defines what action the role is actually allowed to perform. The principles here is least privilege. Don't grant more access than needed. In the example, we allow S3 get object and secret manager get secret value if your application needed access to other service. Add them explicitly here. Third is AWS instance profile. This is a part that often confuses people. Why is here a separated resource instead of attaching the role directly to EC2? That's just how AWS designed it. The instance profile is the wrapper that requires to link an IAM role to the EC2 instance. What you attach the instance is the profile, not the role directly. And finally, in the AWS instance resource refers the instance profile in the IAM instance profile parameter. That's it. Once the instance launches, credentials are automatically available inside it. Sorry. These slides answer the specific questions from our session description. How does the code actually retrieve temporary credential from the attached IAM role? The answer is the SDK doesn't it for you, but let's understand exactly how. AWS SDKs follow what the color credential provisions. When you could make any AWS API call, the SDKs brought through a list of sources in order, looking for valid credential. Step 1. It checks if you pass explicit credentials in the code, like the access key and secret access code directly. It found it used those. This is what we're moving away from. Step 2. It checks environment variables. AWS access key ID and AWS secret access key useful for some CI/CD setups, but still perform the credential management we want to avoid. Step 3. It checks the credential file on disk and home/.aws/credential. This is what most developers use locally. And step 4, and this is the one we care about EC2, it's called EMDS. Here's exactly what happened under the hood. First, SDK send the put request to 169.254.169.254 to get the short-lived session token. This is the EMDS version 2 mechanism. Then this use that token to make a GET request to the EMDS endpoint for the IAM role credentials. AWS respond with the JSON object containing the access key ID, secret num access key, and session token, and also expiration timestamp. The SDKs take choose value and use them to sync every subsequent AWS API call. And before choose credential expire, the SDK automatically fetches a fresh set. You never touch this process. So, what do you actually change of your code? You remove the explicit credential. That's it. Once they gone, the SDK falls through the chains and lands on step 4. EMDS automatically. The code goes from passing 3 parameters to passing 0. The behavior is identical. The security posture is completely different. Oh, sorry. Since our deployment case run Docker Swarm on EC2, there is two things to be aware of. The first is hop limit. And this where our deployment had an interesting discovery. When container tried to reach EMDS, the request got thrown to network hoops, from container thrown to the host, then to EMDS. EMDS version 2 has the hoop limit that controls how many hoops are allowed. Most AMIs default to hoop limits value 1, which means container requests get silently dropped and you get no credential provider error inside the container if on Tron the IAM role is correctly attached. In our case, we use Ubuntu 22.4 with overlay network and everything worked without us explicit setting the hoop limit. We didn't understand why at first. After investigating, we found that Ubuntu 22 and Lattice ship with hoop limit 2 by default. AWS and Canonical allied on this because container just cases are so common, so it's just worked. But here's the important lesson. Don't rely on that. If you switch to Amazon Linux 2, Amazon Linux 23, Ubuntu 24, 20.4, Debian, and each other, choose all default of hoop limit is 1 and container will be filed. The right approach is to define the explicitly in your Terraform metadata option block so the behavior is consistent and document regardless of which AMI you use. Sorry. Explicit is always better than implicit. The second consideration is sharing role in Swarm. All containers on one EC2 node sharing the IAM role attached to the node. Unlike ECS, which has per task roles, Swarms doesn't have a granularity. If you have the services that need different permission levels, run them on separated node pools with separated IAM roles. This slide for those who want to understand what actually happened under the hood. EMDS stands the Instance Metadata Service. This is the internal HTTP endpoint available on very easy to instance at link local IPs. Because it's the link local address is only reachable from within in the instance, there's no way to access it from outside. There are two versions. EMDS version 1 or legacy version is the simple GET request with no authentication. The problem is vulnerable to SSRF attacks. If your application has the SSRF vulnerability, an attacker can use to fetch credentials from EMDS without you knowing. EMDS version 2 fixed this by adding the session token requirement. Before accessing any metadata, you need to request token using HTTP port. The token is time limit. Since most SSRF vulnerabilities only support GET requests, EMDS version 2 effectively blocks an attack vector. AWS strongly recommend EMDS version 2. You can even enforce it at the instance level so that EMDS version 1 is completely disabled. The curl commands on this slide are useful for debugging. If you want to verify that the IAM role is correctly attached and credentials are available, you can run this directly from inside the instance or container. The response will be the JSON object with access key ID, secret access key token, and expiration. That's exactly what the SDK retrieves and uses automatically in the background. Oh, sorry. Wow, sorry. There are the actual issues we hit during deployment. I'm sharing them so you don't have to discover them in hard way. The first is no credential provider. This is the more common error and usually has one causes. The IAM instance profile was not attached to the instance. To verify, go to IAM console, open EC2 and select the instance and check the security tab. You will see the IAM role field. If this empty, that's a problem. Fix them Terraform and reload the instance. One note, some SDK change the no credential fault states the startup. So even after attaching the profile, restart the applications. The second is the container timeout to EM container timing out when trying to each EMDS. This is almost always the hop limit issue we discuss. To confirm, accept into the container and try curl link local IP directly. If timeout, adjust the Terraform code, no restart required. The third is access denied even though the IAM role is attached. This means the roles exist and disconnected, but the policy doesn't include the requirement actions. Use the IAM's policy simulator in the AWS console, enter the role and service and the specific action you want to test, and it will tell you whether it's allowed or denied. Much faster than trial and error. The fourth is credential expiring in the middle of long-running tasks. This happens when raw credential, the access key ID, secret access key, and token are changed and reused later. EMDS tokens have the expiry, typically a few hours. The fix, never change raw credential. Always use bottle 3 session object for your use bottle 3 for for Python or equivalent in your SDK. The SDK handle auto request before expiration. And this is the proof it works. And here's how you know it's actually working. This is from our own deployment. When we generate the present URL from inside the container, the credential in the URL started with ASEA, not ATAA. The prefix matter. ATEA is the prefix to permanent IAM resolved credential, the old way. ASEA is the prefix for temporary credential issued by STS via IAM role, the new way. Just by looking up prefix, you can immediately confirm which type of credential your application actually. Just by looking at the prefix, you can immediately confirm which type of credential your application is using. The second signal is the ANZ security token field. This token is only present when credentials come from STS. If you're using hardcode IAM user credential, this file doesn't exist. This present here confirms the full chain is working. EC2 assume the IAM role STS issued temporary credential and the application used them to sign the request. And the present URL itself signed with choose temporary credentials, valid for 900 seconds with the valid signature. End to end, the whole setup is working exactly as intended. Okay. Oh, this first. Before we close, 5 things I want to leave you with. And this is also takeaways from my season. One is stop using hardcode credential. Not because you're doing something malicious, but something you know there is a better way. Two, IAM role are a correct approach to authenticating AWS workloads. Temporary credential, temporary rotation, full audit train, nothing stored anywhere. 3. The code changes are minimal. If you're still using hardcode credential today, the migration is literally removing a few lines. The SDK doesn't rise. 4. If you're running Docker Swarm, remember one thing. Set the hope limit to 2. Single command, resolve all container EMDS access. And 5. Define the permission to workload from the beginning. Don't create one IAM user or role for everything. One role, one workload, specific permissions. And maybe the most important takeaway to all, when the client for colleges push back on how you work, listen before dismissing. Sometimes they know something, sometimes they know something you don't. I want to close this one line that always come back from this whole experience. If client had a pushback, it's still be storing secrets in a plain text. So go credentialless. The implementation isn't hard. The code changes are minimal and the benefits are intermediate. Thank you for the time. I'm over the question implementing details, adjectives to swarm, or anything else to like to discuss. See you soon.
Sweet. Hello and welcome everyone. My name is Paul Dunlop and I am one of the organisers for today's event. It's been a pleasure working with everyone today to get such amazing content to you all, and also having the privilege of closing out today with a fireside chat. I'm joined today by Aaron Senf, who is a field CTO at AWS, who has a unique background that spans integration, distributed, embedded, and complex adaptive systems, and is also the creator of the Architecting Autonomy series, which is the topic of our chat today. And you can find Aaron articles on Substack, and I fully recommend you all have a read of them, though in all honesty, I'm still catching up. One of Aaron's current focus is on agentic systems and how decision-making is distributed, how execution is bounded, and how we can preserve stability as systems scale beyond human cadence. So welcome, Aaron. It's great to have you here for the conference, and thank you for taking the time to have a chat.
Thank you. That is a long intro.
Yep. We'll get fired up with a bit of a quick round session just to get to know you, the person, a little bit. So I got some 5 questions for you to get us warmed up. What is your first programming language you've ever programmed in, sir?
So I had a follow-up question to that one. Do you mean what did I first learn, or what did I first commercially use?
Oh, what did you first learn?
First learned COBOL.
Hey, turtle logic for me. It's a long old day.
Yep.
All right, technical problems. I shall just refresh that window.
Can you hear me now?
Excuse the cough. Wow, we've been going for 6 hours and 34 minutes on this stream. That's pretty good going. Mike's been doing a good job in the background.
Yeah, I'm using my MacBook microphone. Can you hear me? Hello, I can see it's working fine on my end. Okay.
Excellent.
So should I answer the first question again?
Yep, go for it.
This time I'll tell you both. So the first language that I learned at uni was COBOL. The first language that I commercially used was Perl.
Perl. Oh, that's a good one. Some history behind that one. Which one was your favorite out of the two?
Perl, but definitely Perl. It was for control systems for vending machines.
Yeah. I learned COBOL when I was in Polytech, and I only remember it for being a language that was terrible for generating hundreds of errors on one indentation being wrong.
Yeah, yes.
Yeah.
Well, actually, if you want to say first language learned, then it was probably BASIC, but that was before I went to school. So that was when I had my Commodore 64, learning to program a game using BASIC on my Commodore 64, which took 2 weeks it took maybe a week to write the entire game and 2 weeks to debug one small syntax error.
Yeah. Mine was on an Apple IIe.
Yeah.
What's your preferred coding music?
My preferred coding music would be it depends. So it depends on what I'm doing and what kind of focus I need. So if it's just easy coding, so I'm doing integration stuff, then it'd be like deep house or maybe like almost like musical techno. No voice. I don't want to hear voices because then I start to sing along with the lyrics and it distracts me. But if I do need to get into more deeper flow, I actually listen to Baroque music.
Hey, so does that mean that you're also an Enigma fan?
I am an Enigma fan, yes.
There you go. I've been recently reinvigorating my Enigma fandom.
Nice.
What do you see as the biggest tech trend that's overhyped right now?
Overhyped tech trend right now would be agentic AI as a product category. And everyone's probably thinking, what? I thought agentic AI was like what we're here to talk about. But actually, it's not so much that agentic AI is the hype. It's that it's as a product, everyone's shipping agents that are really just orchestration graphs with an LLM in the middle. So that's not really agency at all. That's just automation with a language interface. So the overhype on people shipping agents as a product is the overhype. But agentic is not a hype. Agentic is real. But real autonomy requires authority architecture, and that's everything that I've been writing about.
Yeah, Very cool. I'd probably say I would have just said AI in general. So that's puts me squarely in the broad stereotype category.
Well, if you want to think of another overhyped trend in terms of AI, then I would say the hype around AGI. We are far from AGI, but we have many people in AI businesses saying, "Oh, we're close, we're close, we're close." That's a conflict of interest. Of course, the AI people are saying we're close because they want to sell more. So they're saying we're close. The actual scientists, the actual in the education facilities doing the research are saying, no, we're far from AGI. And also because I think we haven't actually been able to have an agreed definition of what intelligence is. So you can keep pushing we're close to AGI boundary, and when you get to what you previously called intelligence, you can push that boundary further out again. So until we can actually define intelligence, it'll always be a boundary that we're pushing towards.
Yep, well, I certainly don't feel I'm intelligent some days, that's for sure. What is your most...
Therefore you are.
Most underrated developer tool?
Yeah, most underrated developer tool. All right, I'm going to give you two, because one is a product and one is not a product. The product one, I would think, is Kiro, because it came to market after a lot of other IDEs that do agentic development. So like the Cursors, everyone's using Claude Code. Q Developer was even something that we at AWS put out there. I call it most underrated because it doesn't have a lot of market share, but actually a lot of people don't realize that at Amazon, we invented spec-driven development. After vibe coding came spec-driven development, and we built a process around that, and that's what Kiro is. It's that process for spec-driven development, and unfortunately, a lot of people don't know about it, and so it's very underrated. It's a great tool for doing your modular, I call it micro waterfall cycles again, like taking your agile task and turning it into a waterfall cycle for developing a task, but going through your requirements. So from requirements to design to actual tasks, that's an amazingly powerful tool that other, like Claude Code now does the same sort of thing in the background. It's building out a spec to then go and have its own agents and sub-agents go and build code out. So I think underrated tool. The other one that I would suggest, this is more coming from a systems engineer point of view. So when I've worked across distributed and embedded systems, a big part of our process is ADRs. So that's, what does ADR stand for? Probably a good architecture decision records. So an architecture decision record is not an entire design, but when you need to make a single decision within what you're building, the actual argumentation and justification of what that design principle is and all the options and all the pros and cons and what went into getting to that decision. The ADRs are the closest thing that we have to institutional memory for structured decisions, and nobody tends to maintain them. So like, I think in the world of programming at the moment, everyone's vibing, everyone's getting out there going, oh, we need to build this, and they're just trusting the AI, and that there's nothing to fall back on. We have, everyone's starting to suffer as we move on and say, well, why was this decision made? We can't go back and say, well, AI told us to do it that way. What constraints did it meet? What boundaries did it push? What decisions went into getting here? We need that documentation. And if we're not documenting that, then we have nothing, as I said, to fall back on. And again, that's where spec-driven development helps, because all of your requirements, all of your design, all of your tasks that go to building that, whether you're using Kiro now or you're using other forms of IDEs or agentic development, the decision records are in the vibe or are in the spec, as opposed to just vibing stuff out and letting the AI do the development.
Yeah, it's almost an underrated or a feature that's not really rated yet to have been coded into these systems moving forward, which is capturing them post build as well, right? Because we go through and do one iteration on spec, and then we might vibe troubleshoot and make more decisions as we go, and they're not well captured back into the spec as well.
Yep.
So it could be that, that's a good feature to add in.
So that is something that I was taught in the very beginning of my career. So that's something that has been historically a piece of documentation that we build before we start coding. From a systems development point of view. So having that kind of structure in a, like an accelerated world of vibe coding will make things so much stronger.
Aye. Right, my last one is, what's one book every architect should have on their shelf, tech related or otherwise?
I'm going to give you two, I'll just give you two, but only because they are the same thing from different perspectives. So the first would be Thinking in Systems by Donella Meadows. So it's not a tech book. So this one's not a tech book at all, but because it's the closest account of how feedback loops, like stocks and flows, produce emergent behavior that nobody designed. So understanding like every failure mode in autonomous systems that I've described a lot in what I've been writing, like the drift, the cascade, the instability under scale. Meadows named a lot of those decades ago, like not in a non-technical language, so it's really easy for people to pick up and understand. So it's an easy read. And the other one is from a similar vein. It's what's his name? It's The Infinite Game by Simon Sinek. Again, it's not looking at technical decisions or technical development, but it's looking. So Simon Sinek's look is more on teams and organizations, and how the organization that plays for an end goal is an organization that won't last, but the organization that looks at what they do as an infinite game that's constantly changing, and that's when we get back into the feedback loops, the drift, the cascades, the instability under scale as organizations grow. That's where they feed in, and it's not about getting to the goal, it's about consistently playing. And so when you understand the infinite game, or when you think in systems, you start designing systems that aren't about fitting the current requirements, but are about extending to what is this going to be in terms of configurable, extensible. We're meeting a requirement right now, but where is this system going? How will it scale? How will it be resilient? And this is where we go from application development into systems development.
Does that play into Conway's law a little bit too, in regards to how systems express themselves with the way that an organization is structured?
Yes, absolutely. So, well, depending on which Conway law you're talking about. So yes, Conway's law being that an organization will develop an application that's similar to its organizational structure. So yes, again, that's systems thinking. And so if you have siloed organizations where every team does something in isolation of itself, if they together as an organization build an application, it's going to have siloed components. And you can see this when you go from monolithic to microservice breakdown. All of the different domains are according to the teams that the organization has. Whereas if you're talking, there's Conway has multiple laws, so I'm glad you clarified. But yes, it does definitely relate to Conway's law of communication.
I'm going to have to read that one. That sounds super fascinating. Thank you. All right, well, let's get into the meat of the fireside chat in a way, right? Because you've been blogging recently that autonomous systems don't fail due to lack of intelligence, but because their authority, boundaries, and control were never designed for autonomy in the first place. What we call currently governance in AI is often just orchestration in disguise, right? So my first question really, although with five, they've really got the ball rolling quite well already, is in a world of swarm intelligence and multi-agent systems, where does the human in the loop actually sit? Is the human an operator, a boundary setter, or a fail-safe? Which I think a lot of people are going to be interested in knowing about from your perspective.
So from a governance point of view, a human is all three of those. And I am very careful to say it's not a human in the loop, because as soon as a human in the loop, as soon as you put a human in the loop, they are now a bottleneck of the system, and they're a often non-designed element of the system. So if I need to have all of the requests coming to me at human speed, that makes sense, right? I've got one request come in, I read it, I say yes or no, and then the system moves on. But when we start to scale, when we start to have the amount of requests that are coming in at machine speed and no longer human speed, the kind of patterns we see are people get overrun by the amount of requests coming in, so they don't even stop and read it anymore. They just copy 100, approve, copy 100, approve, and so they're no longer a validation point. So they're not assessing. So I was going to say a valid assessment point, but validation works. So they're no longer validating what the request is. They're just a bottleneck in the system that's slowing everything down. So 2 or 3, absolutely. Where I distinguish that in terms of human in the loop is human on the loop, because now the human is pre-designing the flow of the automated system, right? So instead of saying, I need these requests to come to me and then I'm going to approve them or deny them, I'm going to design the rules that govern whether these requests should be approved or denied, right? I don't need to sit there and read it and approve it and deny it. If I've designed the system that can handle those requests based on the rules that I've set, it can do it itself. And when it starts to scale, when the amount of requests come in 100-fold, 1,000-fold, 1,000,000-fold, they can continue to move at machine speed because you've pre-designed the boundary, you've pre-designed the rules that are required to understand what makes that decision safe. So that's human on the loop. And then the other one is, the other one's more contextual, right? I know I've had this conversation with you before, Paul. It's human as manifold. And what I mean by that is, it's the human in the middle doing the orchestration, which is the vibe coder, or is the systems engineer who's doing research on documents that exist in the system versus new designs that they've got. They are the point between creating something new. So the design is in their head, but they need to interrogate the existing system, whether it be through integration, or through document analysis. Now they are the manifest, or they are the manifold of the entire orchestration. So they're not a bottleneck anymore, but they are enhanced. What they could do in 3 weeks by manually going and reading everything, so it's in their context, in their brain, and then coming up with the design and interrogating the design against the current system, they can now do in a couple of hours, because you don't have to read 20 documents that are each 50 pages long just to have an understanding of the current system. You interrogate the current system based on, I'm going to apply some best practices and some proven patterns, and I'm going to interrogate it against the documentation that we have. Now, it gets even better, because now we can start to create agents and say, right, I'm not just going to depend on my documentation. I'm going to build an agent that can integrate with one of the test systems or one of the API endpoints that we have internally within the system. So now I can stress test, or I can go and do a query on a database, or I can do things in the system that's no longer about just investigating documentation or understanding the context, but now it's physically interacting with the system. And now I can still test my ideas, but it's me in control. So that's human as manifold. So that's where we are, again, serving a purpose that is beyond that of autonomy or automation, by it's us doing the invention, and it's optimizing our capability by getting rid of all of the time that it takes to write the integration tool, time that it takes to analyze the integration assessment, time it takes to interrogate the documentation or read it into context in our own brain. All of that is optimizing the human. And that's where vibe coding became super popular, because it took people who, some had no experience at all in coding, maybe some had a little bit of experience because they'd written some formulas in Excel, or others who wanted to get deeper into compilable languages and they've only ever worked with maybe Python or JavaScript. So they've got a basic understanding of,
yeah, for sure,
and going, oh, I need to compile something that'll run on a physical piece of hardware, like a Raspberry Pi, or I mean, you can still use Python on a Raspberry Pi, so maybe a bad example, but like an M5 where we require C or C++, right? And I've never written a line of C in my life, but I know logically what I want to build. It's now enabled by the human who is manifold, who has the creativity and just uses the tools for what they're good at.
Yeah, and I agree. I mean, I've definitely felt like I've learnt new languages without learning them. It's weird. It's so
Yep.
I've had Rust applications now developed that I've never touched Rust before. It's been a really interesting and empowering, but also very odd experience to go through. And I think from what you've just been talking about, I sort of want to draw the attention to the audience, if I may, around the dissonance that I had with Manifold and On the Loop. And in the loop, if you will. So in the loop for me was like, it's change management, and ITSM and ITIL historically had the roadblock of putting change control in place to stop production from blowing up. When you have autonomous systems working and making decisions for things like building new applications and deploying infrastructure on AWS, for example, using APIs, how do they do that autonomously, which is where all of the on the loop comes in your architecture. Blogging is all kicked in around how governance can work with that. But then most of us experience AI still around interfacing with an LLM through a tool such as an IDE, and how Claude and Claude Code works with, and more recently Obsidian, etc., within our own personal sphere. And I had mixed and blended the two a little bit too much, where I was trying to understand the concept of having an agent swarm as part of my personal assistance landscape, where I could spin up a factory of AI that would, like the open claw concept, I suppose you could say, that could help me, versus having an agentic platform running in AWS on, say, something like Agent Core that had an orchestrator and autonomy that was working to the benefit of my company. And I was confused by that in that sense, right? So being able to sort of say that human as a manifold, is more around the personal assistant and the landscape of using IDE has helped really shape my thinking about how I can leverage AI as a result. And then within the construct of the platform, having human on the loop is allowing autonomy in an agent swarm. That one, though, for us in your blog things, like if you've kind of argued that you're retrofitting AI into an old procedural workflows, right? So what's the fundamental difference for you when you're building automation, like doing things right versus building for autonomy and doing the right thing in that platform?
So there are going to be people that disagree with me because they come from different lenses or different backgrounds and different point of view, right? But applying a systems lens, so applying a embedded and control systems lens, this is where I come from, is the environment around, we've been building autonomous systems for decades. We have autopilot in airplanes. We have autonomous vehicles that have been running in mines for decades. The autonomous systems that people are talking about now as agentic AI is, yes, the LLM has brought with it additional reasoning capability that didn't exist for these embedded systems that we've been building for decades. We did more deterministic rule sets, and we still had reasoning for specific models because we have algorithms. Like if we need to understand tree traversal and we've got so many nodes that we need to get through and we need to figure out what's the most efficient route, I'm not going to use an LLM to do that. So we have ML models that we've designed specifically for specific patterns, right? So that's what we use when we build autonomous systems. But when we get to the difference between automation and autonomy, it is the automation is really just the control of steps, right? So when we're in business systems, when we talk about business automation, we're looking at, here is a flow that humans have done, right? So I receive an accounts billable. It goes to a payroll officer. The payroll officer assesses the account and says, yes, they're a valid account. So these are steps that we can automate away and say, well, a lot of this is just a human doing lookup and looking at a system of record and then validating that the request is valid and then checking that, you know, has the other department which did payable already paid it or not? These are things that are deterministic. And so they can be explained away in rule sets. And so that's automation. So we are automating the control of steps. So we're controlling steps, and that's where we get orchestration. So orchestration is now, I have, and when we get into event-driven systems, we talk about sagas, we talk about different patterns, but ultimately we're talking about the control of a step, whether it's through orchestration or choreography, which is still predefined. We're saying, based on this rule, this step will happen, and then this step will happen, and then this will happen, and that will get to that endpoint. Whether it's through an orchestrator saying, step one, you do your thing, and I'll wait for your response, and then I'll take it to step two, or it's through choreography, and it says, step one, you do your thing. When you're finished, send an event, and step two will pick it up and fire it off, right?
Yep.
That's pure orchestration. That's the control of steps. When we get to autonomy, now we're talking about something very different. It's not understanding what is the step that you need to take.
Right.
It's understanding what authority do you have to make a decision. So autonomy is the control of authority, not the control of steps. So as an example, the one that I use through my series, because a lot of the financial industry are the customers that keep coming and asking me questions, so I apply it to their industry, is you have a payment agent, right? So you have a payment agent that handles refunds. And so a request for a refund has come through and the payment agent has gone, yes, I can do this. I have the authority to make payments up to $500. Anything over $500, now we're talking about a boundary. That's authority. So up to $500, I can just go ahead and approve it. If it's over $500, I need to escalate this. Do I escalate it to a human, or do I escalate it to another system of record that looks or investigates? That's where we start to get into what we call an authority graph. So it's looking at the jurisdiction of pairwise or individual or system-wide controls on what an agent or multiple agents have the authority to do. But in a non-authority, like autonomous system, if we also have our fraud agent sitting there going, I'm just going to look at every request that comes through and I'll flag requests that look fraudulent based on what I know. And so when the request for a payment under 500 comes through and the payment agent goes, yes, I'm authorized to make this payment, and the fraud agent goes, this is a fraudulent transaction.
Yep.
And then which one has the authority to do what, right? So
is that where the 4 questions of authority also kick in for you?
Absolutely.
Yeah.
So why that's where it comes to, right? So if we're implicitly, and this is what businesses are doing now, OpenClaw is a great example of this. OpenClaw has no governance control at all. It has minimal security. It is all 100% coordination. It is a very well coordinated application, but it's all coordination, no governance, very little security. And what it's doing is it's just saying, I can do. It's not saying I have the right or I have the authority to do. And therefore, that's when we get into pairwise, right? So understanding the fraud agent in an orchestrated but non-governed system, the fraud agent might say, hey, I've flagged this as fraud, but the payment agent, because it's under $500, it's already taken action. So the payment's already gone. What do we do? Like the boundary was implicit. It wasn't explicit. So it said, I've flagged it as fraudulent. Well, it's too late. Do we claw it back? Do we go to the customer and say, oh, that was a fraudulent transaction, we won't pay you next time? I don't care. I've made $499. So it's the explicit graphing of the authority to understand in different situations who has authority. So
it's almost a little bit like you got 2 humans in front of you teaching one to fish or giving one a fish, right? Orchestration's told what to do, paint by numbers. The other is actually got a brain that is now going to be given the flexibility to understand how to fish and then make its own mind up how it's going to do it.
That's a great example. So you would say that somebody who is told to go and get a fish doesn't have authority. The only authority they have is to action the task that they've been told to do.
Yeah.
The person who is taught to fish has the authority to bait the hook, cast the rod, reel in the fish, bring the fish to you, right? Now that's autonomy because you've taught them how to fish. Now go away and do it instead of go and get a fish.
So another way that I'd sort of been framing it with my friends that I've been talking to around these concepts is that you can look at it like a cell, a bubble, and the membrane around the cell is the definition of the architecting of autonomy, what gives it its constraint, its authority, its boundary, and then it can act in its own way, in its own deterministic way, right? Yeah, and then essentially what you've been blogging about has been fascinating in the sense that, because you're just talking about it before, you have a fraud agent and a transaction agent, another one. You've essentially got all these little microorganisms coming up on a petri dish, and they're all working on the dish itself. What I found interesting, you talk now about when they start to collide a little bit, there's this seam in the middle on how they interact. Can you dive a little bit more into that?
Yeah, so that's a good start to the example. Where I'll take it though is, this is what we call jurisdictional boundaries, right? So in a governed system, those 2 agents, that's a little bit easier to work with because we can say, I own the system, I own the outer boundary of this system. I'm able to set the pairwise decision between the 2, right? So it's a graph that says when these 2 meet and they have a disagreement, the arbitration of that disagreement is the fraud agent will take precedence. So if it flags it as fraudulent, the payment agent won't make a payment until it's been escalated for investigation. If the investigation passes as no, it wasn't fraudulent, then the payment is made. So that's the jurisdictional boundary within a known system, right? It's easy to do. Where it gets harder is when we have the jurisdictional boundary. So we call it the seam between 2 systems, right? So the seam between 2 systems whose jurisdiction takes precedence.
Yep.
So I have a system and you have a system. My system is designed to do what I've designed it to do. Your system is designed to do what you have designed it to do. 2 of the agents, one on your side, one on my side, are interacting with each other. Each have authority within their boundary. Whose boundary takes precedence when those 2 meet? Now, the only way we've solved this is through law. We do this every day in global markets. We do this every day in political situations. We're doing this
Right.
right now between two countries over in the Middle East, right? There is a precedence for this, and so this is where I like to use law as an example, because when you're at pairwise within a known system, that's easy, yeah. So they both have hierarchies, they both have rule sets that say, well, I'm only valid for a certain time, so that's another boundary is time. I am only authorized to do up to a certain value. So there's different boundaries that they can do within that system. But then we get to, you would call that the local system, right? That's the local government or the local court, right? But if those two systems are disparate, so they have a seam now that's two different local boundaries that have their own governing systems, then we have to go to state, yeah? So the state boundary is the state court. And then again, federal court. And then again, if you have to go to world court, then you've probably done something really bad. But it's a jurisdictional boundary. Now, if the laws aren't written in terms of the precedents, then you have unwieldy systems, right? There's no jurisdictional, there's no, what do you call it? What's the word? When you negotiate, there's no jurisdictional negotiation, right? Without the rules that say, all right, you are authorized to negotiate, yeah, and you are authorized to negotiate up to and of on the authority of this system. And system number 2, you are authorized to negotiate up to and of the authority of this system, and then you will come to an agreement. And so that's when we get to monotonic reduction, right? So this is more so in control systems, but this is why I've started writing the second arc or the second series, which is more an implementation, which I call the Serverless project, which is based on some of the work that I was doing with defense on drone swarm communication.
Yeah, drone swarm. Yeah, I was going to ask, because I mean, it sounds all this jurisdictional stuff is very rigid, and you have a post around the drone brain, right?
So architecting autonomy series is conceptual, right? That's the main arc that's teaching people about the governance and authority of systems, or governing and providing authority to and delegation within systems.
Yep.
Serverless concept is a implementation of that series. So it's going through now and it's talking about, well, how do we apply this in a real world situation? And instead of doing something approximating in business systems, I thought, okay, well, I'll work with what I know. So I've built it in drone systems. So in drone swarm intelligence, when we have two drones, right? So we have algorithms for sensing, we have communication protocols between drones. We understand when they're, within their sensory that they can see each other or sense each other. By see, I mean, it could be visual, it could be LiDAR, it could be radar, it could be different sensory. They are all, with Mavlink, they can communicate across each other. With DroneCan, they're communicating with their sensory. So everything's super fast. It's hundredths of a millisecond in processing, right? When the companion computer has a task, right? So I won't go through the levels of the brain or the architecture, but there's a computer that sits on a drone that is doing all the compute, right? So when they have a task and they have the authority to do that task, but when two drones have the same authority and have a similar task, but now their tasks cross over, they have to negotiate with each other to understand, where do I stop? Because if they don't, they're going to collide into each other, right?
Wow, and that's going to happen super quick.
Create a physical issue. So we call this monotonic reasoning, right? So they go down to what is the single most thing that they can do where their boundaries no longer cross. So once they're at that monotonic point, or at their singular unit of task, now they can each operate safely without crossing each other's boundary. Now, on top of that, there are algorithms and rules that govern the jurisdiction and or the reallocation of tasks within that seam or within that boundary that says, all right, if you've done your monotonic reasoning, you've gone down to a single unit of task and you're both not crossing each other's boundary, but at the seam, you're now missing something, then we need to do something to resolve that, right? Because you both need to complete your task. So there could be some level of predefined rule set that says, once on a time boundary, you've achieved this on that side, you're going to swap sides and now come and do the same task from the other side. And that may achieve what it is that you're trying to do. It could be something as simple as LiDAR mapping, right? In a certain area, and they can't fly within each other's region. One's doing LiDAR, one's doing heat.
Right.
So you're not going to get heat from the other side or LiDAR from the other side. So now after a certain time period, swap and go and do it. So that's a simple example of monotonic reasoning and then providing additional resolution or arbitration between those two drones in an automated fashion. So I'm not sitting there instructing the drones from the control center to say, oh, once drone 1 and once drone 2 have finished their task and done that much, then swap. They're sorting that out themselves because the boundary has been written into the software. So that's authority architecture.
So that's almost a mindset of rewiring itself on the fly too, though, right? So its original construct is reshaped on the fly, or not?
Rewiring, no. So it's still at the end of the day, the same task needs to be achieved, right? Drone 1 is told, I need a 360-degree view of this area. It could be 20-meter area, right? Or if to make it more crossing over a boundary, let's say within a 5-meter boundary. And these guys are big drones. Now, when I talk about drones, I'm talking about UAVs. I'm not talking about like the small
the hobby ones,
hobby drones.
Right.
The series that I'm writing for now is bringing that down to the commercial drones. So quadricopters and stuff used for like line inspection or gas well.
Right. The big ones. Yep. Putting out fires on skyscrapers and stuff like that. Yep.
Yeah, exactly. So they're not the fixed wing, UAVs that from the past, but it's still the same principle, right? So in that context, maybe you've got 5 meters, and each of these drones is maybe a meter in diameter. So then within a 5-meter space, if they've got to get around, they're going to collide into each other. So in that respect, it's not changing or rewiring the task. They have the same task. I need to get a 360 view of this area, and the other one too. They're doing the same thing, but it's based on this specialist task. One is a heat mapping, and the other one is LiDAR mapping, right? The same thing applies. It's more, how do I get to that endpoint, right? In the same way that we talk about LLMs doing probabilistic reasoning. So I have a series of tasks or an objective that I need to achieve. Here is a series of tools that you can use. How do I do it? And then an agent using an LLM goes away and starts reasoning and saying, here you go, use tool 1, use tool 3, use tool 4 in that order. That's the same thing that we're talking about. So it's
right. So this is your hardware-centric model of sense, think, and act, translating into complex cloud-native enterprise software, right?
Sense, think, and act. That's not new. That didn't come with LLMs. We've been doing the RPA cycle in control systems since 1970, since the 1980s. So this is where I if you want to know a little bit more about the history, I wrote a series of prescriptive guidance on agentic AI in 2024. If you just Google AWS agentic AI prescriptive guidance, you'll see a series of, it'll take you to a page where there's a series of prescriptive guidance. Look at the foundations of agentic AI. There I talk about from 1959, where daemons were first theorized, right? Mathematically. Then we went into the actor model, and then from actor model we had RPA, and then from RPA we've gone into different levels of reasoning and different levels of intelligence.
Yep.
We've been doing this for decades. So when we talk about control systems in this respect, the sense of the environment, the reasoning of what to do in that environment, and then the take action on that environment, this has existed in other forms of ML or other agents. I call them software agents because that's what I've been writing most of my career. No, I haven't been using LLMs. I've only been using LLMs in the last 2.5 to 3 years, right? Because that's now the relevant model. But the architecture has remained the same.
Yeah, that's crazy. Hey, I'm going to take us back a little bit because I'm cognitive. I mentioned something about the 4 questions authority earlier. So I was just wondering, because in regards to helping all that coordination occur, can you walk us through what the 4 questions are and explain why a system that can't answer them is effectively governed no matter how well it's orchestrated? Well, ungoverned.
Are you talking about in the formal authority graph? Because I've written a lot in the last 3 months, and I've posed a lot of questions. So, which specific questions do you mean?
Are you going to answer? You're going to ask me a hard question.
You're talking about the authority units?
Yeah, the authority nature of it. Yeah.
Off the top of my head, I'm just trying to think. If you've got the questions up, you mean you're identifying domains, implicit authority?
No, I don't have them up. Nope. Nope, I don't. So that's a pain in the butt, and that's not helpful to this. So sorry about that.
So maybe you mean autonomy units through delegation, composition contracts, constitutional hierarchy, monotonic reduction, and I can't remember what came out. Compositional hierarchies, compositional reachability. So that's the higher. Is that what you're thinking, or are you?
Yeah, well, it's in regards to every component answering themselves 4 questions regarding their authority. So, and then if they don't answer those 4 questions, they're not effectively governed, no matter how well the system's orchestrated. Does that trigger you? Because I didn't actually find the 4 questions, no. Right. How about ask another question? We'll go a different way. Let's reset to a new topic. So you've made the provocative point that technical debt and AI systems become drift. How can organizations measure their drift tolerance, and at what point does autonomy become a liability than an asset?
How can they say that last bit again? How can they measure what?
How can organizations measure their drift tolerance, and at what point does autonomy become a liability rather than an asset?
Yeah, cool. That's a very philosophical question, right? It is not an easy question to answer. In terms of when it becomes a liability, we're now getting into so the architectural constraints around cost, around. So when we talk about feedback loops, when we're actually getting into the implementation architecture, it can become a liability, not reliability, a liability when it takes us, again, this is time bound, cost bound, all of the actual implementation understanding. We can keep going. If you look at, I'm just trying to think of, I explained it in one of my articles, so if you want to read it, the boundary paradox. So in the boundary paradox, I was explaining that the levels of hierarchy continue n+1, exponentially. As we solve for one layer, there's another layer, there's another layer, there's another layer, until we decide where the n stops, right? And so that could be cost. So understanding from one business point of view that we don't have a finite, budget to then just spend as much as we want on token consumption or compute or the actual physical constraints that these engines run on, right? So when we're talking about drones, they have a power and weight bound, like their constraint is the word I was looking for. They have a power and weight constraint, so you can't operate without understanding how much power draw is a sensor going to do, or how much does the sensor weigh, and then how much does the CPU draw, and then how much, based on the sensor. So there's constraints there. In business systems, it's quite different, right? So now we have constraints around, again, security and authority. So what boundaries am I allowed to cross in terms of authentication and authorization? Again, one of the liabilities here is, if we talk about no governance, then again, OpenClaw, I love it because it's given me a great example. If we were to put OpenClaw in an unbounded environment and say, all right, you have access to everything, that's a liability. Not for just sitting there and doing nothing, but the potential harm that it could cause based on having access across any auth N, auth Z, or any execution boundary is exponential, right? But if we start paring that down to say, all right, we're going to start adding layers of governance on top of that. Now we're getting into, well, now we have to start restricting what we can affect in terms of our systems. What's our system boundary? What do we have? Are we allowing it to interact with our payment system? Probably not. Let's cut that off. Are we allowing it to interact with our system of record? Yeah, we'll give it read-only access. So now we're starting to talk about the functional boundaries. And so the more that we add the governance layers, the security layers, and the layers or the boundaries around control into the system that we're building, it constrains the capability. But on top of that, as we start to open up those boundaries, now we start talking about, as I was saying before, the token consumption, the execute cost. If we just thinking of there's another level in there as well. If we think about the current governance systems that most organizations are producing right now, what they are is actually a quick acting audit system. So instead of precognition, so instead of before going to reasoning, so before the model goes and makes its decision, it's actually post decision. So it's saying, okay, I've made my decision, go and action this. But most governance layers at the moment are saying, no, you're not allowed to take action on that. So we're actually consuming tokens for no reason because you've got to a decision that you're not allowed to make. And so that's a liability, because now we're going to have to go back and say, think again. And then it'll come back with option 2. Do this. No, you're not allowed to do that. All right, go back and think again. So if we're not governing from precognition and we're doing, post brain before hand takes action, then we're going back to the brain too many times before we can actually take action. And so that's now a liability on both, not just token consumption and execute, yes, but also now time bounds. Because if we have a specific time frame, like if we're talking about low latency systems, then we can't execute in a low latency system. And by that, I mean, like, if you're talking to an agent on a phone, you expect a specific, time for it to respond. You're not going to sit there and wait for 5 minutes until it comes back and says, oh yeah, we can do that for you. It's like, well, why did it take you 5 minutes to say, yes, you can do that for me? Because it went through 5 or 6 cycles of trying to answer, and then it was told no, and trying to answer again, and it was told no, until it got to its response. So it's not going to work in a low latency system. So when we talk about governance systems, and when we put them at the right layer, so if we're talking precognition, so now we're saying, what am I authorized to do? So that what am I authorized to do is not a matter of can I do, it's what am I allowed to do? Then the decisions that it makes are actionable when they come out. So now it's, you are authorized to make these 3 decisions. You can probably, capability-wise, do 10, but you're only authorized to do 3. So the decisions that you make must fit within those three decision boundary. And so when it comes out, you can immediately take action. So now we have a faster, we call this decision advantage. So now we have a faster system that can respond to intent. So it's still intent, it's still human, natural human, or it could even be system to system, but it's handed through in a natural language intent. It's then, it runs through an authority graph, or it runs through the jurisdiction that it's allowed to take action in, makes the decision based on whatever the intent is and whatever actions it's authorized to take, or what decisions it's allowed to make, hands it off to go and execute. The execution is done. There's no rework. There's no additional chain of thought, if we put it back to traditional or Anthropic's workflow patterns that they put out when we first started getting into LLM workflows. The chain of thought is literally that, make a decision and then come back and verify that decision, and then come back and verify that decision until we get to our final decision.
Yeah, because we're worried about the hallucination of the system, right? So there's got to be some governance gates in there to evaluate that, surely, so that they've got some boundaries within their own power.
Exactly. So we have model guardrails, right? You go and use Bedrock and you turn on model guardrails, and you've got precognition guardrails. So these are things that the model can do. You've also got postcognition guardrails. So things like what do you call it? Negative prompting. So don't say this, or you can't talk about that subject. It's restricted from those during its decision-making process. That's precognition governance. But things on blocking what comes out. So it might be, oh, you can talk about a recipe on on how to make spaghetti, but you can't talk about a recipe on how to make a bomb, right? So it's going to generate what it thinks it can do, and then the filter is going to catch it and go, nah, you can't do that. So that's post-cognition filtering, right? So there's on both sides, but that's at the model layer. So you can apply guardrails at the precognition, which is going to restrict, what it's allowed to think about, or what it's allowed to do during its thinking process. But then that's not necessarily authority as well. So there's multiple layers of that governance that say you can think about these types of things, but are you allowed to decide that you're allowed to make a refund, or are you allowed to decide that you're allowed to flag this as a fraudulent transaction? That's different from the actual content filtering.
But we wouldn't just use Bedrock guardrails to help define that, though, right? There'd be a bunch of
guardrails
potential.
One layer, yes.
Yeah.
Yep. I don't want to do the plug on my architecting autonomy, but I'm working towards,
by all means,
right? So I will eventually, I've written the code. Everything that I'm writing about is not theoretical. So I've gone and implemented it. I have different customers, different AWS customers with my code that they've taken and modified, and there's different people. It's not, hey, here's my code, just use it and trust me. It's they've tested it, they've made it their own. They go and add their own flavor to it. But there are, so I'll call it flavors. There's flavors of my code out in the world, right? So it's tested. I'm not going to write about something that theoretically should work without actually testing it first. So where I'm going is the reason I've written the series in the way that I've written it is, in the past, I just came out and said, bang, 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 here it all is. And this is the AWS prescriptive guidance. And I got a lot of people coming back saying, well, this is too much, I don't understand. So instead of doing that, I've said, right, I'm going to step you through this. Let's first understand that there's a problem. What is that problem? And so the first 3 articles are just defining the problem. And then after the 3rd article, we're like, all right, now that we understand that we have a problem, let's get deeper into that problem. And why does this problem exist? So now we know what the problem is and why it exists. Then we get into, how do we solve this problem? Now we're at the conceptual, how do we solve that problem? We're going to start moving into, all right, how do we implement this?
And would you say, when you're implementing it, in the landscape of the teams that have already built, say, traditional microservices, what would their first practical step be towards architecting for autonomy without throwing away all their existing infrastructure? Or is it a matter of throwing it all away because
No.
it has to be different?
Yeah, by all means. It's not. It's a new way of thinking. It's not a. You don't throw away everything you've already got, right? Like, as I said, this I'm writing it for a new audience, but this is stuff that we've been doing in control systems for decades. So it's just applying a new way of thinking and a new lens on things. Most people in applications, most people in business systems, and I use the term most, maybe too broadly, but a lot of people, they look at things in terms of function. What can I build? What can this system do? So I build a function. We do behavioral driven development for that reason, right? I'm given a task. This task must achieve this function. I go and build that function. Nobody ever asks the question, should we? It's always, can we, right? So all we're doing is we're flipping it up and saying, right, you've got a domain-driven design, microservice environment. You've got 100 different microservices all doing their thing. I'm not going to be a salesman and say, yeah, let's turn each and every one of those services into an agent and sell you in my models and sell you in my framework, because that would just be stupidity. What I would say is go and look at your domains first. What can we do in terms of simplifying those domains? If some organizations break their domains down too granular. Some organizations keep their domains too far reaching, so they cover too much, right? So it's looking at it from the point of view of not what can we do, because you've already done that. All your services are doing what they can do. It's now looking at it from the lens of what should we do? What are we allowed to do? And now let's break it down and say, well, if we're allowed to transact on a payment system, maybe let's move all the logic, all the microservices that can transact on that system into one domain. And so we're reforming a domain on governance now instead of functionality. So capability, great, we've got it. Now let's look at how do we constrain that set of functionality. And now we might be looking at, so that's step 1 is understanding the existing boundaries. So when we talk about domain-driven design, your domains are your boundaries. So looking at those boundaries, maybe redefining the boundaries based on different conditions and based on different properties of the system from that different lens on should we versus can we. Then we get into understanding the individual components, right? So we've talked a lot about automation and autonomy. So instead of having a service that does, a payment service that takes a transaction, it may take a request to just do the transaction, right? We might take that as a function of an agent. So now we have an agent that can do multiple tools. So that service might end up just being partially a tool, and then the logic that's currently in that deterministic service may be blown away for the logic of the agent that then gets taken over to orchestrate all of the payment functions. So I'm not by any means, I'm just trying to pick something out of the air, right? I'm not by any means saying this is how all agentic systems should work. I'm just saying when we start to define or redefine existing systems, especially from a microservice environment, we're just redefining our boundaries, redefining our function now from the lens of what should we do or can we do, not should we do or should we not do versus what can we do and what are we capable of doing, because we have the capability there already. And then it's much easier when we come from a monolithic environment. So if we're actually changing something that's not microservice already, it's a lot easier to do your domain-driven design breakdown, because now we're looking at areas of logic and breaking those into domains, instead of when we originally did our microservice breakdown using domain-driven design from that monolith into a microservice environment, which gave us our existing boundaries, which, going back to what you said at the very beginning, when we talk about Conway's law, 90%, 99% of organizations who have built a microservice environment, their domains are structured the same way that their organization is structured.
Right.
So communication boundary, so that's one boundary of a few. The communication between each of the domains is the same as the organizational structure that built them. And if
so hang on, just to be clear though, are you saying that it's going to be much harder to build in agentic governance for a microservices environment because they're so much more loosely coupled?
Yes.
Versus monoliths, as you just literally said?
Absolutely.
Oh,
Yeah,
that's
because
fascinating.
Contesting with, and it's not just technological, right? It's convincing the architects of old who have designed the domain-driven design principled system to say, all right, I see what you've done there, I love it, and now I want to get rid of half of your integration boundaries. And oh no, we need those integration boundaries. Yeah, we'll still have boundaries, but they don't need to be so, mono unit, right? We can it's not monotonic reduction of deterministic systems, it's monotonic reduction of non-deterministic systems. You've already got a unit of work. Maybe it's 2 nano service or 2 micro for what an agentic system might be.
So if someone's gone and made one service completely nano where push delete's been separate functions, it's way too granular. You'll pull it back up another level and then maybe even up another domain.
Yep.
Yeah, okay, well that's interesting.
I'm going to say, again, coming from a control systems point of view, agentic AI is not the answer for everything. Just because you can put an LLM in it, and this is what I was saying at the very first, I don't know why I'm pointing up, but it was the first question that you made.
Yep.
The very first question was, what is one of the most overhyped trends at the moment? And that's where I'm saying is agentic AI as a product category. Because if you're selling agentic AI as a product, then all you're thinking is, I need to put an LLM in everything. And now I have an orchestrated microservice environment, and I'm removing the machine-to-machine REST or graph or whatever technology you're using to integrate between the services and putting a natural language barrier between them and having an LLM interpret. Like, that's not going to serve any purpose other than the consumption of tokens, right? So the salesman who sold you those models is laughing, but the actual architect who sits down and says, you know what, you've got a whole lot of deterministic logic here that makes sense, keep it. And maybe we'll put a supervisor agent in charge of orchestrating between some of these services, and that may make things more efficient from a systems point of view, but it may make things more complex if we turn everything into an agent. And so that's not what we want to do. We don't want to over-complexify, if I just can use that word. I don't think that's even a word.
No, I really like that. And I really like the fact you call it out properly too, because like the RPA, the robotic process automation of certain workflows and orchestration doesn't just disappear. I agree with that. And I think that's part of the hype problem, right? Oh, we must replace everything with AI. No. You should stop and have a check as to whether it would be beneficial to do so or not. And then I think for me, I suppose I think we're pretty much nearing up in time. So when I was going to close out with you with a question around, can you name, what is one architectural anti-pattern you see most often when companies try to implement agentic AI today? And it kind of feels like a stupid question now, because the answer is probably they're not.
I think we've already talked about
autonomy, right? But would you say, how do you see in your position where you see so many customers today, would you say that people are understanding that general paradigm around not hyping it up and replacing? And if they are replacing, how well are they getting to production these days? Are we using AI properly?
Not yet. There are maybe a rough statistic, 5% to 10% of enterprise organizations are using AI to its full potential in terms of not treating it as a supervisor agent that literally just coordinates orchestration. So when we get to the capabilities, like when we get into swarm intelligence, you'll probably want to have a chat with me once I release a couple more of the articles that I've written on drone swarm communication and the intelligence living in the network instead of in the actual drone itself. When we get there, happy to come back and have a chat. But it's understanding the capabilities of what AI can do. There's still too many people overhyping. Oh, it can solve everything. It's like a general intelligence. It can do everything. Well, I'm not going to say that every edge or every frontier model is capable of doing everything, and I'm not going to say that every custom model is not capable of doing everything. What I'm going to say is each model should be trained for its purpose. And so I don't use frontier models for specific jobs. I distill models, or I build new models specifically for a task that is trained only on that task. So there is no chance of hallucination because it only knows how to achieve that task.
Yeah, it's crazy.
So now we're getting into SLMs or small language models. So they still have the language capability, but they're not going to be providing you, if it's the difference between how do I maintain a Mustang? Well, if I'm asking an American model, it might tell me to feed it sugar cubes because a Mustang is a wild horse. But it also may tell me, well, is it a V6 or is it a V8? Yeah, it's a car, right? So
this is where it's going to be really fascinating, where it's all LLM at the edge or SLM at the edge, and we'll be able to run AI on our phones, for example, and be able to have all that.
You're seeing people like Anthropic already starting to do that even with their the Claude Enterprise or the Claude AI. It's no longer one model, right? They've got
a financial one,
Haiku sitting as the main model for standard everyday task. But as soon as it needs more deep thought, it hands it off to another model, right? So this is where we're getting into models fit for purpose in an agentic environment. So now we've got perceive, reason, and act happening at multiple layers within now an application environment. So organizations themselves, once they're still far from understanding the potential of agentic AI in autonomous systems. So not in using AI as tools. So yes, many organizations have already swapped out their tool sets for using agentic IDEs and Claude Code and Codex and all the tools that are available. Great, they've already found efficiency in optimizing their developers. But then as these models start to improve, and Mythic is coming, right? As these models start to say, well, we don't need humans to guide us on building out an entire application anymore. Those developers need to shift and understand, well, how do we now marshal these agents into autonomous systems? How do we get them using their own feedback loops? How do we get them learning from the task that they're doing to improve the task over time? So now we become, orchestrators of AI as opposed to developers. So we still need to have the technical knowledge, but we need to shift our understanding of that knowledge to understand how we harness or marshal or coordinate multi-agent systems where emergent behavior is a property of the system that we use for feedback. So again,
I know that was my last question, but I've got another question now. But does that kind of mean that we'll be seeing a little bit more fervor around LLM development itself? Like the SageMaker service for me is not something that's leveraged by many people outside of the PhD landscape, right? And then the whole ML ops and the pipeline to go and, you've got a new data set, go and run it through a pipeline to make a new LLM. With the conversation you were just talking before about having an LLM specific to a purpose, say, I don't know, detecting cancer in a cell. Are we going to see a lot more of, do you think, in future around having pipeline generation for LLMs that are distinct on those kind of outcomes?
Yeah, we already are. In that 5% that I'm talking about, that's how it's happening, right? It's not, hey, we have a frontier model, we're just using that and we're tweaking it to fit for an agent. It's actually agentic platforms that have the deterministic logic that is redefining which model it uses based on an ML pipeline that goes and rebuilds a model based on a learning feedback. So as you apply observation, auditing, and feedback loops to the actual action and can bring that back in and learn from it, why would you, like when we talk about standard business systems, like we released Agent Core with Agent Core Runtime and Agent Core Memory, and as you're executing on Agent Core and you're feeding into Agent Core Memory, your model is going to learn in context, right? Because it's storing summarizations of what it's done in context. that's a small example of where we're going, right? If you're starting to do continuous pre-training based on a lot of that feedback coming in, you're refining that model specific to the domain that it's operating in. That is no longer a frontier model. That is now a model that's fit for purpose, that is learning to achieve a task over time that's becoming more efficient. And so now that's the deterministic end of agentic AI frameworks married with the non-deterministic end of models and the ML ops pipeline of continuous pre-training.
That's blowing my mind, as usual.
And so if that's blowing your mind, then we're about 5 years away, 3 to 5 years away from that being mainstream, right? So this is the stuff that we're playing with, and the 5% early adopters who are getting in there and pushing the boundaries, this is what they're building. And so this will become mainstream for organizations as they see the proof of that 5%, and as they realize that there's more to just asking a question and getting a response. It's not a chatbot.
Right. Well, I also want to thank you so much for taking the time to come and chat to us and critically hit me with further information. Sorry for the brain fart halfway through, but
You're right.
I feel like we've got a massive amount there.
Offline, tell me which questions you were thinking, and I'll give you the answer. You can write it up.
Yeah, I'll go find them. Yep, sorry about that. It was brilliant. You're a master in your craft, and thank you so much again. It's been awesome. And also, I guess this is our final session for the day. So I'll run a quick thank you to everyone on the committee for helping organise and all the other speakers today. It's been absolutely fantastic, and it's been another successful conference. So thanks, everyone. Brilliant. I'll hand over to Mike.
Thanks for having me.
Thanks, Aaron.
That was a fantastic fireside chat from Aaron Seff, interviewed by our very own El Presidente, Paul Dunlop. My name's Mike RT, and we are going to sign off now with a closing karakia. And here it is. Haki roto, haki waho, kia tau te mauri, e kōkiri nei. I ngā piki me ngā heke, ko te rangi Māori e tāku, e rapu nei. Tihei Mauri ora. Thanks for coming along to the AWS Oceania. Here's the credits. And I won't sing again. Catch you next time.